Mic check, mic check.
It's working. It's working.
Okay, it's working. Nice.
Sorry, just let me. C, E, 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 A. Ok, 1, 2, 1, 2, C, 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 E, A. Ok.
1 2 check, 1 2 check, check 1 2, 1 2 check, 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 check 1 2, 1 2 check, 1 2 check, check 1 2, 1 2 check, 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 check 1 2.
Dois, um, dois, um, dois, um, dois, teste. Um, dois, um, dois, um, dois, três, quatro. Um, dois, um, dois, um, dois. Teste. Vocês estão a receber sequer o sinal? Um, dois, um, dois, um, dois. 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 Estou a falar, um, dois, bom dia, Cascais, 2023, Splash, IBM, um, dois, um, dois, um, dois. Um, dois, um, dois, um, dois. Ok, parece que já estão a receber sinal. Sorry?
Can I just?
Yeah.
I can keep doing the mic check if you want. I'm just gonna try and get my output to show. But yeah. This is my mouse. Okay. Okay, this works actually. Huh. Pretty seamless. And this also works. Okay, cool. Should I unplug this and leave? Okay.
So the HTML. Oh. Hello. So the HTML. Oh yeah, this side. I do. Yeah. Goes in there. Now, I want to use. Can I just mirror as well? Is that okay? Yeah.
I hope it's going to be interesting. This is my first time presenting something since my Oh, right. I'll just double check.
Yeah.
No,
Sure, and I just want to check this. Actually, I'll just. I don't want that. Actually, let's see. Yeah, I just want to mirror. So. Okay, now it's mirroring. Okay, thanks very much.
Hello, hello. Okay. Oh, yes. This is a gift from Alex Russell. Can you get my laptop up on screen? Oh, hang on, it's probably duplicated. Oh, I have too many screens apparently. Displays. How do I get you over to the other? Little baby one. Hey everybody, while we're just letting people arrive, we're going to do Q&A via the Discord, so if you're not already in the Discord, this QR code is an invite link, so you can get in. And there are separate threads for every session through the day, and there's an overall thread for the workshop. So we're going to try and do that, and that way remote people can participate in the Q&A, and we'll do some discussion sessions between things, but this way also if you ask questions there and we don't have time to get to them, the presenter can follow up at any time in the future. Should we begin? Sure. All right, this microphone is very low for me and high for you, so we'll work it out though. Hi, welcome everybody to the 2023 9th workshop on live programming. I'm Peter Van Hardenberg, I'm from Ink and Switch, and this is Jun Kedo. And we're your co-chairs today. I'm going to let Jun do a little intro for us here.
Sure, thank you. So, well, I think most of you already got the concept, but this is a workshop about live programming. And live programming is really about making program environments live, and also structured, tangible, and concrete. So we'd rather make the program environments more interactive and allow programmers deal with these concrete stuff rather than not only tweaking these abstract concepts, but actually touch on the concrete outcome of these programs and edit it interactively. And then this is a workshop. As he said, it's 9th edition, but actually I think it's already 10th year. And it started in 2013 as part of the XII, which is a conference for software engineering. And then we moved to ECOOP, which is an object-oriented programming-related conference. And then we are doing this in conjunction with SPLASH for several years. And then it's really about this, making this interdisciplinary venue, not only for programming language people, but also for software engineering, computer science education, and human-computer interaction, and art, and what else, which is relevant to programming activities. So it's really a venue for people who love to deepen understanding on the programming activities by building novel program environments by themselves. Yeah, actually, this year we made several changes to improve the workshop structure and workshop quality. We actually this year asked all the reviewers to provide kind of lengthy, or it's really a detailed feedback to the authors of the papers. For authors, I think you noticed that you already received 3 high-quality reviews, which we were really proud of. We really want to thank all the program committee members who contributed to that. And this year, the program will be a bit more interactive than the previous years. We don't have the keynote this year, but instead, the program will look like this.
Okay, here we are. So we have an awesome program. You can see there are going to be a few remote talks in order to make sure that our friends presenting from the west coast of North America, thanks, are able to participate more awake. They're going to go at the end of the day. So we'll have more remote talks towards the end of the program. But we're going to see creative programming. We're going to see sort of theoretical computer science work. We're going to see some built systems. It's going to be a great mix of things. And so we've got sort of 4 blocks throughout the day. We're going to use the leftover time at the end of each block to sort of reflect on the things that we saw in that block and ask questions or get a little bit more into the topic, because most of the people in the room are people who are working in the field. So this is a chance to make it more than just sitting quietly all day while people talk to you. We're going to open, the first session is going to be PAW, the audio workstation, and CellPond, which is programming without escape, I think is the catch line. Yeah. And we'll have a slide up throughout the day so you can sort of orient yourself, and then we'll go for coffee. I think there's few enough people in the room that maybe we can take a moment and we'll kind of work through, and if everybody could maybe stand up and just say what your interest in live programming is, and we'll start, let's see, I'm going to start at the back and we'll work our way across to the front, sort of like a book. So go ahead.
I think it's better to start up here.
Sorry, yeah, June suggests, do we have a traveling mic? Yeah, perfect, thank you.
That should be fine.
Okay, sorry, one sec. Yeah, sorry, this, we want to make sure the live stream can hear what we're saying.
Does it work?
Yes.
Hi, everyone. I'm Thijs van der Storm from Amsterdam Center for Mathematics and Computer Science and University of Groningen. My interest is in developing language engineering techniques for live programming systems. I will be presenting joint work with Jonathan Edwards over there at 11 about live and local schema change challenges. Thank you.
Hi, I'm Travis. I don't know a whole lot about live programming. I'm just here to see what it's about.
That's great.
Hi, Sam van den Wonder from University of Brussels. I am here I like reactive software programming language design, liveness, CRDT things, and so the programming language aspect of it.
Awesome.
Hi, I'm Josh Pollack from MIT. I'm going to be giving a talk later on language model agents, which is about how LLMs might or might not change the way end users program. I am also building a diagramming library for JavaScript called Bluefish, which I think is sort of, in part, aimed to support a lot of the custom visual representations that folks in Live might be interested in. So please talk to me later if you're interested in that, and I'll be at the Unconf as well.
Hi everyone, I'm Jeffrey Litt, currently at Switch. I got my start in research at Live, I think like 5 or 6 years ago, so it's fun to be back. I was working on IDEs that show you example data. Today I'm on the team that put together the Embark talk about document programming inside of documents.
All right, hello, my name is Anton. I'm a PhD student from Lund in Sweden. And I'm interested in building compilers and static analysis tools, and I will present CodeProber today, which is an interactive sort of debugger and explorer for compilers.
Hello everyone, I'm Leo. I'm from TU Munich, and I'm more interested in CRDTs and this kind of stuff, so I think tomorrow is more interesting for me. But I'm also happy to be here and to learn something about live programming as well. Thanks.
Hello, I'm Liang, and also I'm from TU Munich. So my research interest is about CRDTs and formal verifications.
Yes, I'm Youssef. I'll be presenting Typcell in the afternoon. So I'm very much interested in live programming, end-user programming, and local-first applications as well. And I'll also present about the local-first system tomorrow.
Hi, I'm Mariano. I'm co-founder of a company called Instadec. I'm interested in live programming for data analysis, visualization, and decision-making, let's say. I built a couple, and I'm trying to build a new one, trying to integrate LLMs and the idea of conversational UIs.
Hi, I'm Simon from Poland, and I'm interested in interfaces for computation.
Hello, I'm Clemens. I'm from Aarhus University, and I'm interested in collaborative, reprogrammable systems at large.
Hello, Martin Kleppmann from TU Munich. I'm interested in real-time collaborative software of all sorts of different types.
Hi, I'm Jess from DXOS, and we're working on a collaborative real-time environment and trying to figure out how programmable should it be. So.
Hello, I'm Fuad. I'm from Ellipsis, a company in Berlin. I'm interested in local-first software, CRDTs. I come from the Clojure community, so I'm also in jar of REPL programming. So yeah, curious to learn more about the community.
Hey, I'm Martin. I'm from Berlin, and I make Clerk, a kind of moldable live programming environment for Clojure.
Hello, I'm Joel. I'm a finishing PhD student at University of Kent, and I'm interested in highly dynamic, flexible, malleable programming environments that can be changed using themselves.
And Joel's on the postdoc market. I'm Jonathan Edwards. I'm collaborating with some of you. I'm interested in what everybody here is working on. And I've been working behind the scenes to get this live workshop running all these years. And that's it. Oh, over here.
Hi, I'm Xavier, or Xavier. This is how I pronounce it. I'm just interested in ways to make programming more interactive, more enjoyable, but also I'm really interested in how programming can augment other activities such as music, which is what I'm going to be presenting today.
Hello, I'm Lou. I work at Tealdraw in London. Hi, Ivan. And I also make my own weird canvas-related programming stuff because it's fun.
Hi, I'm Kieran. I'm final year PhD student at Singapore, National University of Singapore. And my research is on formal verification, but I like, I'm interested in PL research, and I like finding out how to make programming languages that are easier to use and more fun to play with. So that's my interest in live.
All right, well, I saw like half of Ink and Switch snuck in at the back there while you guys were talking, so Why don't you guys wave for the stream? There you go. Anyway. Awesome. I think, do we have any more opening, June? Are we ready to begin?
I think we are ready.
We're ready to begin.
Well, something that is over there for the on-site attendees only is some souvenirs from Japan. You will enjoy some sweets, like candies. So just feel free to take it.
Oh, I guess we have a couple more logistics notes here. Sorry. Well, this one I have to bend down for them. A few more logistics notes. There's a Discord. I've said this several times. That QR code will get you in if you haven't already joined. And that's where you can ask questions and so on. We're streaming live on YouTube. What you see on this screen is what's going on to the feed on YouTube. If you're a presenter, please keep an eye on that thread and reply to it. And remote presenters we will see in here, and we'll try and have a camera so that you can see the people in the room. And at the end of each session, we'll invite the speakers back up from that block to sort of like have a bit of a conversation and discuss with the audience what we saw. And I just wanted to encourage everybody to actually like try other people's systems. Don't just come and talk about the thing you do. You're here in a room full of some really amazing people who are building cool stuff. So try and take some time and give it a shot if you can. Okay, with no further ado, I think we're ready to begin the morning session. Oh, Jun?
Yeah. So the only one thing that I think we should mention is that we are preparing a slides where everybody can introduce themselves.
Yes.
So, to try out other people's systems, we need some sort of links to all these systems, and we are preparing a slide deck for everybody that can be edited by anyone in the room or for the remote. So
it's already posted in the Discord.
Oh, really?
So,
okay.
Yes, I posted it there.
Thank
you can go in, there's a template slide, put your name, what you're working on. If you have any links you want to share, you can put them in there, and put a picture so people know how to find you if they would like to ask you about what you're working on.
Okay, sorry.
Hey, great. And now we're ready to begin. Yes.
Yes.
Okay.
Yes.
All right. So, Xavier, would you like to come up and get settled here?
Is this okay? Yeah, awesome. I think I'll actually create. Okay, this way I have my notes, and you have this. Awesome. Hi, my name is Xavier. I'm here to present to you this hobby project that I've been working on. It's called PAW. It's an exploration of bidirectional programming in the context of music production. I think you're all somewhat familiar with bidirectional programming, but maybe not with music production. So before I introduce the project itself, I'll give you a little bit of a primer. So these days, this is not working. Well, I guess I'll just do this. So these days, music production on the computer is typically done with software called DAWs, which are digital audio workstation. And they're originally based on like old mixing consoles and drum machines. And they provide you with various kinds of domain-specific UIs that are practical for arranging and producing music. I'll just show a few of them, but the most common one I would say is the track editor that you can see here, which shows a stack of different tracks. Each track corresponds to an instrument. And then those tracks can have little clips of audio or MIDI data. MIDI is just a representation of a sheet music that can be played by a virtual instrument. And then as a musician, I can arrange those to arrange my song however I want. DAWs also come with mixers that I use to combine different tracks together into the actual audio output that I want. This is also where I can apply effects to my track. which can like shape the sound in one way or another. So like, for example, adding an echo, distortion, improving the quality of the audio. And then this is, again, a different type of like domain-specific UI, which is a sequencer, which I can use to have a higher level view of an audio project and arrange bits of audio, maybe if I'm working on a song in terms of verse and chorus. A different tradition of live coding, music making on the computer is live coding. It's here I've got a little like demo that I found on YouTube. And basically, in live coding, the artist is writing a program as it's being executed. And this program, like in this context, produces audio. Performance is editing the program live. This is often being done in front of the audience. Thank you. This is usually done for generative art, like music that needs, mostly for like electronic music, because this is what programming is best at. If you want to do things that are more traditional, that does actually better, you get those like UIs that make a lot of those things easier. If I'm working on a like pop song, I want to cut the audio very precisely, arrange, like maybe I'll have 7 takes of the same like vocals, and then I'll cut them very sharp and select only the best ones for each sound audio. This is the sort of stuff that I cannot do live. On the other hand, like being able to write a program for this can give you a lot of power that you just cannot do with a DAW. And so this is this is where my project is trying to carve a space for itself. So PA, which stands for Programmable DAW, it's a combination of live coding with some of those domain-specific UIs that come from traditional DAWs, and the two are connected together via bidirectional programming. So it's rooted in live coding. I'm just editing a program live to produce audio, but I have special syntax inside of the domain-specific language that will generate widgets inside of a GUI, which allow me to edit the code. And those widgets are, they have, this editing is bidirectional, so I will edit the code, which changes the GUI, and I will use the GUI to update literals in the code and also get direct feedback in terms of the audio, which we'll hopefully be able to see right now in a demo. So I have a video in case if it doesn't work, but this is what it looks like. That's going to be a little bit tough for me because I'll have to look there, but we'll make it work. So maybe I'll just quit this first. This is basically what it looks like if I don't have any project open, and then here on the side I just have a basic normal, like a terminal, and I open a project file, a code file in a normal text editor, which automatically connects with PA, which is on the left here. PA is a language server, implementation of a language server for this DSL that I have here. And so this is how the two communicate. And so let's maybe hear some music. And this is bad news for me. This worked earlier, so tough luck. Yeah. Well, this is not working, but I guess this is what I have the video for. So let's go. Oops. Anyway, so here in the video, I'm demonstrating starting the audio. Oh. Yeah, maybe it just wasn't loud enough here. Yeah, perfect. Awesome. Yeah. So basically, this is the little tune that I wrote for this demo. But you can see those different domain-specific GUIs. Widgets that appear here. They're generated from this code. So for example, here I have this track that looks like one of those track editors that I showed earlier. And this is generated from this little track here that I have. I have 2 little clips here, one there and one there, and they correspond to those 2 lines. And so I also have these little sliders here. Maybe I can show an example. So this is a guitar. This is the slider to control the level of the guitar sound, and so I can adjust it here. Okay, I can turn it back down. If I release this thing, it'll update the value here. But I can also, oops. What am I doing? Yeah, this is really hard to use. Okay, anyway. And I think I'm muted. Yeah. Anyway, so this is kind of the bidirectional aspect. I have maybe some other things that might be interesting. I have these little checkboxes here. They're just basically a wrapper around the Boolean. I have an example here. If I check one of these checkboxes, maybe the click track here, it'll turn the Boolean into a truth value. There you go. This is what I use to record those little tracks, to give me the rhythm. Anyway, maybe a little bit more interesting are those tracks up there. Here I have the drum track, and those track editors are very, very simple. Like the only operations that I can do is moving those clips around and resizing them. In a typical plot, you'll have way, way more features. I'll pause this because now it sounds bad. You'll have a lot more features. You'll be able to import like clips onto those tracks. You might be able to duplicate them and so on. Those features are all missing from this. I only have those basic functionalities. It's not actually a problem because since I have this like human understandable representation of my data here, I can basically, duplicate this. I make a copy, and then now I have another clip. And if I want to, use a different clip, I can edit this. This is the advantage of having this representation. And of course, this is a text editor, so if I want to undo all the changes that I just did, I can do this, and everything's back to normal and should sound better again. Another great thing about having this programming language representation is, again, this UI is super limited. It really does very few things. And for example, you've noticed maybe that if I put the playhead there and start playing, we can hear some music. This is because I'm looping those tracks. In a traditional DAW, I'd have a specific UI that allows me to do this. I don't have this here, but it's a programming language, so I just wrote a loop function here, and then I'm pulling it in several different places. Again, it's a LSP, so I have this show usage, and then I'm just using this when I'm sampling a track to say, hey, I want to loop this section, and then it just does. So it might be nice to have a UI for this, but I don't need it in order to be able to do this in the system. So yeah, that's basically all I wanted to show in this demo. Moving on. So just a little presentation of how the syntax works. I have the syntax, basically it's extremely simple. It just wraps around the literal and makes it interactive. So here, this slider syntax wraps around -6 here, and then I have the bounds of the slider. In terms of the semantics of the language, it's as if the syntax for interactive widgets just wasn't there. It's discarded at compile time. So I could just remove this slider and it would remain the same. I often do this when I'm tweaking some stuff. I create a slider, and then once I have a value that I like and I don't actually need the slider anymore, I just remove it from the code. The syntax is type aware. So here, for example, I have this union type that can take several different values. And so if I add a drop-down widget for it, it'll allow me to select among the different possible values for that type. And then I have those domain-specific UI. I mean, I have only the one for now, but I think in the future it would be valuable to have more. I would love to have a sequencer at some point. Of course, all of this is not really new. I'm merely applying existing concepts to this specific domain. One of my first and main inspirations for this work is Sketch in Sketch. A lot of you probably know about it. It's a direct manipulation programming system for creating SVG documents. And so as a user, I would write code on the left-hand side, and it would generate this graphic on the right-hand side. And this graphic comes with a bunch of those little signifiers of the kind that I would find in a, in a traditional SVG drawing application. And if I use these signifiers to update the graphic, it'll compute a program transformation and update the code on the left. The program synthesis that it uses is like very powerful. And so it'll like essentially run the code in reverse to figure out exactly what needs to change in order to make the code still produce the same graphic. Another work that uses program synthesis, in this case in the context of music, is this work by Santa Lucido, Human-in-the-Loop Program Synthesis for Live Coding, which shows you this grid, this drum grid on the right-hand side, where you can input a specific rhythm by tapping on those circles, and it'll generate code on the left that will produce this rhythm when played. But then you can also edit the code. It'll update the pattern here, and then you can edit back the pattern, change the code, bidirectional programming with program synthesis. In comparison to these two works, PA is actually tremendously simpler. Its interaction model is just, I say this thing is interactive in this way, and that's it. There's no program synthesis. It makes it less powerful. I think program synthesis might bring some interesting things to PA, but I also like the simplicity of this system where I really understand very clearly what the GUI is going to do when I interact with it. My experience of interacting, especially with Sketch and Sketch, is that sometimes it can be a little bit difficult to make sense of all the signifiers that are displayed for a specific program, and also to understand what the program synthesis is going to do when I'm going to change something. PA is actually a lot closer to this work called Livelets, which is an extension for the Hazel programming language that adds those syntactic elements, like here, for example. So those syntactic elements introduce those widgets that are baked into the editor, unlike PA, where you have this window of GUI on the other side. And interacting with those will result in like direct change in the output of the program. So those actually, those interactive values, those livelets, produce closures that are reevaluated when I change the GUI. They also like perform macro expansion to obtain the actual value that is going to be used in the program. In this way, again, PA is a lot simpler. There's no macro expansion. I just like wrap a literal value that is baked in the code. Something that I like about this is that I actually know what the value is, and I can, as I said, remove the interactive syntax, and the program remains semantically identical. A great advantage of livelets is, the GUI is embedded in the text editor, and also for very complex GUIs, like maybe this table here, if I had to have the code representation of this, it might be a bit verbose. And then another work that I really liked in this context is Anderson's visual syntax for the Racket programming language. So those are, if you know Rackets, you have those powerful scheme macros in it. Those are basically visual equivalent of those macros. Here's a great example that shows a function, a balance function for a red-black tree. If you've had computer science classes, you probably heard about this. And it can be a little bit difficult to get a good intuition of those things when they're, just like data structure written in code. But when you have those visuals, it makes everything a lot more intuitive. So yeah. The last time I presented PA to somebody who had never heard about it, they asked me this. They were like, "This is cool, but like, what's even the point? Like, what are you trying to make? Are you trying to make a better environment for live coding?" And in part, but I'm not a live coder myself. I make more traditional music, and so I'm not really trying to make a better live coding environment. I'm actually going after DAWs themselves. As an amateur music writer, I've used DAWs for several years, and I have like little frustrations with them. And mainly my frustration is that they're, I'm a programmer, and so I feel like they're not enough like a programming language. They don't have enough of the programming language features that I really like. What I mean by that is that GUIs, they're powerful, but they're restrictive because they lack compositionality, whereas code is open-ended. because of its highly compositional component, but code is non-visual. And so the impact of lack of compositionality of GUIs is that most of the features in a GUI are ad hoc. If I have a UI to do a specific thing, it was baked into the GUI by the developer. Whereas in a programming language, most of the features are just emergent from recombination of other things. A big impact of this is that the complexity of a GUI will grow along with the number of features that I have in my application. And what I mean by that is the dev work to implement is going to grow, the maintenance work will grow with the number of features, documentation becomes more complex, discoverability can become an issue. In a programming language, some of these things are, don't apply in the same way. You have a really high cost in learning to program and in learning a specific programming environment up front. But once you have this cost, programming language gives you, a programming language can give you the tools to manage complexity and organize things a lot better because of compositionality. But in a GUI, as I said, you get this power from having those visual elements making some tasks way easier than in a programming language, which is why bidirectional programming can be a great tool to try and bridge this gap between the two. I have a couple examples. I think the second one is probably more interesting given the time. For example, in a DAW, I will often want to save part of a project to be reused in another one. A typical example is maybe I set the settings for an effect. I really like an echo that I set up, and I want to reuse it on a different track or in a different project that I made. And so I will want to save this preset. For this, I need to use a specific GUI that was baked into the DAW. It's a different GUI for saving different things, and I need to know exactly where it is, and it has really low abstraction power. I just save something, and then I import it exactly as it is. In PA, because it's a programming language, I can just declare a function and use it. It's a generic programming concept. It works for anything in the same way, and it has higher abstraction power because I can use function parameters to parameterize and create custom effects and whatnot. I'll conclude by saying why not use PA, which is that right now it's not great. It's a very early prototype. The DSL is not really great. You probably saw that it was very messy. If you're used to live coding, it's not the best programming language for that. And then I talk about issues of discoverability in a GUI, but this can also apply to a programming language. The widgets are outside of the code, which can make it difficult to understand which slider is affecting what, and it's missing a lot of DAW features. So I'm trying to see if those problems can actually be solved or if they're like intrinsic to the domain. Then have future plans, improve the program, fix bugs, and then I want to get other people to give me feedback to actually use the program, make some music, and then have a lot of long-term ideas. But I think that's the end of my time. So. Yeah. Yeah.
No, let's do live questions. Well, we can also do the Discord.
So this is very nice. So,
wait, hold on, microphone.
Oh, yeah.
Thank you. That was very nice.
Thanks.
So I was interested how you started to use functional abstraction to go beyond what a physical, emulation of a physical mixing board could do. I imagine that when you're composing music, you want to explore various variations, and you want to save something you tried and go back and do something else and mix them up again. And rather than functional abstraction, that sounds to me a lot more like version control.
Yeah, absolutely.
But on the other hand, Git sounds to me like the worst UI for trying to do it with.
Yeah.
Have you thought about this?
So not really yet, but I am using Git to version control my tracks that I make with PA. I do think being able to track changes in this way is extremely valuable. For now, I haven't really thought of a solution for this. I'd be very interested to figure one out at some point or read about it.
I have a different angle of question. It seems like the way you talk about the problem and what we see in the code, you have a ton of value and benefit from making the mechanisms of your track transparent, right? Like the data of your program becomes transparent. But the sort of programmatic part it seems less valuable. Like you could just put loop equals true on the end of a track rather than having to write a function for it. This is not meant to be a criticism of being programmable, but it kind of seems like actually probably the biggest advantage you have over a traditional DAW is just transparency of the data and the ability to copy and paste and make references and move things around.
Yeah.
Is that something you've given a lot of thought to? Do you think there's more opportunity there?
Yeah, actually, I think it was a main element of designing this project. It's like thinking about how to translate traditional DAW features into this context. A lot of it was thinking about how do I select like the smallest amount of features from this GUI so that I can use this in this environment. Because basically I'm trying to design those like GUIs to be as compositional and as restricted as possible to be able to keep leveraging the power of manipulating the source code directly and writing programs. I don't know if that answers the question.
I think so, yeah.
Who should go next? I'll go.
Yeah, excellent work. It's really great. Real quick question though. I was wondering, is it possible that any of the existing DAW products have an API or an SDK such that you could like progressively augment their user interfaces with programmability or a two-way mapping between a code representation and while also maintaining the power of like some of the DAWs are really, really nice to use for most things, but for some things they suck. And I wonder if you could like layer your stuff on top of an existing DAW.
I don't think so. Like DAWs are extensible to some extent because you can write your own plugins for effects as shared libraries, but I don't know of any DAW that will allow me to actually extend it in this way. Usually extension mechanisms are really restricted. It might be interesting actually to try and fork an existing DAW to add those features to it. But as like mentioned earlier, I had to think very thoroughly about the representation of data and how those the GUI actually manipulates the bits of data in the code for it to work properly. So I think it would be a major overhaul of an existing DAW to be able to do that.
Really nice work. I'm curious, you said your system's simpler than Sketch and Sketch. It doesn't do program synthesis. Do you have any examples of where that is a limitation? Like, are there times you do a change in the UI and your system doesn't update the code the way that you would ideally like to?
Well, I mean, no, that's kind of the thing that I mean is that do you mean the fact that I don't have program synthesis in PA, where is that a limitation?
Yeah, like
okay,
are there examples where that doesn't update the code the way you would want it to? Or not, maybe, I don't know.
Yeah, I don't have a good example of this right now. I think it's more that I will give you a more general answer, which is that writing programming, like writing code with PA like this requires to deal with a lot of boilerplate. And I think a lot of it I can get rid of a lot of it by improving the programming language, but also a lot of it is kind of inherent to just having to type code. If I had a GUI that can be a little bit smarter, that can do program synthesis, I would be able to get rid of probably a lot more boilerplate by having the GUI generate some of the code that I'm writing.
Thank you.
Hi, that was really cool.
Thanks.
This is a programming conference, so I'm going to ask a non-programming question.
Awesome.
You've made a tool for art. Could you talk for just a tiny little bit around any artistic goals you have for this project? Like if there's like a kind of music you want to make that you couldn't make with traditional live coding or DAWs or something like that that this might enable you to do?
Yeah, I think basically for me, what I find exciting about this project, and it's something that I've already had the chance to explore by using it, is that it gives me a direct connection with the tool that I use to make music. When I was working with traditional DAWs, or like when I still work with traditional DAWs, I have several layers of abstraction between what the developer of the DAW or of the plugin wrote and what I'm actually using, which means that I'm only limited to what this is enabling me. Whereas here, in the context of making this project, I've had the chance to be like, oh, I'm using this like ADSR envelope, but I wonder what happens if I tweak this little bit of the code, and so I don't know, fork my own ADSR library that I wrote, change some bits, and then, oh, this is producing something different and interesting. Maybe it's, yeah. This is, I think, one of the big values for me. I'm still interested in making like traditional music of the type that I was making before, but this is definitely like enabling me to think a lot more outside the box and experiment a lot more, which I like.
Very cool. Thank you.
Thank you.
I think it was sorry. Hi, I'm going to make a programming question then. So the other side, like the side of programming, what are your thoughts in terms of like, have you explored the space of like mutability? How do you handle time? Because you're kind of handling a continuous thing, streams and stuff like that. Have you ever felt that it will be cool to have a particular syntax or semantics that are not like normal or useful for common programming, but would be for live music production?
Actually, yes. So the way I wrote the DSL for this, and the way I designed it at first is I wanted it to be kind of general purpose, because my goal with this project is to retain as much programming power as I can while making it. I don't want to make too many compromises. But after making this and working on several different tracks with it, I've realized that this program is really not good. I mean, this programming language is really not good for making music compared to live coding programming languages. So I think there are trade-offs to be made here in terms of improving the language that will change the way it handles some of those things. Is that a good answer? Yeah, thank you.
So I'm curious if you've thought much about a multiplayer aspect to this, specifically if you think about how, like in programming languages, Git is really good at like diffing and forking and merging for asynchronous collaboration.
Yep.
And if you add networking, then I could imagine like really easy ways to introduce synchronous collaboration and like jamming into the GUI or even into the code. And so I'm curious if you thought about those things and how this tool could like enable better culture or like ways of social experimenting around that.
I've thought about it a little bit, and I know of like DAWs that are geared towards collaboration. I think a problem that I see with this is that music is making music is highly dependent on latency, and network latency is way, way too high to make music comfortably. So I haven't really explored that area too much, but there might be interesting things to do with it. I'm not really sure. Okay, thank you very much. I don't want this to fall.
Oh, yeah, thank you very much. Oh, hello, talk amongst yourselves. Hi. I'm great. Oh, yeah, perfect. Thank you very much. Thank you, that was great. Can you hear me? Yeah? Echo, okay. Right, I'm just going to turn my timer on, which will yell at me if I go too long. Okay, we're ready?
Hello, my name is Lou, or Luke, either's fine. And the name of my presentation is Cell Pond, Spatial Programming Without Escape. Okay. So part 1 will be about spatial programming, part 2, Cell Pond, and part 3, Without Escape. So just checking, how am I doing for time? Got a few more minutes? All right, okay, I better speed up. Okay, so 23 years ago, I was 6 years old, and I liked trains, right? And I also really liked computers, right? So this is what I grew up with. Wow, I'm so old. And so I was really excited when my class at school got taught how to code with something called Stagecast Creator. Any Stagecast fans in the house? There isn't usually, but I was, and it works like this, right? You drag and drop to make spatial rules. Here I am making a rule for my character, and here it is in action. My character moves to the right. You make a before and after picture. When this happens, then this happens. When there's space to the right of my character, they move right. When there's an obstacle to the right, they jump over it. You can make lots of amazing things with this extremely simple idea. And because of that, at the time, it was a very popular style of visual coding. And they also loved trains. Like, they seriously loved trains so much. And it was so sad because it was so hard to code trains with spatial programming, for me and for them, because of this thing called and I can't pronounce it, but basically what it means is that you have to make lots and lots and lots of rules to make certain simple things, like trains moving around a track. And it's even harder if you're working in 3D, and I found out the hard way. That's how many rules you have to make something very simple. It's also really hard to make different things act the exact same way. So it's hard to make a car move along a road like a train moves along a track. You can do it, you just need to write loads of rules, which is really annoying. So we gave up. And we turned, I know, and we did this instead. Does that look familiar? Yeah, you see, does that look familiar? When we turned to block-based coding, spatial programming died, right? The end. Thank you for coming to my talk. No, all right. I'm just joking. There are loads of there are dozens of us. All right. This is SPLATS. This is by Dave Ackley, a spatial programming language designed for a new kind of computer architecture, which is robust first. This is Color Code by Murillo Plays, an artistic and beautiful puzzle. This is NetBiodin, a spatial programming tool intended for research, biological, chemical simulations. This is Viscit, another educational tool. It shows us how to do spatial programming without a grid. And I made one too. This is SandPond. You code it like this, with before and after pictures to make different elements like sand, water, and rock. Spatial programming is used for education, hardware, art, simulation, and games. Spatial programming is general purpose, and so I think it's worthy of our attention. But it has a dark secret. Can you see it? Can you see the secret? Can you see the dark and terrible secret? You can't see it because this image is cropped, right? Here's the full image, right? You see what text? How did you know? So spatial programming makes heavy use of escape hatches. If you want to do something simple, it's fine. You can do it with the spatial programming, the rules. But if you want to do something more complicated, you have to use normal programming. They all do it. Even Stagecast Creator. It's not even a spatial rule. These are instructions. They're lines of code. If you want to have more fine-grained control over it, you have to deal with it. I mean, color code doesn't have any escape hatches, but it's more limited. You know, that's intentional. It's part of its design. It's part of its beauty. But is that really our choice, right? Powerful with escape, or limited without escape. Could we make something that's powerful without escape. Is it possible? What would it look like? Will there be any unexpected and enlightening lessons along the way? So this takes us to part 2, Cell Pond. It's demo time. Whoop. All right, I gave it a go. All right, this is Cell Pond, and you can paint in it, and you can clear the screen, and you can paint in it some more, and you can clear the screen. Can you see we're painting with white right now, and that's because in the top left up here it says white, but you can open this up and see that this white is just made up of red, green, and blue. So you can just like click on these and change them. Does that make sense so far? Yeah, and you can like do that with all of them. If you're undecided, you can pick a range of colors. Do you see that? Yeah. Oh, yeah. Oh. You see that range? And I like that color, so I'm gonna just keep it safe here on that paddle. Does that make sense so far? Are you following? If you're really undecided, you can just like, blue or green, I don't know, just put them together. And then we've got blue or green, a new color. It's called blue or green. All right, I'll keep that one too. If you're really extra undecided, you can just like remove some of these color channels. You just chuck them off the screen, yeah. And now I'm only drawing into the reds channel. Can you see that? Ah, yeah. So here's reds. You could draw into the blue. No, sorry, green, and then and the blue. You see, it's like mixing together. I'll keep that one too. Another thing you can do is do you see this triangle? Do you see how it's kind of pointing to the right? Well, you can point it up or down or like any way you want. So I'm going to point it up, and then I'm going to put that in one of my channels. Yeah. So now it's increasing green. Yeah, or maybe increasing blue, or red, but then I could also like reduce red, but it's not touching the green or blue. Do you follow it? Yeah. Do you know what I like doing is you put one up and then another one to like full. Oh yeah, you see that? That's nice. Anyway, so another thing you can do with the triangles is make a rule. See, green points to, green becomes something else. I am going to pick, and it's really important I pick pink. All right, so green becomes pink. Now watch it, because this will happen fast. Do you see that? I'm going to pause it, put some green down, unpause, it becomes pink. Do you see that? I'm going to turn off the rule, put some green down, turn back on the rule, it becomes pink, yeah? So that's a very simple rule, but it's more interesting. Ooh, everything becomes pink. All right, so it's more interesting when you have a rule that's bigger than just one square. So I could say if pink is above black, then we're going to replace that with pink below black. So now our pink is falling down. Can you see that? And you can make these any shape or size you want. There's no limitation like most other spatial programming things. All right, you can say if pink is kind of like up and above to the side of black, it's hard to explain with words this, right? But it's just obvious when you see it there. So like if I put down this pink now, it's falling down and it's falling to the side. Both of these rules are randomly firing. It's super non-deterministic, super random, but still it's making something compelling that we can understand. I want this to happen to the left as well. So it would be annoying if I had to make another rule. So I have this little circle, and it's like a mirror. I'm going to flip this left and right. And now, when I drop it down, I've made pink sand in Cell Pond. Can I get a round of applause for pink sand? Yeah. Right. And you can just keep doing this. There are some I made earlier. So you can just like keep adding more and more rules to make more and more like complex simulations. I've got sand, I've got wood, I've got water, I've got rock, I've got plant, and I've got fire. All right? And you can make all sorts of things, just keep adding more and more rules. There's one thing I just really want to point out. You see this top rule? I'm using that thing I showed you earlier. This is sand or water or rock. We're making different things act the same way with just one rule. And this uses a really key concept that I've always failed to explain, called conservation. and CellPond does it. So I'm going to try that. It's world exclusive of Lou Wilson trying to explain conservation in CellPond. Okay, so first of all, I want to show you this green color is a range of greens. Yeah, it's not, they're slightly different. All of them are slightly different. And this one rule I've got here, it just says if there's black above green, then fill the black with green. Okay, so when I place down green, it starts copying itself upwards. But look closely. It's like every time it copies up, green stays the same color. It doesn't randomly pick a new green. And this is really important, CellPond uses what's already there in that little neighborhood to decide what to draw. You can always override this by stamping one of them, and that link gets broken. So now, rule of conservation is gone. And that's really important for allowing this consistency from one rule to the next. So that's my attempt. It's pretty dry, but please let me know how I can explain that better. All right, here's another one. In this first rule here, these colors are empty. They have no values in their channels. So I'm basically saying any color is fine. I don't care. Any color is fine. If I have two of anything next to each other, then they become two of anything next to each other, but they could be flipped. So what this is doing is it's randomly swapping things around, and that's how you get this diffusion effect. But you can play around with this rule of conservation. Which one are we going to place where by stamping one of them? And you end up with this Galuppi effect. Again, I find that this kind of behavior is really hard to explain with text and words, but when it's expressed spatially like this, you get more of a sense of it. It's more of a feeling rather than something you explain. And by the way, look, you can make them disappear at the edges. It looks nice. Ooh. There's no real point with that one. I just thought it looked nice. So do you remember earlier on I showed you could have a color like this where we're reducing the value of channels. And this works in rules too. So you can say in this rule, anything is just going to have all its values reduced. So no matter what you put down, it's just going to reduce down to 0. But you could have this only affect certain channels, only reduce the red channel, and you can make all sorts of different things with it like this. And this is also this is really important for storing data and information in CellPond. So here I've got this little ball. You place down a ball and you chuck it upwards and it falls down, right? And you can throw lots of them. And have a look. There's 2 stages. It rises up and then it falls down. And we're storing that stage in the green channel. As it rises up, green gets reduced. Have a look. Green gets increased. Green gets increased. And when green is at the top, it switches into the other stage. So even though these rules are firing randomly in any order, in any place, we've created a control structure. And that's how you can make more complex things. Just don't get these stuck on the ceiling. And by the way, when I say random, some people freak out and they think, is this even Turing complete? And I now present to you my proof that CellPond is Turing complete. Okay, please stop asking me about it. All right. I'm joking. But please don't. All right, so now you're ready to see the main thing behind CellPond. Okay, so do you see this rule at the top? Blue doesn't just become one other color, it becomes 2 colors. And this is CellPond's big idea. This grid is not fixed. You can merge cells together and you can split them apart. So watch this. Do you see what I've done here? I'm going to make it run a bit slower so you can see it. These cells are splitting. And I could just keep going in and we could just split more and more and more of them. For the 1 or 2 of you out there, no, this is not a quad tree either. All right. So this is another way that you can encode. I need to fix that bug. Please fix that. Please fix my bugs. It's open source. you can encode data by splitting. When you need to store more information, just split, and you've got more memory, more data where you can store stuff. So here, I've got these same little shapes, and they have one rule: move forwards into an empty space. But this rule, you see here, is flipped in all directions. That's a bug. That's not going back on. All right, there we go. Fix my bugs. But so you can place them down, and they're pointing up, and they'll go up. But I could just like rearrange this and have them pointing down. I could even add a rule that makes them like change and go in a random direction. Yeah. I could pause and zoom in, and I can look at any one of these and just see, just by looking, I can see what direction that has stored. There's no hidden stack or heap or register or there. It's all right there. I can see it. You see? Do you see it? Yeah. Yes. Thank you. Yeah. Okay. But you know that's less interesting. No one really cares about that apart from people at programming conferences. People care more about this. If you make something split into more copies of itself, then you can make a fractal, and this will just keep going and just crash your computer like a normal programming language, which I think brings it legitimacy. But of course, like fractals are quite a popular thing to make in creative coding circles, and they're quite complicated. But I think this is a fun way of just seeing it. Look, I'm just drawing a new fractal. What if we swap it with this, which I've just made? And I place it down. Hey, we just made a new fractal. What if we just give it like random rotation every time it splits? Ooh, right. You know, I want to see more of this. Just in case anyone asks, yes, you can make trains. So let's say I'll make a nice little track, and like this. Oh yeah, yeah, like that, and then I can pop a train in it, and we use some of those things to make a little train. It's No, wait, it gets better. Right, watch this. You can, I added like a one-way only track piece, so this will always turn right there, and then you can put two trains in, and they won't crash. Yeah, that's what should have got the applause, but it's fine, How are we doing for time? We're good. So another thing I want to mention is that you can, choose a different resolution for CellPond if my default one is too boring for you. This is a nice, slightly bigger resolution. But of course, because you can split cells, you can just increase the resolution by yourself. So have a look here. Can you see that it's getting? Do you see that? Did you see that? I'm going to show you one more time, and this time you better be paying attention. All right. So I'm placing down this white square, and as it spreads around, it's splitting these cells into smaller cells. So I'm just increasing the resolution myself. However, some people weren't happy with doing this every time they loaded it, so I added a setting as well. But yeah. You can make nice high-resolution stuff too. We'll get back to that later. Part 3, without escape. Is it possible? Probably more possible than it once was. What would it look like? Maybe that. Will there be any unexpected and enlightening lessons along the way? This surprised me, because there was, right? The biggest breakthrough with CellPond was not its UI, right? The UI is just provocative. That's not the point of CellPond. Forget the UI, all right? The main breakthrough moment, after which everything just fell into place, was CellPond's virtual machine called Dragon, which is like drag and drop, and it has 4 main instructions: check, recolor, split, and merge, which are basically read memory, write memory, allocate memory, and deallocate memory. After this, everything else just slotted in. And I think if you were to learn from CellPond, you'd take this away, not the UI. But you can take the UI too if you want. I was very surprised by this, because all of my reading of things in the past, solutions to these problems were all about the high-level user interface. They were about the UI. I thought I'd have to build layers upon layers of UI, but really, as soon as low-level stuff was sorted out, the UI just figured itself out. So here's another example. This is a very simple rule. Yellow, if there's yellow above black, they swap positions. So I have a question for you. Is this yellow square falling down, or is the black square falling up? You think it doesn't matter, but most spatial programming languages force you to decide with this thing called origin, or sometimes it's like implicitly decided. At worst, it's slightly annoying, and at best, it just messes up your program. So we don't want to do that. So instead, when you make this panel in CellPond, it doesn't just make one rule, it makes a registry of multiple rules. All of those extra rules that were really hard to make before, well, let's just get the computer to do it, right? Like instead of us doing it ourselves. And you don't need to understand all this because CellPond does, right? I'm not going to explain all that to you. That's what CellPond does under the hood. It's making all these redundant rules for you. This is how I think about it, right? We could map out every single bit of normal programming from low level to high level. We'd probably have assembly down here and JavaScript and Scratch right at the top, and Dreambird over here. And we could do the same with spatial programming. Okay, so I would say Splat and Sandpond around there, they're extremely low level, very early examples of it. And I'd put CellPond here. That's what I've been trying to do. I haven't been trying to make a very high level language. I've been trying to make a higher level assembly language. And Markov Jr. is another example that does this like differently, but in a really interesting way, and you should also check it out. It's really tempting to try to make a high level solution to these problems. But I found that it's really hard because we don't know what these middle steps are. So I'm interested to know, now that we know CellPond is maybe an example of how to go up from the bare minimum, what would the C of spatial programming look like? And we could do this with any field. Visual programming, live programming, node-based programming. What's already there? What's next? So my advice to you is to ask yourself, where are you in your field? How low level are you? How high level are you? Because it might save you some time. Learn from my mistakes. I'll tell you where you are right now. You're at the end. Thank you for listening to my presentation.
I'm going to be the first to say that was an amazing presentation. Thank you.
Thank you.
I think this idea that when you find the right primitives, everything kind of falls out is, it's incredible if it happens. But you didn't just find this thing on the first go. You built a whole bunch of things. You tried coming down from the top. You tried coming up from the bottom. You went in from the side. Eventually, you got this.
Yeah.
Can you talk a bit more about that exploration and discovery process?
Yeah.
How did you know that you'd found the right primitives, and what did it take to get there? Because the eureka moment is like this, you told it like, oh, and then it was there. But, but actually that took you years, right?
Yeah, it took a long time. And I think there was one thing that helped make these primitives arrive. It was CellPond had extremely strict goals. It had a very, very, very strict purpose, and if it didn't hit that purpose, then it just shouldn't exist. So the design stage continued until it would hit that purpose. And the goal was, I'm going to go all the way back to, I'm going to keep going. Okay, here. So this is what I was working with in the time, at the time when I was designing it. The goal of CellPond was to be able to do everything that this language can do, which is called SpaceToad. And everything that I've ever made in SpaceToad, which I have in a repo on GitHub, I need to be able to make in CellPond. So those primitives need to do all of that, and I just kept iterating. I didn't touch like my keyboard until that was in place. There wasn't any, oh, well, it kind of does half of them. And that actually forced me to make some really weird decisions and hard decisions about, you know, when I was making CellPond, this stuff sounded crazy. You know, like when I was first started to sit down, we're going to be able to split them? Like, how's that going to work? The UI just was like the bare minimum of how we make that work. And I think I'd encourage everyone, when you're making something, just know what your goal is and stick to it. Because even if it takes you somewhere you don't expect, and that's what happened with CellPond. Thanks. Any other questions?
This reminded me of two games that I've played before. I wonder if they had any influence. First was an old Flash game called the Falling Sand game.
Yeah.
And the other one was Baba Is You, the rule-based game.
Yeah. Okay. Yeah.
To
Very
what
quickly.
extent
Yeah.
Does it relate to those?
Falling Sand games. I think when I first saw Splat. No, I've gone too far. When I first saw Splat in the top right, it just made me think of Falling Sand games. And that's how I first started on this weird journey. So yeah, well spotted. Another one is Baba Is You. Baba Is You is really interesting because in CellPond, you have two layers. You have the simulation layer and you have the code layer. But Baba Is You, there's just one layer. And that's really interesting because there's no reflection in CellPond. You can't make the simulation change the rules. The rules can't change the rules are stuck. And so now, with Baba Is You in mind, I'm now building some different stuff where the rules can feed back into the rules and change the rules and stuff like that. So Baba Is You is really interesting from that point of view. Yeah, thanks.
So do you have how do you decide, you have the operations of if this then that, how to have, you have a color and then you remove one thing and you have a family of colors and then you have ranges and and then you have the mirror. How do you, is there a process to decide which operations to add, when not to add one, when to have, you found one but you keep looking because you don't think it's correct,
right,
or to combine or to split? Do you have a process? Do you have a aesthetic of what rules are ThoughtPond worthy or stuff like that?
Yeah, that's a good question. And I think so this is what you call an asynchronous cellular automaton. And in that world of async CAs, you always have to make that kind of decision. How are we going to apply these rules? What order do we do it? And do we do things at the same time? There's lots of decisions. And CellPond really takes the simplest decision, which is we pick a random place and a random rule. If it matches, we fire it. If it doesn't, we don't. And you just continue and repeat. And that sort of simplicity means that you just don't need to worry about it. We kind of do in another way. It won't have any side effects, but it means you can't guarantee certain things. So I've worked on another thing called Sandspiel Studio with a good friend of mine, Max Bitka, and we chose a different update scheme for that because we wanted to support slightly different kinds of simulations. But CellPond is the purest, just pure random. I'm going to tell you a secret though. For performance reasons, it doesn't always do that, but it should do that. It's like going off spec in those cases. Yeah, don't tell anyone.
Hi, Lou.
Hi, Ivan.
That was very good.
Thank you.
This is kind of a repeat of Mariano's question, but maybe upside down.
Mm-hmm.
So you've got this UI that doesn't matter, and it's not the point. And don't look at the UI, and it's the VM that's the interesting thing. I'm going to look at the UI for a sec.
Mm-hmm.
How much of the stuff that is in the UI is stuff that you added to the UI because there was something in the VM that's this is a capability that the VM affords. I need some way to let the person, get at that. And how much did the reverse happen where it's oh, I have this idea for a thing I want to be able to change. I know how I would UI that, but what are the mechanics that's going to enable that?
It was 100% the first one.
Okay.
And basically me making this UI is from my frustrations of, because like you can just write, like you can write out by hand the VM instructions, and it's really like, it's quite fun, all the stuff you can make with that, because you just go crazy. And it was very frustrating to not be able to do that with this UI. So basically, every change in this UI is to allow me to be able to make more of those handcrafted things. And there's this, what you can do with the UI is so limited for the VM. And I don't know if this will load sandlab.com. This is like another example. No, that's another one. Don't go to sandlab.cool. No. Oh well. I have another one that I'll show you, and I'll show others around if they want to see, which like where I'm experimenting with how to create even more stuff with the UI that you can make on the VM, but not with this. Yeah.
Cool. Thanks.
Hi, so these demos are really amazing. You showed how you can get a lot of functionality without the use of hidden state, but I could imagine, maybe I want my bouncing ball to not, have a consistent color or something like that. I'm curious if hidden state could be implemented in the VM as it currently is, and if not, what changes you might have to make to those abstractions.
Yeah, good question. So, and I think this is like related to what I was saying about the main sort of purpose of this project is the virtual machine, not the UI, because I could definitely see how you could, instead of, you could say something like, well, if a cell matches these criteria, then replace it with a sprite and show that instead. Like, what this would benefit, and I hate to say it, what this UI would benefit from would be some words. If you were to try to make a useful game making tool or creative coding tool, if you put some words on and you select, sprite for this color, and then even be able to just embed some JavaScript in or something like that would help. This is an extreme example, if that makes sense. So here is a little mock-up they got. This is a deleted scene. Look at this train track. Because this was something that they, back in the day, they struggled with figuring out is how do we conditionally show different sprites at different parts in the track? So you'd need to do more than this, but this is just like a start of the kind of thing you could do. Can you see the inner parts of the track are light blue? We've got the corners as purple, and we have the end as blue. And so it's really quite easy to pick out certain situations. And then you could say, well, we're going to show a slightly different sprite for those things. This is all symmetrical. You'd have to do the corners, but that's the idea. It would be nice if you had a view like that where you see sprites. It would be nice to just toggle, between I want to see the data view, I want to see the sprite view, or even an onion skin thing maybe. Yeah.
Hi, Lou. That was really good. I know that you said that the UI is not really the interesting part in the VMs. So when you reload the page,
yes,
it does the thing where it's like one giant pixel and then it subdivides down.
Yes.
Does that mean anything, or is that just cool to look? Okay, so what does it mean?
You see that?
Yeah.
So this does a lot of heavy caching. This CellPond does so much caching to speed things up. It's the grid. It's not a grid, but the grid is organized in various different data structures, and it tries to choose the quickest one at a given time. That process takes a little bit of time, and it's kind of fiddly to do programmatically. It's easier to just let CellPond do it itself. So every time a cell splits, it will put those resultant cells in the right caches. Yeah, this is all just JavaScript, but it's quick enough. Yeah. Yeah, so the question was, why is there some randomization going on there? Yeah, CellPond's random, but it turns out like random's fine, you know? Like not all computing needs to be deterministic. There is a chance, there is a non-zero chance that like I could set the resolution higher. Like this may never end. Just because, you know, the heat death of the universe may come. Like even on a small resolution, that may never end. All of the events, wouldn't that be crazy? All of the events could fire in one corner down here, and then these ones would never happen. But it's never happened to me yet. It's kind of mad, right? Ooh. All right, is that it? Thank you very much.
Mic check. There we go. So we have a few more minutes before the coffee break, and I thought we've had two presentations kind of about creativity and live programming. So I thought it might be nice to let folks in the audience like ask about that or offer thoughts about that. If you have questions about creativity in live programming, is live programming particularly useful for creative endeavors? How about that for an opening kind of question? Do you find that? Yeah, go ahead.
Shall I answer here? Is that? Yeah, I think play is really important to creativity. I think being able to play around with how something looks, like that fractal example, just lets you discover things that you wouldn't have found otherwise. Don't know about you.
Yeah, no, I agree with this. Like, I think a big component of what has kept me interested in my own project is just building something and then having fun with it, just like I would do with, like, I don't know, Legos when I was a kid.
Yeah, yeah. And obviously live programming is perfect for that because it's not something you do and then it's done. And it's not something you do and then you get immediate feedback. You're just in it. You know, and I think there's like a slight difference there. Like, I'm not reaching for an undo button because like I wouldn't reach for an undo, or maybe you would. But when I'm like building something with Play-Doh or like drawing on there's no undo button. It's just like interacting with these materials, like a simulation, like a sandbox. So I think it's a good fit.
It's okay if your hand slips.
You know, it becomes part of the artwork.
Is that different in music? I mean, you have a much more precise kind of thing as you're composing.
Yeah, I would say here the big difference is that I do have a like more traditional programming language, so I need to be careful not to segfault, which is unpleasant when you're working on a creative project. But I do have to say that the discoverability aspect and the like free-form aspect of programming in this way makes the act of music making fun in ways that I think are similar to what Lou was describing. Yeah.
I'm going to keep asking questions, but okay, good, thank goodness.
Did you ever find out yourself or somebody else using this for something you didn't expect it? Or they ask, can I use this to do? And you say, what? Why would you want to do that?
Yeah, so CellPond, I occasionally just search for it on YouTube. And I'm often quite surprised with the kinds of things people have made. And I'm really surprised by the range of things because some people just use it like just to draw pictures, which is nice. And I think that's why, like in these demos, I'm now just putting more time. Look, you can make paintbrushes. And this is something I learned from working on Sandspiel with Max Bittke. Sometimes these tools don't get used for coding until much later on. I've seen some very intense fluid simulations, and my favorite was from this week, and they might be watching, I don't know. Someone, you know Among Us? You know the character they made a fractal where it was the shape of an Among Us character, and then in each part of the body there were more Among Us characters, and then in each one of those, is it Amogus? I don't know. Anyway, yeah, it's always very surprising.
Yeah, in my case, I would say the thing that I didn't expect is how much I would get into learning more about like actual electronic music and how to build effects for music and so on. Like, this really wasn't something that I really thought about when I went to do this project, but it's so natural to be able to peel off layers of abstraction and then put them back on. That is just a natural part of making music with PA. But maybe it's also just because there's nothing, and so I need to build everything. So I don't know that a user that's using something complete would have the same experience, but I kind of hope so, because it's a great opportunity for learning, and it's really fun.
There's a question in Discord for Lou, if someone wants to read it out.
I could.
Lou is someone. I have a question. Yeah, sure.
Oh. Should I take this? Yeah.
Is it long?
No. Continuing the hidden state question, can CellPond have several layers on top of each other, or even go full 3D or 4D? 4D, wow. So that's a good question. So I used my earlier stuff was in 3D, SandPond, but that's still quite a good fit for this 2D rule manipulation, because you just end up only working in a single plane at a time. So like a rule can only work in 2 dimensions, even though it's within a 3-dimensional thing. Maybe that's the same with 4 dimensions. Never thought about it. But of course, like, it's harder to see inside 3D stuff. That's the challenge. If anyone knows a solution, maybe it's VR, I don't know.
Exploding diagrams.
Yeah.
That brings us to our first coffee break, though. Oh, I see a question, Todd. Is it a quick one?
Yes. For Xavier, when you are composing, most of us who have seen sheet music think of sheet music and the compositional attributes of musical notes and whatnot. When you're composing using your tools, do you think of the programming language that drives it as the creative visualization?
I mean, right now I mostly think of it as a hindrance, I would say.
Okay.
But eventually that is kind of the goal. I think if you look at live coding, which is what I'm trying to approach with this project, now, it wasn't really what I was going for at first, but it's kind of what I'm going for now. You can really see the source code as really a medium, a creative medium for representing music, and so I think there is that aspect to it. Does that answer your question?
All right. Well, for those online, we're going to take a half-hour coffee break. We'll be back in 30 minutes or so. Thank you to our opening speakers. You brought us to a great start for the day, and yeah, see you in half an hour. with Jonathan and Thomas's paper. The second block we have. Ooh, I don't have my slides up handy. Do you have them handy?
I have it, but I think we don't have time to show.
Great. Yeah, we're not going to show it, but we're starting with live and local schema change. This is Typcell under Storm, and if you're on the stream, I hope you're getting this. And Typcell, come on in.
Yes, we have three presentations.
Yeah. All right. Thank you. Welcome back. My name is Thijs van der Storm, and I'm here to present live and local schema change. This is joint work with Jonathan Edwards and Thomas Petricek. And we are from different organizations. I'm from University in Prague, and Jonathan is independent, so he gets the background picture, right? I mean, do you recognize this beautiful picture of the typewriter? That's from his blog, right? This is what this workshop is all about, right? Getting away from the typewriter. Okay, but without further ado, let's talk about live and local schema change. And this is actually a very old problem in the sense that we know this from databases. You know, you have a database, it has a database schema, sort of typing or structuring the contents of the database. And then you change the schema to a new version or, you know, a refactored version, but there is existing data and it needs to be migrated, right? So this is sort of in the database community old news, even though that the tools they use, you know, alter table, add column, these things are extremely primitive. But this paper is sort of based on the observation that this problem pops up everywhere in sort of live programming contexts and local first software or computing things. So actually this paper was also submitted to the PLLF workshop, I think. They rejected it, but I don't know why, but so this was a joint submission because the idea was that, you know, these problems are basically the same if you look them from the angle of live programming and local first software. So this is basically the basic picture, you know, you evolve the schema to a new version and you have to migrate the data. But you have sort of variants of these pictures where, for instance, someone copies or forks or duplicates a schema, starts messing around with it, populates the data according to the new version of the schema, and then this data needs to be ported, merged back into the old schema, or this is then not literally the old schema, but the other schema, right? And here you already feel the flavor of local first, right? Where people independently modify stuff, but in the end, this has to sort of converge again. Well, and this picture gets more complicated if the data is also accompanied with code, right? So if you have like GUI code that depends on the structure of the data, or you have like computations that refer to specific columns or fields or you know, locations in some data structure, because then not only the data has to be migrated, but also the code, right? In this talk, I'm not going to present any solution because it's challenge problems, right? And I think Jonathan will later present a solution to one particular setting. But we sort of see this also as a, well, call to arms is maybe a big word, but you know, if you have other challenges that look like this or can be added to this list, then please contact us. So what I will discuss is a number of challenges from the paper, not all of them. I will only discuss the ones in italics in the interest of time. And we'll start with a sort of standard one, extract entity. We know the refactoring from code maybe, you know, extract method, but this can also be done at the database level. Let's simply call it databases in this case. There is also a challenge in the paper about where spreadsheets are diverging. Empirical research in spreadsheets has shown that spreadsheets are copied and emailed around all over the place, and then, you know, they get modified in different departments of a company, and then they get sent up back, and then all these changes have to be merged again. It's like mind-blowing that people actually do this manually, but, well, this is what happens. Then there's an example from the structured document editing thing area. So think Notion. Does anybody know Notion? Yes, I would expect this in this audience. Probably you know it better than me. I only know the name and what it sort of does. So this is one that Jonathan invented or added to the paper. And there it's really about this, you know, different people modify a document and then these changes need to be merged again. And sometimes this is also in the presence of code. And then I will talk about live modeling, which is sort of my turf. I'm interested in language engineering aspects of live programming systems, and one thing that I've been studying is how to make modeling languages, like in model-driven engineering, more live, and that's also an area where this problem really pops up. And finally, in the paper, there's also a sort of similar setting or challenge problem in the context of Elm programming. If you know Elm, this has this beautiful idea of a single immutable value as the application model, and the view, the UI, is simply a projection of that. And then, well, I mean, this runs then, right? But what if you change this the data type of this model value, then you also have to adapt the view functions and maybe insert new values in the actual running model. So if you squint with your eyes, the live modeling and live GUI programming challenge are the same thing. All right, let's look at the first one, extract entity. This is a simple database on the left, and if you look carefully, you see that this is denormalized, right? There's a duplication in the address information, and well, one idea could be to extract this entity into a separate table where you list the addresses and then let the original table refer to that through a foreign key constraint, right? And in this case, it's just the customer name that is used to link these things, right? So at the schema level, super simple, but you know, with the data, you have to do all kinds of things. And also furthermore, there might be GUI code that depends on this, you know, the forms to edit this data all have to be migrated. And, and the challenge here is then how can we give better support for this, right? You can always hack this together, you know, with alter table, blah, blah, blah. And of course, just programming, but it's primitive. We don't want that, right? It should be more manageable and more automatic. All right, next one is about this merging structural documents. So here at the top, you see a simple document for a conference organization setting. And you know, some developer or user of this system wrote the list of invited speakers in an itemized list, which is nice, right? The invited speakers, and they have the email address and so on. And then a person on the left takes this document and thinks, okay, this is not complete. There needs to be another speaker on this list. And oh, by the way, I want to have this list sorted, right? So there's sort of constraint now that whatever you do with this list, it will sort the things in the list. On the right, somebody else makes a modification to the same original document, but here the change is a little bit more invasive. This is a refactoring from the itemized list to a tabular notation, where sort of the name and the email address are separated in columns, and there is an additional column you know, indicating the organizer. But no sorting, right? So it keeps the original order. So then the question is, how can this come back together again, right? So the end result that we want to see is that it's still sorted, it's in tabular notation, and it has the extra organizer column. And here you immediately see some of the sort of tricky things. What do you do with the organizer cell of the element that was in the left-hand side but not in the right-hand side, right? So you have to pick a default value, or you have to reject the merge, or you have to interactively ask for the organizer name, right? So there's all kinds of heuristics at play that make this a non-trivial, or at least not a sort of clear-cut automatic solution. Okay, that was the slide from the perspective from this Notion-like thing. But it gets harder if there is code involved, right? So imagine that there's some kind of spreadsheet formulas associated to this data. Then on the left-hand side, there's a reference, are references to paths in this itemized list, for instance. But in the other side, we have references into the tabular structure of the data, right? And you see literally references in the code to the actual sort of schema of this data, right? And how to merge those things in that case. Okay, that was Notion-ish. Let's look at live modeling. So here's a simple program. This is a much hated example language, namely the state machine language. I still use it because it's so simple, everybody understands it. So imagine you have a language with a little DSL modeling state machines, and here you have an example that models a door, right? And a door has two states, can be closed, can be opened, and there are events, on open, then you go to the open state, and on close you go to the closed state. So super boring. To make it a little bit more interesting, this state machine language has also global state in the form of variables. So there's this totally contrived variable there, is closed, of Boolean type, and it's sort of swapped in value as a statement when you enter a certain state, right? So this is a simple language, right? So imagine this language, this program gets parsed and it gets represented as a structure in memory that conforms to a schema. Then we could say that it is a schema, an instance of something like this. This is a sort of bespoke schema language that I invented for this particular paper. So you define classes, and a class for a machine. It has a name, it has a number of states, it has a number of variable declarations. Class state has a name, it has a number of statements as when you enter the state. Of course, a state has a number of transitions. The transitions has an event and a target state and a class declaration. Of the class declaration as a name and a type. And then the type and statement are omitted for brevity, right? So you could see this schema definition as a representation of the abstract syntax of this little modeling language, right? So now another, and then you can see, imagine that this state machine is run by interpreting, executing this structure in memory. And then you actually have an instance of this schema, right? So this is UML object notation, or at least a little bit close to it. So we have an actual machine where the name is doors and is closed is true. There's a state closed, there is a state opened, there are transitions that point to the right things, right? So you have this graph structured in-memory representation, and you imagine that there is some code that sort of runs this, it checks for the incoming event, and then it sort of makes the transition. So, and the key point is that, of course, at runtime, you need a little bit of more information, and you see that here, right? Yeah, I cannot, do you see a pointer here? No. Okay, so there are two red circles on the screen. One of them indicating the current pointer, a machine has a current state at runtime, and there is this extra field in the machine itself modeling this is closed variable. So what we see here is actually that this object diagram is not literally an instance of this abstract syntax schema, but it's actually an instance of an extended schema that declares these things that are implied by this specific doors state machine. So now imagine that we're editing this state machine, we're adding states, we're removing states, we're adding variables, maybe changing the type of the variables, and we want to apply these changes at runtime without shutting down the state machine, right? So then you get questions about, okay, what if is closed becomes an integer? How do I convert the actual value at runtime that is there, right? What if I delete a state, but it happens to be the current state at runtime? Do I reset the current state to the initial state? Do I take the previous state? Do I pick a random state as the current state, right? I want to maintain the invariance of the language as much as possible, but I have to apply heuristics. Alex?
Is the challenge here that we want to do it with
Ideally, yes. Oh, the question is if the point of the talk is that we want to do this with as little human intervention as possible, right?
Yeah, and I mean, we can talk more about it in the Q&A, but it seems like there's a happy middle ground.
Right, so I think there's no totally happy path here. I mean, it's basically unsolvable. Like git merge, is also unsolvable. It will never give you no conflicts, whatever, right? I mean, it's just not possible. But yeah, let's talk more about this in the Q&A. I'm almost done, by the way. So why are all these things the same, right? I think if you squint, you see the similar problems popping up at all these application areas, so to speak. So in the database, so all these things have a kind of meta definition, which may be implied by the UI or implicitly. They all have a sort of before and after, or like original and copy, right? And they all have a sort of axis of divergence. I made this up, this term. This is probably not a good term, but so in the database you have the schema is the SQL schema, and the before thing was denormalized or unnormalized, and then after it was a normalized structure, right? And then the axis was versions, right? Version 1 of the schema, version 2 of the schema. In the structured document situation, the meta definition doesn't really exist. Well, I don't know enough about Notion, but I assume this is implied by the UI, right? So how things are structured, there's no separate description of this schema. And the before was an itemized list plus the sorting constraint, and afterwards there was a tabular form with an extra column. And the divergence axis is the copying, right? So people copy things around and merge back again. And then in the live modeling example, the schema is defined by this meta model. I mean, this is a term for model-driven engineering. I know that PL people don't like this term, but I'm going to say it anyway. So a meta model is basically a class diagram, and that describes the abstract syntax of things. So the before is the abstract syntax of the program, the fixed static abstract syntax, but the after is sort of that structure plus all the runtime adornment that is sort of needed to execute something. And there the axis is static versus runtime, and then in the Elm example, it's sort of similar, but we don't talk about the meta model, we talk about the data type, right? An algebraic data type describing the actual application model of the system. And yeah, it's a bit of a contrived example in the paper where you sort of describe the application model as a list of items or a record of lists, right? It's sort of interchangeably. So it's like a refactoring. But the divergence axis is the same thing in the sense that you have the static code, you modify that, what should happen at runtime to actually keep the application running. All right, so that's why we think these are more or less all the same thing if you squint hard enough. And there are some general challenges or observations or lessons from this list. So the first thing is that in all these cases you want to do minimal harm, right? Nobody likes their data to be dropped or their structure to be mangled, or right? So the less disruptive these automated techniques that we want are, the better. Another axis is we want as much automation as possible, right? We know it's not possible, just like with diff merging in Git. There are cases where you have conflicts or you have to ask the user questions or let them, fill in the gaps that you cannot synthesize automatically. Conflicting edits, that is a real problem, is unavoidable. You have to do something with that. Also this is no data loss is a little bit from the do minimal harm, but you can imagine that if you define certain refactorings in your system, in the programming world, a refactoring is behavior preserving, but in this situation, we also want them to be data preserving. And you would expect that refactorings could support that, right? Because if they are behavior preserving, why are they not data preserving, right? Another thing is that, and I already mentioned some of those things during the talk, is that there are heuristics involved, right? Sometimes you just have to make a choice to do something, you know, a default value like the empty organizer in the document example. You have to maybe reset some things like this, you know, if you delete the current state of a state machine, maybe you reset it to the initial state, some kind of thing to sort of restore sanity in the runtime world. And there's ample type conversion stuff, right? If you change types, even already primitive types, then how do you deal with converting them? Or maybe you don't want to convert them, maybe you want to reject certain changes or let the user do it, right? Simple example, if you have in your database, you represent dates with times, how do you, dates with strings, how do you convert them to actual date things? You know, that's possible, parsing dates and then putting dates in it, but it's not automatic, right? Big example of that is Y2K problem, right? You represent a year with 2 digits, and now you want to represent them with 4 digits. How do you do that? So at the top there are some related areas of research. I think the general observation is that this problem is everywhere, but at different levels of abstraction and at different levels of dynamicity, right? So the database migration literature is full of this stuff, but it's all about very low level, hard, you know, stored data. It's not about, you know, clicking buttons in your live programming environment, for instance. Well, there's also operation-based versioning. I did a PhD in software configuration management, don't ask, but back in the day, there was this thing called operation-based versioning to improve merging of diffs. It failed miserably, but it's definitely related to this, right? So you have these little changes to things, and then you compute the effect of on other things. There's some stuff from other sort of research areas there. Most importantly, maybe, is the lenses thing. Some people in this room know a lot about lenses, I believe. And this actually has also led to a whole community called the Bidirectional Transformation Community, also nicknamed BX. It's pretty dead now, but it used to be, you know, dark stools and papers and workshops and everything. It's too much to mention and to consume, actually. So, yeah, so with that, I would like to conclude. Please send us other variants or instances of this problem, maybe for a future workshop or for a future paper. You all know Jonathan, and you can find me and Thomas also online. So with that, thank you.
Yeah, I'll let Jeffrey take this one first, since he and I wrote this paper together.
Hey,
hi.
Great talk. Thank you for pointing out this important problem.
Thanks.
My question is about, it seems to me like a great way to learn about the real problems that come up here would be to find real-world examples where these problems occur, and in particular in the live programming world. I'm curious if you have thoughts on where we might look to find what the real problems are. I think Smalltalk is sort of the most obvious example that comes to mind in this world. I'm sure there are people in this room who can talk about,
right,
you know, how these problems emerged in Smalltalk and what solutions that community came up with. But I'm curious, like, do you all have thoughts on other systems we should all be looking at for problem inspiration?
Okay, yeah, so thank you for that question, also for bringing up Smalltalk. I mean, Smalltalk is a live programming environment, but it sort of closes its eyes for migration, right? So it basically, you know, it deletes fields if they are gone, and it initializes them with nil if they are new, right? So there is no first-class migration semantics. I mean, you can program everything, right? I know this, and then you use become to fix it all up, and then, but it's sort of like alter table, right? I mean, it's like manual, and I think this should be first class somehow. And one of the things I'm trying to do in my research is to literally use this database sort of technology to think about or to reason about this. We did a paper that was also not a success, but where we used constraint solving to basically solve the heap towards, you know, the closest thing that is compatible with the new program, right? Super cool, doesn't scale at all. I mean, even for the state machine language, it's like too slow. But you know, I'm looking for things that are less operational and more declarative in the sense that you get this live behavior.
Can I try answering?
Yeah.
I mean, that's a really great question. And the purpose of this paper is that we don't have an answer, and we feel that we're all in denial about this problem. This paper is a cry for help, that we're all in denial about this. The Smalltalk people, you bring this up, and they say, no problem. But then you really talk to people, you know, over a drink, and they say, yeah, we have to like reset our image all the time because it gets corrupted. But they won't admit to this in public, right? So we're all in denial about this problem, and we always have been. And so we're trying to just bring it out into the open. And this is just encouraging us. Let's talk about this problem.
I'll throw to another question I saw back there in a sec, but I'll maybe offer some comments from the field then, because I have felt this pain firsthand. And I tell this story often, I think it's in the Cambria paper, but I was working on Pushpin, which was one of our prototype projects, and I noticed that the fans on my laptop were getting really loud. And it was because we were using shotgun type migration, which is basically the idea that just wherever you go to read a data field, you check to see if it's there, and if it's not, you just make up what you feel like you need to do on the spot in the moment. And they call it shotgun migration because it basically blows a hole in your program, and it's just riddled with little migration code throughout the system. And it's a great source of security vulnerabilities, which is why this concept came from the security community. But anyway, so my laptop was getting really hot, and it's because my coworker had opened up the program on his machine, and we were in live collaboration, and my version of the code was migrating a field, and then his version of the code was recreating the field. And mine didn't check to see if it had a new one already, it just checked to see if the old one was there. So he kept making the field, and I kept migrating it, and it got hotter and hotter and hotter as fast as the network could send messages back and forth between our machines. And that was the day we decided to start working on this problem, because that then also created such a big blob of like useless history in the CRDT that we couldn't load that document anymore after that day. So this is why we wrote the Cambria paper. So the Cambria paper, I don't want to bore everybody with it today, but I'll put a link in the thing. But the basic, I've figured out how to explain the strategy very succinctly, which is always present data in the form that the program expects. And when you make edits, record the schema that you used. The last step is to have a way to translate between schemas, which is difficult but not basically strictly mechanical. And if you record changes as they happen, you can maintain this. Now, there are some unsolved problems that didn't come up in here that I will mention from the wild. One really big one is that your schema is a lie. It is at best a small subset of your actual constraints. And in fact, all real world schemas represent only like a fraction of the true constraints that a system has. And I don't even mean just like performance constraints, but like, you know, phone numbers don't all have the number of digits you think, or you know, people put in hyphens or parentheses and things. There's all kinds of crazy stuff in the wild, and that's a thing. The other thing is when we built this Cambria system, and then we started thinking like, oh, it'd be cool if you could like use it to interoperate between cloud services, which like on the face of it, you can solve the schema problems. That's the easy part. But then, you know, your issue IDs between two different issue trackers, you know, you can't create those with your schema migrator. The API from that cloud service has to. So you have all of this unmodelable, unmappable, untranslatable data in the thing that you need to find mappings for. And then the third problem is really just an operational problem, not a computer science one, but it's that you're not allowed to act as other people. So if you can translate the comments on the issue tracker from somebody else commenting so that you can read them, but you can't write those comments into the other API because you're not that person.
Right.
And they might not have an account in the other system, so what's the user ID you're going to use for them? So these things kind of killed that short-term effort and I think are big problems. But I think figuring out what to do about unmodelable constraints basically means that you need human-in-the-loop intervention at some point, no matter what, and everything else is going to be, you can reduce the frequency of that, but there is a hard limit on how far you can take it. Anyway, that's my rant.
I agree. Thank you.
I'll pass the mic now.
Hello. So I'm just obviously a wee bab and don't know how hard this problem is. I've read a bunch of lens papers and it seems like that doesn't solve the problem. Like, to your point, you can't get rid of human intervention, so I don't understand the second goal here of minimizing it. Like, why would the goal be to minimize user intervention instead of to make user intervention as smooth or as nice as possible, right? Like, rather than saying, okay, we're trying to get some theoretical thing of like, you intervene as little as possible, and then we're going to use some heuristics like, oh, we'll just insert a default value so that we don't have to ask the user for the value. Like, shouldn't the goal be, like, it's way harder to evaluate, does this make it easier for users to actually use, but why not, why should the goal not be to go for that rather than like, we're trying to make it as few like questions to the user as possible?
Sure. So I'm not against that. You could see minimizing it is a subset of trying to make it easier for the user, right? There are other ways of, improving the interactive things. But I can imagine that in some cases it also wouldn't scale, right? Because you don't want to click on 1,000 things. If it's possible to do it automatic, or, you propose a fix and the user presses OK if it trusts it, right? Then why not automate it if you can? So I don't think these are not aligned with each other, your remark and this statement.
One more question.
So I think it's been interesting to see you bring together a lot of the different problem areas where these same challenges apply. And I presume that the next step is to look for some kind of like formalism or taxonomy where you can like bundle things together and use this as a toolkit that like programmers can use. They come to this toolkit,
right.
They can easily map a tool in this toolkit to their own problem. And there's a little bit of this here already with like these heuristics are like examples of tools in the toolkit. But when you look at, say, the table that you had a few slides ago where you compared different problem spaces as a path towards getting to that toolkit, it's still very like fuzzy. It's not like a rigorous kind of theorem. And so I'm curious if you have a sense for like what the next step is. I mean, I think within particular domains, there are strong formalisms, like say in database schemas or CRDTs. But have you found like domains that you think are like ripe for being merged into a single cohesive formal model?
Well, I think that the biggest problem is that if you want to go that next step towards a toolkit or a formalism, you have to commit to a schema language, right? And this will always sort of leave things out or unmodelable, right? There is a paper by Ilko Visser who has made this catalog of model transformations based on a fixed sort of database schema language, and he sort of lists all the changes that you can imagine and then how to sort of automatically implement it, but it's probably not useful for something like this Notion use case, right? So I'm very happy to commit to a certain schema language, I think, from there on, but probably other people will be sort of not amused or bored or, angry, I don't know. But of course, I think technologically, the way further requires an actual schema language, right? Not implicitly defined. So I hope that answers your question. Okay, all right. Thank you.
That's not right. That's not right either. Try this. Hey, much better. All right, we're good to go. All right, hello everyone. My name is Anton. I'm a third-year PhD student from Lund University in Sweden. And today I'd like to show you CodeProbber. This is joint work with my supervisors, Jarl and Niklas. And yeah, CodeProbber is an exploration tool for compilers. I'll spend most of my time today with a live demo, but I'll first begin with a small introduction into what the problem is we're trying to solve and where it fits in the world of programming. And the problem we're trying to solve is programming is hard. I think everyone in this room is trying to solve it in one way or another. People are creating programs, and because it's hard, they might make mistakes. So one common mitigation to this is we write compilers or static analysis tools that look at your code and point out when something went wrong. You might misuse a type, you might miss binding a name before you use it or something like that. Now these are great, but where did they come from? They're also just programs, and someone else created them. And they might also have made mistakes. And that's where CodeProbber comes in. It's an exploration tool for the tools that look at your code. It's one step removed from normal programs. It means my target audience is quite narrow. It's people who create compilers and analyzers. But I think that narrowness allows us to do something quite interesting. That's all the background. Whoops. Oh, this is super zoomed in. I'll zoom out a little bit. So this is CodeProbber. It's a client-server-based application. The client is written in TypeScript, runs in the browser. The server is written in Java, currently runs on my machine, but it could run somewhere else as well. Most of the surface area is a text editor. This is the Monaco text editor. You've seen it in Visual Studio Code, for example. But the thing that makes CodeProbber interesting is this little window. This is what we call a property probe, or just a probe. And it's like a magnifying glass that looks into the compiler at one particular operation it's performing. In this case, the compiler has this sort of analysis that checks whether a declaration is final or not. This is one of the simplest forms of analysis a compiler does. The top half of the window is the input to the probe, which tells us we're looking at a variable declarator. The property name is final. And this here is the span where the declaration exists. And when I hover over it, you can see the span in the source code gets highlighted as well. And then the output says it's false. One of the most important things about CodeProbber is that everything you see is, well, live. It reacts to changes as soon as they happen. So if I add final, it becomes true. If I remove it, it becomes false again. But this is not a very interesting analysis, so let's upgrade. Oh, I forgot. I mentioned earlier, this is not a compiler by itself. It's not an analysis tool by itself. It's merely a visualization tool. So we're looking at Java because I'm currently exploring a Java compiler. But you could swap that out with another compiler if you want. Just so you know, this is not Java unique. So what I now like to do is ask my compiler if it can figure out the compile time constant of this addition expression right here. To do that, I'll right-click, create probe. Now I get a list of all the AST nodes that overlap with the place where I clicked. So I clicked on the number 2, so that's on top of the list. That is part of an addition expression, which is part of a declarator, and so on and so on. And when I hover, you see the span gets highlighted. I'll select the addition expression, and now I get a new list containing all the properties that I can inspect. So this is a full Java compiler, so there's quite a lot of functionality here. And I'll use the filter to select what I'm after, constant. And there we go. It works. I can make changes. Again, changes update. When I enter an invalid state, it will crash, because CodeProbber does not just handle the happy case. It tries to also show you when you made mistakes and capture those and show that in the UI. That's pretty cool, but we can go one step higher in the complexity. This is a Java compiler, after all. We can ask it to generate bytecodes. So this is the bytecode representation of this method. And again, as with everything else, if I make changes, it immediately updates. When I first started using this probe, I didn't know anything about the Java bytecode format, but now I think I know quite a bit because I've been playing around with it quite a lot. CodeProbber is not only for finding issues with programs, it can also be really useful for educational purposes, just to play around and see, how does this work? What if I change the input to this? What is the output? You may have used a tool called Compiler Explorer, godbolt.org. Well, this is a very similar thing, except you can do it not just with code generation, but with all properties in your compiler. And if I were to make some more changes, this is supposed to be nonsense code, just showing that it's updating as I'm typing. Yeah, here you see how branching and more variables are handled in bytecode. All right. Certain kinds of analysis, they rely on the control flow of a function to do their work, and CodeProber can render that as well. To begin with, many people when they see this, they think, well, I wonder what the colors mean. They are randomized, so they don't mean anything. They're just there to make you show where one arrow ends and the next one begins. But again, if I make changes, you'll see it also updates live. So if you do control flow graph-based analysis, that might be something you want. One thing I really like about CodeProber is that I'm actually interacting with the AST here, but I haven't shown you the AST. It's sort of hidden away. Some people want to see the AST, and we can do that too. And so this is the actual data that I have been interacting with all this time. And I can again hover over things. I can click to create probes and so on. There is some things that CodeProber can do for you. So far, I've only shown things that sort of, well, except for the AST view, I've shown things that the underlying tool provides for me. CodeProber does very little. It can do things like searching. If you're not sure of a certain node you're looking for, you just want to find all nodes that fit the criteria. You can do like question mark equal type equals int. This will select all nodes where the type is, well, int. I can extend this filter and say, actually, only give me the things that are constant. Now we only get the literals. If I change the declaration to be final, again, it updates. So yeah, if you're not sure which node you're looking for, you just want to find everything where something is true, you can do it this way. All right, I'll end the demo by doing a small little demonstration of what it's like to use CodeProber as a development assistant while you're working on your compiler, making revisions. Let's say I've worked with my compiler for a while, and I noticed that something is wrong with constant propagation for multiplication expressions. This does not look correct. It should be 246, and I can sense that it is using my input somehow, but not correctly. So I'll skip ahead in time a little bit and say, okay, I figure out what's wrong. I'll go to my editor. Whoa. I'll look up the place where I have defined this constant expression and see mulexpr.constant is the left operand multiplied by the left operand. This is probably not what I was intending to do. So I'll change the left to right and recompile. So now I'm actually rebuilding my compiler. I've shown you a lot of interactions in CodeProber where as soon as I made a change, the probe updated. CodeProber also monitors the file system so that whenever you change your compiler, the probe updates. So if you have multiple monitors, I recommend putting CodeProber on the secondary screen, and it will open a few probes, put it there, and then it will keep showing you live values as you rebuild your compiler. Okay, that was the demo. So we looked at some very, very simple properties like isFinal. We generated bytecode, looked at the control flow graph, and some other features here. This was all done with XII, which is a Java compiler. It's written using a meta-compilation system called Justad, which uses reference attribute grammars. And in one sentence, with RAGs, you place computations on top of AST nodes. And that's what allows this type of interaction that you just saw, because you first select a node, then you select a property, and all the functionality is on the AST nodes. That's what enables CodeProber to work. A colleague of mine is trying to visualize the set of properties that exist to find out if there's cycles of dependencies between them for optimization purposes. So he gave me some screenshots from his tool. Each circle here is a property, a piece of functionality inside the compiler. The lines indicate the dependencies. If I zoom out, these are all of them. There's 2,500 properties in this compiler, give or take. Imagine if you're joining a team working on this compiler and you're told, hey, improve this, work on it, add some feature. It's quite a lot of functionality to get into. Something I like to do in that situation is start to playing with it, give it some input, see what output comes out. And to do that, you need to go through some form of entry point into the program. Perhaps you can run the type checker to generate semantic errors. Perhaps you can start a language server to interact with it that way. Or if it's a compiler, you can, well, generate code. Bytecode in this case could be assembly code as well. With CodeProber, instead of having like 3 or 4 entry points, you have all of them. Everything becomes interactable. I'm very biased, but I think that's pretty cool. Of course, with an asterisk, it only works for tree-like data structures that put computation on the AST nodes. But if you could make something like this that works in a more broad context, I would love to try it. I think this way of playing with programs is really powerful. CodeProber does work with non-Justad compilers as well, as a disclaimer. I've talked about Justad so far, but the tools to the left, Spotbugs, PMD, and Wala, they work in CodeProber, not written in Justad. And it's not just Java. We have ChocoPy, which is a subset of Python, and simply C, a C-like language, that works as well. If you're interested in integrating it with your tool, if you do computation on a tree, please let me know. I'm happy to help. All right, I'll end with some case studies of using CodeProber in courses. So, first course we use CodeProber in is a compiler construction course. Students go from not knowing anything about compilers, and in the first lab they do simple scanning and parsing with a handwritten scanner and parser. And then in the last lab they do code generation. They generate assembly code, link it to a binary, and run it. And every lab sort of builds on the previous one. Somewhere in the middle, they start defining these more advanced properties to perform interesting computation. And we introduce CodeProber to them there. So I gave them a short presentation saying, this is the tool, this is how it works, here's how you create a probe. You can use it if you want. And then at the end of each lab, we ask the students, so did you use it? If so, what did you think? So informal interviews. We've done this 2 years now. The first year, CodeProber was quite new, so it didn't have that many features yet. We got mostly positive feedback. One common point of feedback from students was, I don't have a mental model of the AST. Like, I don't understand how source code maps to the AST, and then there's features on top of the AST. They would like to see the AST. So that's why we added the AST view that you saw in the demo. Roughly a third of the student groups regularly used CodeProber in the labs. This year's instance of the course, it ended 2 weeks ago. No real common point of negative feedback, because mostly people were happy. Some technical issues, but in terms of features, they seemed a lot more positive this year. And we have around 2/3 of students regularly using it. There are other factors as well contributing to this group, but we can see, or it seems like they're happier now. And it doesn't help for today, but we have better course evaluation coming in a few weeks. One course where we do have numbers from students is in the program analysis course. Similar situation, there's a series of labs, but instead of the students writing everything from scratch themselves, the teacher gives them, here's a finished compiler, now you add analysis on top of it. So this is a different kind of challenge. Now they have to get into this code base that's relatively big and understand it, and then add their analysis on top. And I think CodeProber can work pretty well here too, with the sort of exploratory, playing around to see what happens for a certain input and output. All students used CodeProber in this course, which sounds really positive, but actually they were forced to, so it doesn't really tell us much. They had to do it to present the labs to the TAs. But in the course evaluation, we had this statement. CodeProber was effective at helping me discover and understand bugs and omissions in my analysis implementation. So this was written in the evaluation, and then they had to answer fully agree, fully disagree, or in between. We only have 15 people who responded to the survey, but there's a clear trend. People seem to be happy with it. Yeah, so I don't have that many more evaluations of CodeProber yet. Unfortunately, it's something we want to do in the future. It seems like people are happy with it in the scope of creating compilers and analysis tools. Something we might do in the future, looking forward, is code review. I don't know if, well, probably most of you have been in a situation where you're reviewing code. In a larger team, you're all you start from the same code base, you make your changes, and then you put up the changes in a pull request or a merge request, and you ask someone, can you look at this, approve it, so that I can get merged back into the main branch? And it's not a very fun experience, I think. Most people are, well, I've never spoken with someone who said, I love code review. Most of them say, it's not very fun, but it's necessary. What if you could just like right-click and on a complicated-looking method and find hey, give me all the related test cases to this method. And then you can look at the log file from running that method, and you can diff in the previous and the new version. Like adding probes, it's already written with the client-server model. We think this, oh, it doesn't look very good on the projector. Well, I think this could be a really nice way to enhance the experience of doing code review. Wow, I'm done 4 minutes in advance. What's wrong? Thank you. So, yeah, I recorded a video of the demo you just saw. It's on YouTube. I'll put the slides up on the live webpage later if you want to get them. We wrote a paper about this, submitted to SLE last year, so you can read more about the underlying technology of how CodeProber works. For example, I didn't show this, but if I move this expression around, it stays, it keeps tracking the node. Even if I make structural changes like wrapping the expression here inside of an if statement, it still is able to track it. Also, it can track nodes that are external files or built into the compiler. Yeah, that was a lot of work. It's more like a third of the paper is just how we track nodes. If you're interested in that, please check it out. And finally, CodeProber is open source. It's BSD licensed. You can do whatever you want with it. Look at the code, play around with it. And if you're interested in integrating your tool with CodeProber, please ask me and I'll be happy to help. Right, questions?
Cool demo. I really love the floating window. I was thinking about, for code review, just like a comment before I have a question, I would love to see the control flow, because I know that like the first time I'm reading through a larger pull request, the first thing I'm building, I read from top to bottom to try to understand how all the changes relate to the different chunks of like, oh, this calls that and that kind of stuff. So I have to like build that in my mind by reading the thing, and then I can actually do review, which is kind of an annoying step. Yeah. If I could just visualize it, it'd be way easier.
Yeah, we could do a diff of the control flow graph almost and highlight those arrows that are diffing more. Yeah, that would be really cool.
Yeah, it would be really helpful, because then I could read it in control flow order as opposed to alphabetical.
Yeah.
But I was curious about another, you mentioned other use cases where this thing could be useful. I was curious if you thought about applying this to documents, because documents also have an AST, like if you're doing Markdown or any of these other things, like if you look at the HAST, H-A-S-T ecosystem, like the entire ecosystem is taking different document formats and converting them to ASTs. And so they have this sort of actually surprisingly formal structure. When you look at a prose document, you might think there's not a lot of structure there, but there is quite a bit that could be explored using kind of the same user interface, the same. It's just a separate set of formalisms. So I don't know if you've thought about applying it that way.
We have not. I'm trying to think of what's an interesting property you would like to look at in that situation. If you could handle it, yeah.
Sorry, a couple of things that came up would be like headings, paragraphs. Like you could basically like expose the entire heading structure of the whole thing. Like show me all my H1s. You could, and then there are other things that are unique to like English language or like language in general. Of like show me imperative statements, show me questions, show me like you can. Yeah, so that would be.
Yeah, so like advanced. Okay, yeah, very very interesting. No, we hadn't thought about it, but I'll think about it after this. Thank you.
Thank you. Very interesting talk and demo. Can you go back to the slide with the visualization of all the different properties? Just trying to understand a little bit better what you mean, or by each property, are you referring to like a different attribute occurring on a different non-terminal, essentially, or like the 2,500?
Yes.
Number.
So I have a bonus slide.
Okay.
So I was going to talk about what I mean with a property in more detail. I thought I didn't have time, but now I was 4 minutes early. So most tools, all tools that I know of, probably not all of them, but you take this source code and you parse it into a tree structure, and then you associate properties with the nodes in the tree. I think to this level, this is how all tools work. They associate intrinsic properties with the nodes. Something like the declaration. We know the ID being declared here. It's X for one of the declarations. We know the literal value of integers. What just that does then is to place also computed properties on the AST nodes. These are the ones in orange. These are slightly more complicated. The parser cannot figure this out. At parse time, you have to do it as pass later or somehow do it later. Something like, what is the compile time constant of this addition expression? Well, that requires you to find out the constant of this variable reference, which requires you to find out which declaration it's referring to, which requires you to, like it's the clauses chain of things that needs to be computed. So when I say property, it's these boxes on the next side of next to the AST nodes. Yeah.
Thank you. Hey, Will Creighton from Brown. So your diagram at the very beginning showed CodeProber at the very top, but it leaves out the question of who's supposed to help you build CodeProber.
That's you. It's open source. You should help me.
So my question is, first, what was most difficult in implementing this tool? And second, are there certain frameworks that you think could be built that would help you either at the front end or the back end to build this tool more easily?
Yes, okay, thank you. What was more difficult? I think it was the node tracking. There's two challenges to tracking nodes. While the user is actively mutating documents and structure completely changes and they might copy and paste several lines at once, you need to do it in a way that's both robust to handling changes and quick. Otherwise, the experience is really bad. In the beginning, you could wait 2 or 3 seconds between typing and getting the result. Still pretty cool, but not all as cool as what I showed today, I think. So we worked a lot of how we track accurately and quickly. And there's some benchmarks in the paper showing that if you have a project with 100,000 lines of code and you have 15 windows on screen, then it updates all of them within 40 milliseconds. So we managed to push down to the point where the only thing limiting you in how many probes you can use is the size of your screen, more or less. So yeah, tracking nodes.
And is the work that you did very specific to your domain and your tool, or do you think there's something more fundamental here that could be extracted out that would be useful more broadly in live tools, is kind of what I'm getting at.
Okay, yes. The node, okay, so the title of my PhD position is cloud-based language tooling. How do you build tools that run well in a client-server environment? And this locator data structure for how do you describe computation at a distance? I'm the client, the server is over there, has some form of data structure. How do I describe the tree and the computations happening there? That's what this tracking thing really is. CodeProber is just a realization of, well, okay, we have this algorithm. What do we make of it? Well, let's make a compiler explorer. But I think you can take the tracking data structure and use it for other experiences as well.
Cool, thanks.
That's been waiting a long time.
Yeah, I think so too.
Hey, thanks. That was great. That was really interesting. Could you say a bit more about so you had the visualization where you showed bytecode and you hover over the bytecode and you can see the associated source code.
Yes.
Can you just say more maybe about how that, what's needed, what you need to change in the compiler to support that? And because having built visualizations like this, I know that often you end up, having to put a bunch of stuff in the compiler that's specific to the tool, or at least that's what I've ended up doing.
So this is a great question, thank you. This is Godbolt, the compiler explorer I mentioned earlier. It also has the same thing where I can hover over the bytecode here and I can see the corresponding line getting highlighted. So the information needed to do this is already present in most class files. You have the actual bytecode instructions as one, I think it's called attribute in the class file. Another attribute is source something something. It's the mapping from attribute offsets in the attribute array to which source line does this correspond to and which source file. So we just combine the array of instructions and the array of positions. In terms of code, I think it was 15 lines of code I needed to add to make this appear specifically in CodeProber with this highlighting enabled. Then I could just reuse the rest of the code generation code that existed. We try to be as much plug and play as possible, where you can look at properties that you already defined, but you can also then create some more special properties, like the one rendering control flow graph or this highlightable lines of text that enhance the experience. We support both. Yeah, 10, 15 lines of code.
Cool, thanks.
Last question, I think, here. I know there's so many. Ask them in the Discord, I'm sure.
Well, yeah. I'll be here until Friday, so.
Thanks for the great talk. I'm wondering if you've undersold the value and potential applications of your work, though, because in that first diagram you said it was for the compiler writers, but I'm wondering how can I use this as a programmer using, writing Java code or whatever, and you hinted at this a bit in code review, but I'm curious, yes. Can you talk more about how do you think people might use this in the flow of doing programming. It's not live programming on the runtime data, it's live programming on the compiler structures, right? And how do you think about, like
Yes.
I think type error red squigglies are an instance of live feedback on compiler structures, and is this a generalization of that idea?
So I didn't show this, but we have squiggly support as well, of course, in the tool. Yeah, code review I think is one of the simplest answers to your question. This is something that could benefit most people. The challenge here is the term AST node is not very clear to most programmers, I think. You need to start reading a little bit about compilers and to understand what the tree structure, what the nodes are called. Like, if I tell someone, hey, create a probe on the variable declarator, they might be able to figure out what it is, but it's much easier if you're actually part of building the compiler. So you need to create some prettier presentation layer on top of this to make it more usable for most people. I don't think the actual code review UI will look like this. I think we'll take a few of these probes and put a prettier coat of paint on it and package it more nicely. I think that's what's required to make it more mainstream, let's say. But for now, we made our lives easier by just targeting people working on compilers and analyzers.
Makes sense, thanks.
Yeah. Thank you, that was a great question. Yeah. Thank you.
All right, hi everyone. I'm Josh Pollack from MIT. Some of you may notice the presentation environment I'm using right now. And if not, it may become clear in a little bit. I'm going to be presenting a more theoretical talk called Language Model Agents Enable Semi-Formal Programming. And I want to start with a provocation, which is how malleable is malleable software really? So when we think about malleable software, we might think about spreadsheet environments, or maybe browser extensions, or Apple shortcuts. And what's common across all of these is that they all use programs. And programs are kind of like brick walls, right? Brick walls are nice, they're sturdy, they're rigid, they're precise, but they're also pretty impenetrable for end users. And the thing about programming is, programming is often an art of formalizing some very informal thing. So if I'm, want to make an Apple shortcut, I might start with some informal task description, for example. I want to make an Apple shortcut that creates a new note with the current date in it. And maybe this is plugging some hole in my wall, right? But then there's a very long process of sort of, breaking that task down into individual pieces, maybe coming up with some informal plan, and then gradually formalizing bits and pieces of that plan to create a final program. But the problem with a lot of programming environments is that they have no way of understanding ideas that are in this sort of unfired clay form. And so while a user's perspective may be kind of this, where part of it is this well-defined wall, and then there's this sort of unstructured part in the middle, the view from a typical programming environment is that of the wall with nothing in the middle. And when you have this, it's impossible for your programming environment to actually help you. And projects like Hazel try to help this a little bit by essentially making sure that a wall with a hole in it doesn't fall down. But if I try to do something in Hazel like, add today's date to 2 and 3, Hazel doesn't have any notion of what today's date is, and so it can't, it's not going to blow up in your face, but it can't evaluate it either. So this is where kind of LLMs present a really interesting opportunity, which is that they let us reason about this unfired clay stage of programming. And specifically, I want to highlight kind of two analogs to how we think about programs that LLMs help us do. So one is LLMs can execute an informal specification. So for example, I can just ask ChatGPT to extract numbers from a recipe, and I'll get this nice bulleted list of numbers. Another thing that LLMs can do is essentially act as a compiler from an informal specification to a formal program. So I can just directly ask my unstructured task, like I want to create an Apple shortcut. I'll get a list of all the actions to do. I don't think I made a shortcut before this demo, but this instruction set is what I use to create this note, which essentially does exactly what you want. You take the current date, you format the date in some particular way, and then you make a new note with the formatted date. And so this gives us a capability for working over here on the left with unstructured clay. And we have compilers and interpreters which help us with this fully formalized program. But what I think is a really interesting emerging opportunity is how do we help people in this middle process, this large sort of complex process where parts of their program are unstructured and suitable for LLMs, and parts of their program are suitable for programming. And so that's why I kind of want to to name this space, I want to talk about it as semi-formal programming. It's partly formal and partly not. And to get at what this space kind of looks like, I'm going to come both from sort of the LLM side and see how we can get more formal, and from the programming side and see how we can get less formal. So the first thing I want to talk about is kind of what does it kind of look like today to sort of work within the semi-formal world. And I've kind of identified 3 interaction techniques that people use here. So I'll start with the simplest, which I call direct, in the sense of like directing a model to do something. And what you'll see is within the sort of programming world, you treat an LLM as basically an API call. So this is an open source tool called LLM Parser. And in LLM Parser, you define this sort of structured representation of things you might want to parse. Let's say you're searching for a job. Job listings have all these sorts of different formats, but I want to know what's the job title, what's the company name, what's the location. So I define this little kind of structured representation. I have a job posting, and then I just call this parser function, which essentially internally is just saying, hey, ChatGPT, tell me the job title, the company name, and the location, and then I get some formatted piece out. So this is taking one step away from programming, where you have these building blocks of little informal pieces you can plug and play in different spots. On the other hand, we have this kind of weird space of doing a lot of things in the LLM, but kind of with more internal structure. So we often think of LLMs as doing like one call at a time, but people are exploring extending LLMs with additional tools like search, querying a database, sending messages, or even calling itself in kind of recursive ways. And I feel like it's easier to see this sort of play out than to talk about it. So I'll show an interesting demo in a second here. But this still is very much living in the unstructured world, where people often use these systems by presenting very, very unstructured high-level goals, like please learn about AutoGPT and explain it to me, or make money, or yeah. And so I want to kind of show this demo of how people interface with AutoGPT. It has some great backing music. How do I get the audio? I need to, here we go. Is this going? There we go, okay. Whoa. This is like skipping, I've seen this issue before. Does this work? Does the aux work? Okay. Well, I will just manually skip to the timeline, and I'll pretend that there's like cool techno music behind this. So basically, a user is working in some command line. They type in some prompt. In this case, it's like, tell me what AutoGPT is. And then AutoGPT on its own generates some list of goals. So here it's search AutoGPT, find the GitHub, figure out what it's about, explain it, and then dump it in this text file. And then the user's main interaction here is like saying yes or no to these things. And then AutoGPT has this whole like internal structure where it's like, oh, here's my plan, now I'm going to critique my own plan, and then it can go on this loop and just keep looping forever until it thinks it's done. In my experience, sometimes it will just loop for 20 minutes in segfault, which is a really great user experience. But when it works well, it's doing this very complicated sort of unstructured thing, but internally building its own little pieces of semi-formal structure, like an internal plan, a critique of the plan, and then calling some actions for other tools. But one area that I think is especially interesting, especially for the live programming audience, is this sort of emerging middle ground, which is this very large, discussions between LLMs and users to cooperate to accomplish very complex tasks. So a few months ago, Figma announced this Genius Chat API, which is essentially this little text box that you can use to modify your Figma design. So here the user's asking to add imaginary songs, and then the Figma genius is saying, oh, so you want to add some imaginary songs to your music app. Let's create a list of songs and add them below the album information. It presents, it makes that modification, but then it also adds this little bit of structure for what the user can do next. So in addition to just this unstructured chat, it's presenting this little sort of in situ structure of like a few kind of predefined buttons. Going even further, Amelia Wattenberger just a couple weeks ago demoed this system at an AI engineering conference for building these sort of ephemeral UIs to interact with web pages. So her example was booking hotels on Airbnb and hotels.com. And essentially, given a website, an LLM and a user can interact to build a bespoke interface for working with that. So in the case of Amelia, she wanted to know how long the walk was to BART, how long the walk was to the hotel that the conference was at, and all this information is personalized in a way that like the original website is not. After a few more rounds of iteration, we see kind of more complex display with some photos extracted, but also ways to send information back to the original website through these action buttons here at the bottom. And this interface can be sort of directly transferred to a different website because under the hood, the LLM is doing the support to kind of paper over the differences in the two interfaces. So this is kind of a way where at least from the user perspective, they're using a little bit of structure, maybe not writing the code themselves, but it's sort of relying on a mixture of traditional sort of web scraping methods and also building kind of interfaces automatically. And so this collection of systems taken as a whole seems qualitatively different. I mean, it's not a program in the traditional sense, but it's also not just an LLM. It's sort of something in the middle that has a little bit of structure. And so that's why I like to call these, language model agents. They're agentic in the sense that they're interacting with the user in a particular way, but they're also sort of based on language models. And from the language model perspective, this looks like LLMs being augmented with this ability to run programs, read, write from applications, use storage. And from the code-centric view, this just looks like embedding LLMs as API calls into normal programs. So to return from this image to from before, the way that we're kind of transforming and running semi-formal programs is via these language model agents, which are exposed with these abstractions and then kind of used using these interaction techniques. But another thing we might want to consider is, how do we actually represent these semi-formal programs? And here again, we kind of see from two perspectives, like what does it look like from the LLM's perspective and what does it look like from the code perspective? So from the code perspective, this is often, you can think of as an abstract syntax tree where the leaves are some kind of unstructured data. So for example, in this parsing example, right? We have like a type here, right? It's a list of objects where each object has a name, a description, and a type, and those are all strings. But if we look a little closer at the description of this type here, the description is not just a string, it's really instructions to help the LLM. And so there's some kind of semantic meaning to the type of string that you couldn't capture in TypeScript, for example, but that has there's some sort of semi-formal structure within that. From the view of LLMs, the way an LLM views this data typically is as some kind of structured text. So LLMs can only take in text, but within text you can embed, let's say, a formal type for what you want the result to be, some informal type, so here it's like name-description, and this is some sort of like text output thing, and then some like totally informal like instructions, like, okay, pick a type if you're very confident, there may not be a type if there's no type, right? So there's this mixture of like super formal things like TypeScript types, completely informal things like instructions, and then these sort of also quasi-formal structures sort of in between. So I want to kind of close by saying, so this is sort of the state of the world as it is right now, where we kind of have the like, what is this middle semi-formal thing viewed from LLMs, and what is this semi-formal thing viewed from code? But I think there are some interesting places we can look if we want to think about stuff that's kind of native to the semi-formal world. And that's to look at semi-formal languages embedded within natural language. So one nice example of this is domain-specific jargon. So in things like medicine and law, right, there are terms like plaintiff or counsel or myocardial infarction that are precise, but maybe not so precise that they could be completely formalized in a programmatic sense. In the case of things like law, the ambiguity is actually quite useful because it lets you sort of adapt interpretations as new use cases arise. And so in some sense, this stuff wants to live in this kind of interstitial space. Another thing I find very fascinating is there's some work in linguistics on developing a natural semantic metalanguage, which is a way to kind of break down a complicated concept into these almost formal descriptions of what a word means. So this allows you to do these really precise comparisons between complex words like happy and contented by kind of breaking them down into scripts. So for example, happy could mean X feels something. Sometimes a person thinks something like this. Something good happened to me. I wanted this. I don't want other things. Because of this, this person feels something good. X feels like this, right? So it's a little bit stilted, but the importance of this language is that it's kind of agnostic to different cultures and allows you to do these interesting comparisons. So the difference between happy and contented is like instead of something good happened to me, something good is currently happening to me. Instead of I wanted this, I wanted something like this. And so by sort of unraveling one level of abstraction but still living in the semi-formal world, we can say these very interesting things while living in kind of, in that sort of semi-formal programming space. So that's all I have for my presentation. I'm happy to take questions. Thanks.
Thanks for the great talk. I'm curious, towards the beginning, you showed two examples of LLM as a sort of direct interpreter or executor of instructions versus using it as a compiler. Yeah, that slide. I'm curious, could you say a bit more about how you think that dichotomy fits into the semi-formal idea? Because I feel like these are two quite different ways of dealing with semi-formalism, and how do you think about the trade-offs between them and moving between them?
Yeah, that's a good question. I don't think I have a fully formulated thought, but I think if I'm thinking about this picture, I think this is sort of the picture in my mind is like at any given time, a program might live at some point on the spectrum. Well, let's see if I can actually do edits. Okay, so I might say that like doing LLM compilation is like pushing a program to the right like this, whereas like this kind of like execution thing is maybe like moving downwards in some sense. I don't know if that really answers the question. I guess one other thing to note is I think kind of like these interaction techniques is getting a little bit at somehow maybe like, I guess this is a little bit tangential to the question, but sort of like maybe what does this picture look like for that middle space? But yeah, I know it's a good question. I don't know if I totally know how to think about it yet.
Thanks.
So one idea that comes to mind is thinking about formal programming as like a theoretical endeavor where you're trying to like theoretically work out what's the code and how to formalize what you're trying to do. And informal programming as like an experimental endeavor where you're playing with LLM and exploring and experimenting with getting it to output the right things. And so I'm curious, thinking about semi-formal programming, how you could add this like experimental exploration aspect to it. I mean, I've seen some examples of this with LLMs where like tools that allow you to generate a range of inputs and see them all at the same time and pick the one you like, or tools that allow you to like maybe peel off one layer of the nodes of the LLM and modify weights at the edges of the LLM and explore the latent space in that way. And so thinking like with that conceptualization in mind, can you imagine how that could fit into like semi-formal programming?
Yeah, that's a really great point. I was just at a talk a week, I think last week, that was really showing off more examples of this kind of like generate a UI on the fly thing, specifically for ideation. So like, I think one of the examples was you have like you want to generate an image for a news article. And so you extract, keywords from the news article, you identify the tone, and then the LLM will give you like, okay, here's a bunch of words that are associated with like climate change, like, whale, fire, like. So I see that as sort of like the LLM brings a little bit of the structure, like here are a bunch of options you could select, and then the user then goes and kind of selects those things, and there's sort of like a back and forth kind of process. So I guess like, in that sense, like, I think there's some ways in which a little bit of structure, which is something an LLM can give you, allows you to like do more exploration and also eventually kind of funnel in on a particular design or a particular program.
Hi, really great presentation. I really like the sliding scale between clay and bricks. I think that's kind of how I see some of these things in my head. So I'm really pleased to see that sort of explained so clearly with some like in a novel way. I also noticed you use TL Draw, and
yes.
And I work at TL Draw. So thank you. I'm just curious, but you haven't like used a TL Draw within like as a library within a slideshow app. You've just used a whiteboard, which I just wonder if there's any like what was the thinking behind that, and yeah, how that's gone.
That is a good question. I think it's sort of a meta thing, which is like when I was making this, like I feel like presentation software makes me live closer to the brick style of editing, and I really was not in a place where I want to commit to that style and think about like all the mini like alignment issues. And I was living over here, and then finally when I had gotten far enough, I was like, oh, the aesthetic is kind of nice, and I can like zoom in and out on code, so that's cool. And so I just kept it in the TL Draw environment.
Wait, what was the question over here? You had a question, right?
Hey, it was a very interesting talk. Thanks. I had a question about the jargon, the domain-specific jargon thing, especially in the medical side, right? So I don't actually work on it, okay, for disclosure. But there is this aspect very much of this kind of live interaction, especially in medical diagnostics, where there is a kind of formal-like thinking process, but the interaction is all informal and the jargon is all domain-specific, so it's not really formalizable in that sense. But by and large, what's happened is really that chat interfaces have taken off, and any flowchart or formal-like aspect has been in the background. So do you see a modality or an application where the formal side of it is up in your face for the end user, in these domain-specific applications?
That's a very good question. I think one paper I love telling everyone about is Formality Considered Harmful, which really gets at some of these questions. I think what's really fascinating is like one reason why people reject formalisms is because they are living over here and they don't want to think about the formalism until afterwards. In some sense, the formalism is describing their thing post hoc. So an example was some people tried to build formalisms for argument structures. So like this is a premise, this is a conclusion, et cetera. And people don't think that way when they're writing the argument. It's more of like a descriptive thing. And so I think it's really interesting to think about the trade-offs between these two styles, I guess. Like, I think it's more like, yes, that's a really interesting provocation, and I think it'd be interesting to look at, well, why did they reject that? And adding formalism is not necessarily good, right? It's important to understand kind of like where it's useful and in what scenarios, I guess. I don't know. I don't know is the answer.
I think we're going to see I love when a talk weaves into the next talks. We're going to see a bunch of discussion about formalism and informalism later in the sort of documents section. I think this is the first year we've had LLM talks at Live. And I know some people in this room think these things are overhyped and bogus, and some people in this room think that these things are vital and important in the future. And without asking anybody else what they think, I would like everybody in the room to give like a big thumbs up. Wait, not yet. A big thumbs up if you think LLMs are exciting and vital and important, and not great, just if you're personally really interested and enthusiastic about it, and a thumbs down if you're like, maybe it's going to be a big deal, but I'm just not that into it. And I'm really curious to get like the temperature of the room. So let's all do it together. We're going to go in 3, 2, 1. You can do like an in-between one. Yeah, I see a lot of thumbs in all directions. And I think that's awesome. Right? Like we have this like, and if you're in the chat, you could go ahead and like put some thumbs. Everybody put your thumbs up for posterity here. We'll do this again next year and see how the thumbs, someone's got a middle finger there. That's great. We'll see what this looks like maybe next year and if the opinions are changing. But I think it's fascinating just to see the multiplicity of perspectives on this stuff right now, because it's obviously a very dynamic space. Maybe if you could comment just briefly on, particularly obviously being here at Live, bringing an LLM talk, your position is pretty well known, but how has that affected that both hype and enthusiasm, but also kind of like reactionary movement and controversy? Does that affect the way you're thinking about this work at all, or are you just like full steam ahead?
That's a great question. I think one thing that's really hard to disentangle is like what problems with LLMs are intrinsic to that approach or intrinsic to informal structure versus what things are artifacts of the way they work. Like what things are like artifacts of GPT-4 that will be removed by like 5 or 6 or whatever, and which things are like, oh, your task is underspecified, so you can never do this thing. I think like one thing for me is sometimes I think people try to use LLMs for formally structured tasks where like a compiler or interpreter is better. And I guess one thing for me is sometimes I use this sort of spectrum-y framework to think about like, oh yeah, like I'm fine with errors in this case where my thing is unstructured anyway. And so I kind of use that as a scaffolding to measure like, oh, this thing is overhead, this is not. Yeah.
That's great. Well, it is now lunchtime, so you can take your controversial opinions about LLMs to the lunch table. We will see you back here in 90 minutes for the next round of talks. And yeah, thanks so much again, Josh, and all the other speakers. This is a great block. Thanks so much.
So Thomas, do you hear us?
I can hear you very well.
Ah, great, and we hear you, so.
Hello, Thomas. We've got Jonathan here too.
I can see him. Hello.
Great. So.
He doesn't want to say hi.
Yeah, please wave hands to him.
Everybody wave to Thomas.
Hi.
Hey, that's better than like zooming into the void.
Everyone's hiding in the back of the room.
Yeah,
that's true.
So I hope you had a fruitful discussion about LLMs and programming in the lunch. And now we are moving on to the afternoon session. The first session is more about document-oriented programming and beyond. The first talk is about document-oriented programming based on edit history by Thomas. So please go ahead. Thank you.
Thank you. So I'm very happy to see that there's an entire session about document-oriented programming, because I think this is a theme that I found very interesting. And so I'll tell you a little bit about my work in this area. This is kind of paper or a video that I did that came to existence in parallel with this work that Thijs presented earlier on the challenge problems. So it's sort of an attempt to address one of the challenges that we posed in that paper. How did I get here? So first, let me tell you a little bit about the kind of programming systems that I want. So sort of vision behind this is that I want something that's accessible and simple on first encounter. Idea is that if you sort of have a program created in a programming system, I'll talk about systems rather than languages, then you should be able to sort of approach it, do simple things with it, even if you're not an expert programmer. But also, I want something that allows the power users, the actual sort of expert programmers, to do whatever they want, modify the system. And this should be something that can be used for collaborative editing, and it should be open in that you can sort of use the system to explain why you got the results you got, or where certain properties of what you see on the screen are coming. So for example, if you see a sort of green and red color somewhere on the screen and you want to change it for accessibility reasons, you should be able to sort of use the system to trace where this is coming from. So it's kind of an idea for a system that in some ways I think has been envisioned by the Smalltalk people in the 70s, at least in the early days. And what I'm going to talk about today is two ideas that I think if you combine them together can get you somewhere in that direction. The first, and that is nice to see as this has become a theme for the whole session, is to represent sort of everything you have in the environment as a document. Here you can take inspiration from things like Smalltalk, which had the image-based format. But there's also other sources like the Boxer programming tool, which you can see on the screenshot, where everything in the program is sort of exists somewhere in a document. So this is really my sort of first key idea. All your program, all your code, all your data will live in a document. And imagine something like an HTML page where, or maybe you can collapse some part of it, but the key idea is you can sort of navigate through it and find everything. And as a bonus point, this could also contain not just the code and the data, but also the evaluation trace of the code. So if you run something, it proceeds in some steps, and those steps you should be able to store in the document as well. And that then you can use for doing this inspection and sort of from within the document, find out how things were calculated. That's the idea number one. Idea number two is to represent program as a sequence of edits. So what I mean by this is that when you program, when you're creating this document, of course you could just store the current state of the document. But then it becomes quite hard to see how things were created, and it also becomes a nightmare to merge diverging documents. So if we instead sort of every time you interact with the document, you add some nodes, add some code, run something. All of these things will just append interactions to a list. And then you can, hopefully this makes merging of documents easier, and you can analyze the previous edits to sort of see how the document was constructed. So all my demo here is going to be around this conference planning example that Thijs talked about earlier. Hopefully you I don't have to repeat that. But the idea is we've got some conference organizer, sort of conference planner, or that's the task we want to do. We want to organize a conference, and we want to invite some speakers, and multiple sort of chairs of the conference are collaborating on this. They suggest some speakers, then they calculate some budgets. That's sort of the work they do. And I've got this demo here that I'll show you in a second, where on the left, you can see the document, and on the right, there's a sort of a preview of all the edits through which the document was created. One of those is sort of the currently displayed state, so you can navigate through this and replay the history. And to actually show this, so I haven't really implemented any sort of fancy editor for my documents. Instead of doing any editing, I'll have a couple of buttons highlighted in green here at the top that basically replay some hard-coded edits to the document. And important thing that I'll get back to later on is that they all start with the same baseline document. So if I go to my demo, then here's my baseline document I created, and you can sort of navigate through this. So I added the title, then I added subtitle, then I created the list and added a few people to the list. And so the first challenge is what Thijs has been describing, where I can imagine we've got two people. One is adding a new speaker to the list, and the other is refactoring this list to become a table so that we can then track other things. Those two sort of buttons I've got here, they will add more edits on top of this baseline. And if I click both of them, then they have to be merged in some way. So let's first see what happens when we add a speaker. So this has added a speaker, and I can now replay that. So first we add a new speaker, and then we sort the names. And then the other person can come, or their machine connects, and their changes synchronize. And what they have done is that they refactor in a couple of steps this representation to be a table. So now I've got a table here. And this sort of did some retagging and wrapping and so on. So there's a couple of basic operations in play here. Now, the other interesting thing is that, of course, if the changes were merged in the other way, then we first refactor. So given the original list, we turn that into a table. And then what happens when we add a speaker? So naively, this would just append the list item somewhere. But the clever thing that the system is trying to do is that it sort of reconciles the edits. And as we are now adding the new speaker as an edit after all those previous edits to refactor the table, the edits to add the speaker get transformed along the way. So they actually become an edit that appends new table row and then reorders the table rows. So this is a thing that has happened sort of behind the scene automatically for us. So to some extent satisfies the first sort of task that we set. So again, the important thing here in the demo is that I've got this green bit at the bottom, that's my baseline. And then on top of that, I can replay various other edits, like adding a speaker or refactoring the list. And this is kind of a typical local first scenario where maybe you work in a disconnected mode and then you need to reconcile the edits coming from multiple sources. And in this example, I had two different ways of merging where we take the baseline and then we either refactor and add a speaker or add a speaker and refactor. And for the sort of second edit, like on the left, the adding a speaker, that has to be transformed to sort of be consistent with the refactoring that's happened. On the right, we add a speaker, and then the refactoring has to be consistent with adding the speaker. And there's a couple of interesting theoretical questions that I've sort of not really driven deeply into. But do these two sequences result in the same document, or can we have some edit that will impose a conflict so that we can then only merge one way? I can tell you that in my demo, I have a test that checks that the two documents are the same for the samples I've got, but I only tested that, and I have no proof that this will work. So this was the document editing part. The second part of this example that I've got is that you can also include code in the documents. So inside the document, you can write some formulas, and the formulas are really represented just as three elements of the document. So everything here is a tree, and they're, in my view, they will be rendered in a somewhat nicer way. Of course, then we have lots of interesting other problems. So this is a sort of illustrated screenshot of a thing I'll show you soon, where we now have formulas in the code. They're not rendered super nicely, but there's this little sort of expression here where the key thing is you can refer to other elements of the document. And there's some built-ins like count and multiplication and sum. But there's all these references which you can sort of think a bit like a CSS path or a navigator that refer to the first purple example right here at the top that says select all the speakers. So take the speakers section of the document and then select all the elements, and then we want to count them to get the total number of speakers. Then we do some other calculation, like the speaker travel cost will be the number of speakers times some fixed cost. The cost for coffee breaks will be the number of attendees times the baseline cost of the coffee break. And then the final total sum will be summing all these sort of intermediate sums. So you can write these selectors. And this is something that I think, together with Jonathan, we've spent a long hours discussing what you can actually select to make the merging then work. So this is maybe a sort of another lesson from this, where I think my selectors are a bit more flexible than what Jonathan has been working on in some other projects, but that also means my merging is a lot harder. So let me actually show you this. Again, I start with my basic speakers list, and then I've got this button that adds the budget calculation. So let me just replay all that. And this was just adding all these formulas. And I can also evaluate. This actually I can sort of do step by step. So it sort of proceeds from top to. So as you sort of do this, first, the arguments where there's a path selector, they get replaced by a copy of the actual value, and then that gets reduced, and the same thing happens sort of on and on. Now we multiply 5 times 10. Well, I can sort of just click eval all and replay that for you. So now the formulas have been evaluated. Now, the interesting problem again is this merging. So if I add the budget calculation. So this is sort of one person adds that. The other collaborator, the other co-chair, adds instead, or does the refactoring to a table. Then we have an interesting problem because the refactoring changes the structure of this list. And so all these nice references, like all the speakers, it is kind of tricky what to do with them. So here, as I do the refactoring, you can see that this is changing as well, because we have a wrapping operation that wraps the elements in a sort of sub-element, and the wrapping is not applied just to that list element, but it's also applied, it's basically sort of applied to all the selectors in the document. So the selector changes because now we sort of suddenly inserted body table or T-body into the document, and that we need to kind of count the rows inside that. And of course, this has to work the other way around as well. So if I do the refactoring first, and then add my budget calculation, the budget calculation is already using the new correct path with respect to that refactoring. So this is kind of an interesting issue where you really have to take account of these formulas in the merging operation. So the merging has to be able to handle both the case where you add a formula and then you do some editing in the document that may affect what you need to select in the formula. So then you fix the selectors in the formula. You also need to handle the case where you sort of change the document, but then you add a formula that was written based on the original version of the document. And in this case, you need to edit the formula sort of behind the scenes as it gets inserted. The last interesting thing that goes on here is how this interacts with evaluation. So there's sort of two things interesting here. One that I mentioned initially is that another idea I've got is that in the document, you should not store just the final result, but we also want to be able to see how this got computed. And this is rendered in a sort of slightly shiny way here. But I can actually sort of see what was here before. So when I evaluate something, it sort of basically says replace the node. But what actually happens is that the new result, the new node, just gets appended as a more evaluated version. And I always show you by default just the most evaluated thing. But you can actually sort of go back in time and see, well, this was multiplication of two things. The first thing is 1000, and that was actually referenced to this. Second thing is number 3, which came from here, and this actually came from this calculation or this sort of counting. So this is one interesting thing that happens around the evaluation. The other thing that happens with the evaluation that's worth pointing out is that if so let me add the budget here and evaluate everything. And as you see, these sort of, what the evaluation does is that it really just appends more edits to the document. So the whole document is just edit history. I do highlight the evaluated edits, generated edits in gray. And so if I sort of do all these edits to my document and then add a speaker, then what happens? Well, this number 3 will be wrong. So let's do that. And the interesting thing that happens behind the scenes is that the adding of the speaker actually removed some of these generated edits from the document. So there were some edits in the history, but those are in conflict with the edit speaker, with the add speaker edit, and so the generated ones get just deleted. And so what this does really is that it invalidates some of the previously evaluated things, and I have to re-evaluate them. It didn't invalidate everything. You can see that there's still 4 gray edits here because the evaluation that calculated the refreshments and the bit that evaluated the travel speaker cost, that is still correct. That remains, but the number of speakers and the total speaker travel cost and the total cost is something I now have to re-evaluate. So again, this sort of representation of everything as edit history actually has this nice consequence that if I treat evaluation that way as well, I get invalidation of evaluated things for free. So somewhat contrary to the theme of this workshop, I'm not actually making this very live, but the point is this is sort of the infrastructure behind something that you could make live, for example, by doing the evaluation automatically, and because of this clever invalidation, it might actually be able to run faster. All right, last word I want to say. So normally people talk about future work to basically say, well, this is what I'm planning to do. Don't step on my toes, do something else if you're working on a related project. My purpose here is completely different because I really want to kind of get some feedback from people where this kind of thing might go. So please, I'll be hanging out in the Discord over the next couple of days. If you're interested in this, do come and have a chat with me. There's various things you could do with this, like do some formal proofs about this, actually turn it into a sort of usable projectional editor, rethink some more basic ideas about programming, or sort of add interactions with the user, which could also be edits. So those are sort of some possible directions, but I'd be really interested in hearing what people think about this, or whether it sort of relates to anything you're doing. And I do want to mention that we also have some funding in Prague, where I moved recently, for both postdoc and PhD positions with some interesting programming language people around. So if you're interested in these kinds of things, or are thinking about maybe going somewhere nice for a PhD or a postdoc, then please send me an email and we can discuss. So the conclusions, there's really 2 ideas here. It's this idea of working with documents, a theme of this session, and a bonus to that I'm adding is represent the program as a sort of edit history. And the idea is that, well, maybe this combination of these 2 things will let us realize something like what was the vision behind the early days of Smalltalk, but do it in a different way that will maybe let us solve some of the issues that Smalltalk eventually faced. Thank you.
Great. Great talk. I'm just looking around the room. Does anybody have questions now? I'll just start walking around with the mic here. Yeah, sure. Here you go.
Yeah, thanks for your talk. I found the idea of the evaluation as edits very compelling. Is there a way to intercept this? So as a user, for example, if there is a bug and like some value is not corrected, calculated correctly, that instead of fixing the program, I could like intercept the evaluation and like fix it myself in the concrete and then continue the program?
That's a good idea. In the current system, basically nothing works. The things I showed you are possible, and there's nothing else. In principle, this is something that I found very sort of potentially interesting, because you could, I think, edit the more evaluated version of the document at the point where the wrong value got computed, and then continue sort of evaluating further based on that modified state. I think this is something that we'd have to be careful about because we want to highlight that the manually edited part is sort of inconsistent with the automatically evaluated part. But I think this is a sort of potential use of this representation that would be quite nice and practically useful.
I think if you think of the evaluator as another editor, it's an interesting model, because then obviously you can edit a human's edits, so you should be able to edit the evaluator's edits. Other questions in the room? There.
Hi, great talk. Very nice to see working demos like this. So your edits, are they like, can I understand them like they're designed as a sequential language of valid things that you can do to the document in order to update it? And could you then reason over how these edits work in terms of a language definition, do you think? Or, yeah, how would you reason about this?
Yeah, I think reasoning about this is an interesting challenge. So the sort of formal model of this really is you've got edits, and then the program is a sequence of edits. I guess a lot of the interesting like safety properties, for example, if you wanted to say which edits are reasonable, they will have to deal with the fact that the edits are kind of replayed to construct the document. So you kind of, the properties, I think, would be hard to formalize just over the edits. You'd have to model the evaluation as well. And the edits, the way I have them right now, are very kind of low level. They're really like 3 edits on the document structure. So maybe to get something more kind of semantically meaningful, we need somewhat more higher level logic. But you definitely would do the reasoning over this like sequence of edit operations, and you would formalize how these kind of transform the initial empty document into a current state.
Still there? Are you still there?
Yeah.
Oh, okay. We can't see you anymore. Yeah, tomorrow
no.
I'm giving a talk about something very similar. I'd love to discuss more with you. What talk is that? The Cascade one at SLE. All right.
Send me a message on the Discord if you're able to access that.
Okay, Thomas, would love to talk more with you about this soon, but for now we're going to move on to our next document editing collaborative live programming environment. And welcome Yusuf to the stage. And we're going to switch over to his video now, so give us a moment here. Yeah. Yes, this is, we're not yet sure. Okay, well, I guess, does anybody else have a question for Thomas then while we're working here?
So I'm not sure if this question is a bit low level, but I'm curious about how the merge and rewind is implemented. I'm imagining that there's like a tree of different edits from different editors that get merged, and wondering if there's cases where merging could create a cycle in the tree and turn it into a graph, and if you could talk about some of the issues you may have encountered or you're thinking through with regards to that.
Well,
to try and answer that, most edit operations.
hold on, Jonathan. There's probably some people on the stream.
Right, well, you're going to tend to design your edits so that you can't create cycles. I mean, it's a tree editing grammar of some sort.
I will also say that if these topics interest you, we have this data structure called a conflict-free replicated data type, or a CRDT. They're very popular and trendy these days. Martin Kleppman knows a thing or two about proving the correctness of them. If you want to learn how to do that in Isabelle, he has literally spent years of his life on that, and I'm sure nothing would make him happier than diving back in to do some more. But the Programming Local First workshop is tomorrow, and there'll be lots of talk about these very specific issues. And Thomas, I thought it was really funny that, if you can hear us still, that you were just sort of backing your way into implementing a CRDT, and not funny in a bad way, just I know exactly how miserable and difficult it is to get those right, and also the precise feeling of, well, all of my tests pass, and I don't feel comfortable saying anything more than that. The Paratext paper, how many tries did we take on that? Is Jeffrey in the room still? 15, yeah, we were like days away from publishing, and then we realized it was completely wrong and had to rewrite the whole damn thing.
Nope.
Is this a good sign or a bad sign? Not the right thing.
No sign at all.
Is that the extension of your desktop by any chance, June? Oh, hey!
So, well, actually, this is mine.
Oh, okay. Well, we see something.
Yeah, we are watching something, so it's better than.
It's better than what we had.
Okay.
Let's see if it's.
The hard problems in computer science, cache invalidation, and video conference.
And printing. Don't forget about printers.
And printing, yes. And Linux, suspend, resume.
Let me go back to.
All right. Are we in business?
Looks like it.
All right. Welcome, Yusuf, and it's all yours.
Nice. Thank you. Excited to be here and talk about Typcell, which is my journey into creating a block-based rich text document editor that is end-user programmable. Of course, we all know this famous quote by Mark Andreessen, software is eating up the world. And one of my motivations to work on this is, okay, if that is actually happening, maybe we should step back and see what we want that software to look like. It's really great to be here with, I think, many people who share this, this motivation, this mindset. So what does that mean for me? I want to explore what could software look like when you really put users in control. So it's about giving users agency over the software and the tools that they're using. So Typcell is a fresh take on what that can look like, and I focus on two main things, which is hackability, so end-user programming, etc., to make it possible to tinker with the software that you're using. And as part of that, I also want to make programming easier, because otherwise you can still not really tinker with the software. So, and I try to achieve that by embedding a live, reactive, as you type programming environment into the system. It's also built on local first architecture for a lot of other end-user benefits. I'll talk more about my experience in that tomorrow. Today, I'll start with a quick introduction. We'll look under the hood at how the core engine works. I'll demo some of the different layers of abstraction. I'll put it into context to related work, show some more experimental demos, and then conclude with what I think are the strengths and challenges. Quick demo. Let's see if that also works. Yeah, so basically Typcell is, you start off in the Notion-like environment, and you get all these blocks that you can use, and it's rich text and notebook-style programming. So when you're using Notion, or for example, you can only use the blocks that they provide, but here I can also open a code block, define a variable, hello live. Everything, as you see, evaluates as you type. You can use TypeScript, JavaScript, React. So I can create another code block, and I can create something simple. I always think it's fun to see that marquees still exist. And using the $ variable, I can actually access variables from other cells. So now I can just import the greeting, and I get this nice live marquee. But what's even better is when I edit the variable in the other cell, the marquee also automatically live updates. So this is the basic programming model. Of course, if you build upon that, you can do more complex stuff. So for example, build a simple savings calculator, add a slider, all the variables, they bind to the system. This imports Vega Lite, so you can import libraries from NPM, including confetti, et cetera, et cetera. And what's also cool is that I think it's, let's see, which one? Yeah. It retains the liveness across documents. So if I open a different document here, let's see if I can arrange this right. Here we go. So this document now imports the module that I was just editing, and it uses the greeting variable from there. And as I change this, then hopefully the other one should update as well. I might have just restarted my computer, so maybe I didn't start the server that actually propagates. Try to get it for the display, of course. Normally, things live update across this. Let's see. Yeah, well, refreshing is not as live as it should be, but you'll see it in the other demos. All right. So that explains the core system. The fun thing is, or actually maybe a bit disappointing after 2 years of work, is that the core of this can be written in about 30 lines of JavaScript and MobX. So MobX is a framework for a library for reactive programming, makes heavy use of observables. I think nowadays everybody likes to call them signals. It's somewhat similar. And then, does this work in the resolution? Let's see. Yeah, here we go. It's too big, right? Yeah, so you basically have two cells, which is the code here, that defines the code. They're observables. I won't go through this code too much in depth, but it's fun to play around with. I can share it afterwards. And the main thing is you have this observable context where we put all the variables. And as I now change one cell, you see the console.log actually is the code of the other cell that automatically executes. So I thought this was a fun exercise to see how you can implement a basic system like this. It definitely has some pros and cons. So I think, okay, what you saw, a relatively simple implementation. It supports all pure TypeScript, JavaScript, so there's no custom language constructs. I didn't write my own compiler, write my own language, or whatsoever, and that's also great for interoperability. And it's fairly easy to reason about while coding. So this reactivity layer, if you create a button and you want to mutate a variable, you just say, okay, X++. I think that's easy when you're writing. So in that sense, it makes programming simpler. But it also has a lot of, a bunch of cons. So there's no unidirectional data flow. So your program can end up in a state that is definitely more complicated to understand it completely what is happening if you start mutating variables from all kinds of different places. There's also a possibility for loops, although those are mostly detectable. I want to take a moment to put Typecell in context to related work. And this is actually a slide from a blog from Thomas, who just presented. And he's talking about how you can have different substrates of interaction. And I think that is a really key concept that I'm inspired by. So if you look at Excel or spreadsheet software, I think the easiest substrate to interact with the software is just entering a bunch of numbers in the table, just editing a grid whatsoever. Then if you go one level deeper, you can start adding formulas, add equations. And if you go one level deeper, you can create VBA macros, although that is in a slightly different environment than the spreadsheet itself. But you can, you have these gradual modes of extensibility, and all the way at the top are the developers of the spreadsheet software if you have access to the source code. Let's have a look at what these different levels look like in Typcell. So look at the gradual complexity. To make sure I'm somewhat on time, I pre-recorded this, but I'll walk you through this. So when you have something like Notion, you can't, there is no concept of a map, for example, right? Well, in Typecell, because you have this live programming environment, you can import a mapping library from NPM and add the concept of a map to the system. So here you see a document where we start creating the map. It uses map libre. And as I go down, yeah, there you see, okay, by creating custom code, we can create this map component. And the variables at the top, there's the two-directional data binding, so they live update as I interact with the map. Now this is all great, but you can't imagine, like, not every user is going to code these kind of things. So the next level of extensibility of that complexity is to reuse existing components. You couldn't do that by, you can import the document that defines the map, and now this user, with a little bit of code, can add the map to his document. But still, it's possible to interact with it. Now, that still required a couple of lines of code, right, to get this, to import that map component. So what I actually want to achieve is really extensibility of the system itself. And we do that here by importing the other document as a plugin. Now this is done via code, but ideally this should be done via an interface, like a plugin store or whatsoever. And then in the other document, it says register block, a map by using this variable. And now the environment is actually extended as the user types /, the map appears in the menu, and he can start editing it to the document. So now you can really extend the software that you're using from the software itself. And it's still possible to program against it. So here I can use code to update the zoom level, or I can use code to inspect it. And this updates as the user interacts with the map. Now this is nice, but imagine that I want to create a document where that I want to share with others, saying, okay, this is the location of the conference. Then we still have an issue because, okay, now I can add an interactive depth map to my document, but it's not really, as soon as I refresh, that state is gone, right? So now how do we go about persisting the state in a user-friendly way? Of course, I could do this by setting the latitude via code, set the latitude, the longitude, the zoom level, but then that would still require code from the end user. So if we want to go one level further into the gradual extensibility, we can look into, okay, how can we provide a sort of a no-code customization experience? And the thing that I'm exploring is just, okay, by specifying the properties that should be configurable. Now when the user adds the map, a settings panel also appears, and he can use that settings panel to, without any code, really set some of the key properties that he might be interested in. Now, entering a location by entering the latitude and longitude is still not very user-friendly, so what we do here is you can copy the current variables, and now it's set to those, and as the user refreshes, those are persisted as properties of the map component. And now we have this page that can be shareable with kind of like a no-code experience. You can still program against it, so here you can create more advanced data bindings, and instead of a value, I bind a piece of code to it, so I bind the value of the slider that I just created, so that's also possible. All right. So that explores the different levels of gradual extensibility in Typcell. If you compare it to other software, I think this was useful. If you see Jupyter Observable or notebook style software, they quite focus on programmers, on engineers, right? So they focus on that harder substrate, which is Python or custom JavaScript in the case of Observable. Then you have spreadsheets, which do have a really easy substrate, grids. Coda more has like this rich text document editing as the easiest substrate. Then you can go one level deeper with formulas, but you can't really go all the way down to the programming environment, right? So with Typecell, I'm exploring, okay, can we create something that spans all these, really goes from the easiest to the hardest substrate. I'm doing this by focusing on these key points. So there's a focus on liveness. As you see, everything executes client-side in the browser. It evaluates as I type. Things are live and composable, and we try to retain that liveness across documents. The environment is extensible, so whereas previously you didn't have the notion of a map component, I can extend the environment to add that. Two other things that I would like to show. It's more experimental, but because all the code can be written in Typecell, in TypeScript, sorry, we can use the type system to create new experiences, and also see where we can get with when we further combine documents and code. Let's start with the letter. This one was very much inspired by Jeffrey's talk after me, so about Embark, and I tried to see, okay, can I replicate somewhat of that experience in Typecell? It's definitely some differences in the approach, and the UX that you see here is not ideal yet, but it does show the potential of going about this. So we can actually write code that inspects the document that I'm editing. So what we're doing here is kind of like Inception style, is see, okay, output the value of the block as I'm editing it. It's also possible, okay, let's say first block, and now as I edit the title of the document, you also see this variable being changed. And yeah, then you can start coding with that variable. So this is the Embark inspired use case, where let's say you're planning a road trip. I'm trying to establish a context from what the user is creating in the document. You see these inline code cells, definitely not the prettiest, but they help to add context that we can then program against. Here are some API calls for routing, for geocoding. And what you see is, okay, two locations, and as I edit the location, the coordinates automatically update. And then at the, so you see that it's done by doing the geo lookup. And then at the higher level, there's this piece of code which based on, in the bullet list, you see the column separated property name, property value, and it parses that. And the parsing of that is actually also not written, it's not part of the Typecell source code. It's one of the blocks below. There is this concept of like a smart block, which just says, okay, parse the children. So this parsing, where you see as I edit the greeting, that this variable updates, that is something that was thought of in the context of this document. But then if we build upon that, I can also add a map, and I can start plotting the route on this map, so you get this interactivity between code and the document. Now you see the route being plotted, and we retain the liveness as I change the destination. So copy paste, add a new destination. Let's say I want to go to Spain. There was a typo there, but you can see everything updated as I type. So now I go to Madrid, and even as I drag and drop, it will change the order because like the way the query is built, it will query from top to bottom. And now you see, okay, I'm going to make a large detour. I'm first going to Madrid, or actually here I can edit it to Barcelona and go there first, etc. So this is an early experiment of how all these systems can interact. Finally, Another early experiment that I did, and I think we were talking about this earlier in the LLM talk, talking about formal and informal types of data. Because we have the document text, yeah, that's very much, it is somewhat structured, especially in the block, because we work with blocks. So the previous road trip example showed, okay, how can we use the structure of the document to extract context? I also try to explore, okay, can we use an LLM to extract unstructured or more difficult structured data from the document? So in this, see full screen. Not sure if you can read it yet, but it basically says we're planning to build offices in Amsterdam, Berlin, San Francisco, and we're not planning to build offices in Barcelona, Prague. Super simple example, but we can feed that data to an LLM. But what we can also do is feed it the context of the code. So now we ask LLM, show office locations on the map. And we also give it the information of that map component. And we do this by providing it the TypeScript types. And in the map component, there's this type markers, which is an array of marker objects which take a latitude and a longitude. And we pass this TypeScript definition of everything that is in context, so including that marker property, to an LLM, and it then figures out, of course, 8 out of 10 times, and there's a long wait here, but then finally it figures it out, starts typing in the document, and you can start collaborating with the LLM, and it starts, and then it adds these locations to the map, and it only adds the ones where we're actually trying to build offices. Can zoom in, explore Berlin, Amsterdam, San Francisco. And I think that is also quite promising on how you can reuse the type system for extensibility like this. All right. Definitely also some challenges and things I'd like to explore further. Because we're in this notebook environment, sometimes like the state of what is executing on your local computer, right? So it's not it's happening in your browser, in your JavaScript environment. So you can interact with the document, and those interactions are not necessarily shared with other users. So sometimes it can get complicated, and what is the ephemeral, what's the local state layer, and what is the persistent layer? So the code in the document is persistent, but what do you want to execute locally, and what do you want to keep shared? I think it makes sense to have some things locally, but for example, in spreadsheets, like 90% of the stuff is shared, so it's easier to reason about for users. Same thing what I already discussed, mutability, side effects. I think it makes it easy to write code, but it can make it more challenging to read code. I think for small composable documents, it can be suitable, but I think this is interesting to explore further. And then the last two demos, of course, super early work. I think it's there are some promising concepts of the gradual complexity, and okay, we can do a lot with the system, but I think it's a challenge will be, okay, what are the best primitives in terms of UX that we should provide to the user to make it prevent it from being necessary to dive into a code editor all the time. So we don't want those code snippets to show up inline. For example, can some things be handled in a no-code configurable way? I think that will, it's promising to see this is possible, but getting the UX right will definitely take some research. Similarly to how we use the type system to empower the LLM, what I think is also really interesting, if we can use the type system as kind of like a material to weave together different plugins. So you saw, okay, we can create a plugin that defines a map, but maybe we can also create a plugin that defines if you have a type with a latitude and a longitude, then you can modify that type with this plugin. And that plugin could be, so for example, this. Now it's nice, you can enter the number, but it would have been nicer if somebody else could create a plugin and you get this composable system, and one plugin could be, okay, you can select a location on the map, or another plugin could be, okay, you can do a geocode search for a specific location and then enter that location, and then hopefully the type system can be an interesting way to compose these plugins together. And this is very much inspired by Livelits and Hazel, and I think they explore that concept further, but I'd love to see how far we can push that. All right, thanks. It is online, it's open source, you can sign up and try it out. Would love your feedback, and also if you're interested in collaborating in some sort of way, also open for that. Would love to hear more, so yeah, hit me up the next couple of days. Thanks.
I think just maybe one or two questions so we don't get too far off time.
All right.
Well, there was someone else with their hand up behind you.
Okay, so who wants to go first?
Mine's going to be really short, I promise. That was very cool. So you've got the code blocks in the Notion style, thingamajigama. And then you showed an example where it's like, I'm using some this thing colon that thing, and I'm reading it into the code block and doing some stuff with that. Have you ever played with just throwing an eval in there and then writing your code in the nicely rich text side of the picture instead of this terrible, colorful monospace font world?
Yeah, you could. So basically, saying, you want to write the code here, right?
Yes, write the code there, and then just in one of the places where it's like, I can read stuff out of blocks. It's like, well, just put eval around it.
I haven't tried that yet because the block API just built. We could try it right now, but I heard we're short on the.
Yeah. Okay. So there was a second part of that question, which is okay, of course, obviously you've done that because it's
Let's see.
obviously. Then how do you choose when to write in the little, formatted monospace gross world versus in the nice, typographic beautiful world? But that's, yeah.
I think the reason for that monospace world is, because you do enter sort of a programming environment and you get all the Monaco benefits, right? So that's definitely, at least to me, that is a benefit. And you can get the auto-completion, etc. And they are, the way I think it should be, it's that they are collapsible, or you can present it in different ways. So now by default it outputs all the stuff that I export, but I can also say, okay, add a default export, which kind of overrides what it looks like. And if I combine that with collapsing it, you kind of get rid of that code experience, right? Because I do not imagine that you want to be sharing all these documents and just have code visible there for everybody. So either it should be part of a separate document, or it should be hideable, etc. I'm not sure yet about writing the code in the eval.
I'll argue with you about that, but later.
Okay.
Yeah.
All right.
Here we can give it a shot. Just I hope thing will not explode, but let's say.
All right, while Josef is doing that, I will introduce Paul Sonntag, my colleague at Ink and Switch, who's presenting the Embark paper. I have been following this work for quite some time since we did it at the lab. Hey! It worked, but you were so busy figuring out if you could, you never stopped to ask if you should. So thank you, Josef. Let's give him a round of applause. And we'll welcome Paul Sonntag to the stage. And so Paul's talk is the last one of this block. I'd hoped we'd have some time to talk about the ideas of document programming, but you guys have had so many questions and we've had great presentations here, so we may not have time for a discussion at the end, but maybe we can fit that in the closing session. Or we can take it into the chat, so definitely ask your questions there, or propose your ideas. And Paul, are you ready? All right, almost ready.
Yeah.
He's just figuring out how to go full screen.
Wait, sorry.
Your pointer's not moving on our side here.
I-
Is that... Have you tried saying enhance?
I'm having trouble clicking.
That often works for me, yeah. Have you tried turning it off and on again?
Like clicking doesn't work.
It seems to have frozen your machine. This is the opposite of live programming. Thank you for this illustration. While he's working on that, if you haven't seen Jack Rusher's talk from Strange Loop last year, Stop Writing Dead Programs, that's a great rant, as all Jack Rusher talks are.
For some reason, my machine rebooted, so...
Somebody else was saying they had trouble in another session with M1 Max and HDMI and things, so you're not the first person to have a reboot. I'm sure it will work again momentarily when your machine finishes rebooting. You know, and updates to the new version of Xcode and decrypts your entire hard drive and all those things. Computers, everybody. It does seem like maybe we took a wrong turn somewhere along the way. Though to be fair, I do remember reading that Multic's uptime was measured in microseconds. Or was it milliseconds? Either way, not that great. Paul is re-implementing Embark on his laptop right now. This is
revenge joke about the years and years of getting jokes about Linux.
Yes, the Linux, the one person still running Linux in the audience here on his laptop is very impressed that finally Apple has caught up to Linux in another way, which is that it can't be used to stream video to a projector. So it's nice to see feature parity there. Yes, there were audio issues as well, yeah. 2024 is, yes. I will say Linux on the desktop, I bought a Steam Deck this year, and that's a little Linux computer handheld. It's a surprisingly reliable piece of hardware, and the suspend resume basically always works, which is really an engineering accomplishment all on its own.
Okay.
Paul, you're doing a lot of typing there for a guy who's opening up a presentation he already wrote. Is there something you haven't told us?
No.
Almost.
Okay.
Okay, here we come. No, we're... OBS. Yes, but Linux is back in the game here. Revenge of Linux. So is everybody having a good workshop? Yes? I see at least a few heads down programming in the audience. That's always nice to see. Oh, hey, we're in business, or sort of. It's a weird mix, but we see Paul and the video. All right, double Paul, slightly delayed. Oh man, you got to be able to do some good like collaborations with yourself there. Yes, we have life-size Paul. Paul is to scale. If you're on the feed, his video version of himself, the doppelganger, is exactly the same size as real Paul now. Oh, hey, there we go. Okay.
Thank you so much.
Thank you to our hardworking AV team. All right, Paul, take it away.
Yeah, thanks for the introduction. And now my pitch by software is bad, and how we can improve it. Yeah, today I'm excited to share Embark with you. With this project, we explored dynamic documents, which allow you to do your whole planning process within a single medium. Instead of reaching out to external app in Embark, you can pull all the computational tools you need directly into the document. So to ground this research in a real use case, we picked travel planning because planning a trip requires you to pull together information from different sources in order to make a decision. So first, as a baseline, let's see how I might plan a trip in our app-based world today. So let's say I want to go canoeing this weekend, and I know there is a nice lake nearby where I live called Ruhrdamm. So I might start my plan by just pulling it up on Google Maps. And first, I want to know, like, how can I get there? This is still straightforward to do, and now I can see it takes about 1 hour by car. So next, I'm curious about the weather, like, should I go on Sunday or on Saturday? And this is a question that lies outside of the realm of Google Maps, so I need to pull up the weather app. And this is already where things kind of start to get tedious because, like, by default, the weather app just shows me the forecast for my hometown. The problem is it's completely oblivious to the surrounding context. It doesn't know that right next to it I have Google Maps pulled up looking at a specific destination. So I guess I have to punch in the location again. And first I try Ruhrdamm. That doesn't work. So next maybe the city close by, Heimbach. And finally, I get the forecast, and I can see, like, Sunday is probably the best day to go canoeing. So now I have all this information, but the problem is the views I composed here are completely ephemeral. As soon as I close these windows, like, all the information is gone. And this isn't even that complicated of a plan. And, like, maybe this exists, this is just one decision of a bigger plan of, like, some friends are visiting over the weekend. So, like, how are people coping with these limitations today? One approach is to have a central planning document that people use to record their decisions and collect information across multiple apps. But there are some problems with this approach. First, a document is a static medium, so at most you can paste in links or take screenshots, but you're losing a lot of the richness and interactivity that you're usually getting from apps. Also, this doesn't solve the context problem. The user is still forced to manually copy back and forth data between the document and the individual apps. So we think this idea of having this central information document is really great, but with Embark, we want to elevate this. We want the document to become a substrate that can host both the nodes of the user together with the computational tools that they need. So how could such a substrate look like? For this, let's first look at what apps are made out of. So as an example, let's look at Google Maps. To the user, it's presented as a fixed interface, but conceptually, like, what does it consist of? So first, there are locations like Aachen and Ruhrdamm. Then we have routes based on that location. And finally, we have a map that shows that information together. But what are these parts? So location is a piece of data. It's something that an app can operate on. And the routes are computations. These are things that the app can perform on the data. And finally, the map is a view that can show both data and the results of computations. So with Embark, our strategy is to unbundle the app by reifying data, computations, and views as tangible things that a user can place in the document. So we start with an outliner as a base material. An outline is a list of text nodes that can be nested. And the user can then gradually enrich their outline with structured data, computations, and views. So structured data can be referenced in the outline through mentions. In Embark, for example, you can mention locations or dates. Computations are then represented as formulas in the outline, and formulas allow users to reference live data like routing information, and they can also do calculations from within the outline. And finally, we have interactive views, which can be opened for any node in the outline to render the data it contains. So after this brief introduction, let me show how we can actually use Embark. Hopefully that still works. Oh no.
We have crashed again for those on the stream.
It's back.
Wait.
Maybe?
Well, not here.
It's the same thing. I can't click anything anymore.
Okay, we're going to take a brief minute here.
Okay.
Matt on AV, are you seeing the feed from the... Okay.
Should I just unplug it and...
Yes. Do you not have an HDMI port on that one?
Okay. Maybe it doesn't like it if I switch it while it's... No, come on. No, now it's frozen again. I'm so sorry about this.
Oh, blame Apple.
Yeah.
Full screen, or there's some HDMI negotiation that's probably getting swallowed somewhere in the stack. Yeah. No more full screen, Paul. Just keep things in Windows.
Okay, now it's rebooting again. So.
Okay, we're rebooting. For those
so
on this,
sorry.
I guess you can hear him. Anybody know any good knock-knock jokes? Oh, we see it. We see your screen here. Your computer was restarted because of a problem. Yeah, that's accurate.
Good.
Do you have to restart your daemon there? I see a local host.
Yeah, right. That should do it.
No, don't go full screen.
No,
Didn't you learn the first 2 times? Okay. Good luck.
Okay, finally. Thanks for your patience. So yeah, let's now see how we can actually plan a whole weekend with Embark. So in this scenario, I have some friends visiting over the weekend, and I want to plan a couple of activities for them. So they arrive on Friday, and I want to do some sightseeing with them. On Saturday, we have 2 things planned, an art exhibit and a flea market. And on, wait, sorry, did I mess up? I didn't show you the canoeing example, wait.
You had 2 tabs open.
Sorry, I messed this completely up. Wait, no, sorry, I was messed up. I just continue with the demo. Sorry, I was confused for a bit. Yeah, on Sunday is the canoeing. Did I talk about the yeah, sorry. Okay, so now let's go into it. Yeah, so so I have these notes, so let's start by fleshing out this a bit maybe. So on Friday, I have like 3 stops on my plan, so maybe I can add a 4th. I know there is a chocolate factory in Aachen, so maybe I will add this, and I can do this by writing at Lind chocolate factory and add it to my outline. And if I click on this mention, you can see like actually the chocolate factory is also just an outline with attributes nodes, and this outline was automatically created by the system for me through the autocomplete. So this is the first time that my friends are visiting Aachen, so it would be really helpful for them to see all these places on a map so they get a better feel for the city. So there are a couple of ways I can do this in Embark. So first I can open a map for the whole document right next to it. And now I can zoom in, I can see the individual locations, I can hover over them, and then they get highlighted in the outline. I can also open up individual markers to see the details, and the hover also works the other way around if I hover a location in the outline. Instead of opening maps for the whole outline, I can also open it for individual days. So for example, I could open a map inline just for Friday. So now I can see the locations for that day in isolation, which is useful. So I can see actually, like most of the spots are like in walking distance, only the chocolate factory is further out. So maybe we need to think about how to get there later. I'm going to close that for now. So besides just placing maps in different, for different places, in different places of the outline, I can also customize the map itself. For example, I can like change markers. If I have the cathedral open, I can add an icon property and add a nice emoji. And now it's easier to see like what the individual markers are. In general, you can add your own attributes, but there are certain like system attributes that the system recognizes, like the icon here. The map still looks a bit cluttered, so one thing we could do is like color code the locations by day. So for that, we have a color picker, so I can choose a different color for each day. And now it's easier to see like which location belongs to which day. The way the color picker works is that it adds a color attribute to the day, and then all the locations that are contained within that day are rendered using that color. Okay, so now we have a pretty good overview of the weekend. Next, let's figure out the remaining detail for Friday, Saturday, and Sunday. So for Friday, first of all, it would be good to know what the weather will be. So for that, we can use a weather formula in Embark. Usually, we don't have to write formulas ourselves. Embark automatically suggests formulas. If I select a node, I can see here suggested formulas using the data at that point in the outline. So I can add the weather, and I can see actually, it won't be great, but at least it's not raining, so we should be fine. Next, let's figure out how to get to the chocolate factory. Here it's really useful that Embark automatically shows a preview of the result of the formula. So I can actually use this suggestion list to compare different modes of transport, like going by bus versus walking. And I can see like transit is much faster, so I'll pick that option. So I can make this a bit bigger. So now we've seen how you can add formulas to individual nodes, but sometimes it's also useful to apply a formula throughout the outline. For example, it would be nice to know the weather for each day. For that, Embark has an automation, so I can select a formula, and I have here this repeat button. If I hover over it, I can see already a preview, and if I like it, I can click it, and now I can see the weather for each day. So to do that, Embark infers automatically a pattern by looking at the arguments. So in this case, it would look for a node that mentions a date and has a parent node that mentions a location. And it's important to note that this automation is just a one-time action. Like the weather formulas that were inserted here, they don't have any special behavior. They behave as exactly the same as if I had inserted them manually. And the benefit of making things concrete is that if the automation messes up, the user just has to fix an individual formula. They don't have to think about abstract patterns. Okay, so now we figured out most of the details for Friday. Next, let's look at Saturday. We can see there are two things, the art exhibit and the flea market, but we can see some problem because it's probably going to rain. So the question is, like, how do we sequence things so we go to the flea market when it doesn't rain? And this is a question that Embark really excels at because you need to consider both the opening times of the flea market together with the weather forecast. And usually these kinds of things would be spread across multiple apps. But in Embark, it's pretty straightforward. All I have to do is open a calendar view for Saturday. And now I can see both the weather forecast and the opening times. Actually, the weather forecast also has hourly data. Like here, it's just shown as a summary. But if you open it, open a calendar view, it shows it by hour. And looking at this, it's pretty obvious that we should go there in the morning because it's less likely to rain. So probably I'll just like rearrange these two things. Finally, I want to consider one more detail for Sunday. Actually, I don't own a car, so usually I use a car sharing app, and it would be nice to figure out like what it will cost approximately to rent a car for the day. So I can do this by assigning the result of the drive formula to an attribute. For example, I can call it route. And then I can write estimated costs. And I can get the route, the distance of the route by 2, and like each kilometer costs 30 cents, and there is a 25 euro charge per day. So it's around about 50 euros to rent a car. I can also do computations in line. I can write per person, it will cost, estimated cost divided by 4. So I can say like per person it will be around 12 euros. So now you've seen how we could plan a whole weekend with an Embark. We considered different things like the weather forecast, transportation. We visualized that information in different views to make decisions like maps and calendars. And all of that we could do within the document. And not only was this more convenient than the app approach, but also it's really nice that we now have this single artifact. I can share this as an itinerary with my friends, or I could, and it's also useful on the day to refer back to get crucial information. Okay, I'm not going to switch. Yeah, wait. I've opened the wrong thing, so okay. Okay, so next I want to tell you some personal stories how we in the team have used Embark to plan various travel trips. So first I want to talk about my colleague Jeffrey. He was planning a road trip, and in the middle of it he wanted to stop for dinner, so he was considering 2 alternative restaurants. And with Embark he was able to show both routes together on a single map. And by looking at the map, he quickly decided for the first option because it split the trip more evenly, and also it was a more scenic route along the coast. And of course, using research-grade software takes some dedication. Unfortunately, Embark doesn't work on mobile, so for this trip, Jeffrey had to carry around his laptop the whole time. Next, I want to talk about my colleague Alex. Usually he works from an RV traveling through the US. Only COVID forced him to settle down for a while again. But during our project, he was planning another trip with his RV to go travel full-time. And for him, he's not just interested in the final destination, but also the routes taken along the way. So with Embark, he was able to create a personal wish list of potential routes and points of interest, together with notes to add additional context. And by visualizing all this information on a map, he could then flesh out his plan and consider different alternatives. Finally, I want to talk about my own travel story. This year, I participated in an adventure rally called Poles of Inconvenience together with my brothers. And the goal of this rally was to get a really crappy car and then visit as many poles as possible, which were spread all over Europe and beyond. And with Embark, I could create a color-coded map for all the poles, and this was a really useful asset for the planning process. For example, one evening I was talking with my brothers on the phone, and we were discussing whether we could do 3 polls in a single day. And to answer this question, I could just pull up my planning document and quickly do some back-of-the-envelope calculations to figure out if we could do it. So next, let's zoom out a bit and see like what things did we learn through building Embark. First, it might be interesting that when we started this project, we didn't even think about documents. Initially, we explored how you can compose various widgets by placing them on a 2D canvas. For example, here you could place a map next to a weather widget and have them share data with each other. But we quickly realized that this environment lacked a way to record your decisions. In contrast, once we started to host all the tools in the documents, we were suddenly able to capture our whole thought process. And documents are really great for this kind of thing because you can see or you can record how a decision evolves over time, like what were the alternatives that were considered and why did you pick a certain option in the end. And this is information that's really important when you're looking back at your plan. Another thing we found is the outline strikes a really nice balance between structure and freeform. There are many things that you can express through an outline, like a sequence of things or alternatives, or you can group things. And expressing your thoughts like this feels very fluid. Of course, there is some drawback because to the computer, the exact meaning of the outline is kind of ambiguous. The only universal semantic we have is the parent-child relationship between the nodes. For some cases, we found that that's fine. For example, if you want to visualize a node on a map, we just like pull in all the locations that are contained in that node. For other cases, it's a bit more tricky. For example, if you want to suggest formulas, it's important to understand the nuanced relationship between the nodes. So this is something we weren't fully able to solve in Embark. That's still a bit of an open question. And we also find that reifying computations enables composition because in Embark, formulas are tangible things. There are many problems that users can solve by just like composing multiple formulas and visualizing the result in a view. For example, like users can create a list of routes and visualize them together on a map. They can use the result of a formula to do some further calculations. You can also compare different modes of transportation or even like show multiple or different formulas in the same context. Like here you can see a route together with parking spots near the destination. And it's important to point out that the last two examples are things that you can also do in Google Maps. But the difference is in Embark, this is just a composition that the user can do themselves. Whereas in Google Maps, like each composition type is a new feature that like a developer needs to build. So this is all I have for now. Thanks for your attention and patience with technical difficulties. We also have an upcoming essay about this project where we talk more about like how this is actually implemented. So if you're interested, you can also already sign up on our website. And also I want to thank Todd for the beautiful photos in the presentation. Yeah, if there's time for questions, yeah, feel free.
We have, thank you. You can take all the questions you want during our coffee break.
Yeah,
so if you'd like to hear more about Embark, get out here and get a coffee and ask about it. Thank you, Paul. That was great. Folks on the live stream, we're taking our coffee break now, the last coffee break of the day. And we will be back here in about 30 minutes at what is locally 4 o'clock. 25 minutes now, yes. That's fine. Tomas, if you're there, I'm doing a little surprise bonus demo. Can I make this microphone high enough for me? All right, Jonathan's back. Good. Okay, this is Trail Runner. As I think I promised Joel he wanted to see this too. Okay. All right. Oh, I was on the stream. Now I'm not.
I crashed again.
You did? Oh, okay. It was working a second ago. Yeah. Okay.
Your face is streaming.
My face is streaming. I'm plugged. I saw it. Can I get my screen on the monitor? That is Jen's. Oh, maybe. Do I have an extra screen? Oh, double desktop. Hang on. I'll turn on mirroring. Okay. How do I change display mirror? Displays. Okay, arrange. Oh, there's a system update waiting. To mirror displays, hold option. Okay. This is where I'm going to crash the machine. Okay. So this is the tiny essay editor here. This is just a little markdown editor that Jeffrey Litt wrote to write the Embark essay in. I wrote the script for this demo in there. And over in this tab here, let's see, I had it live. Okay, in this tab here, we can see this is actually the underlying data structure of that document. This is the auto-merge document underneath this here. And that's happening because both of these are using the same auto-merge sync server. So the data layer is separated from the application layer. And both of these apps, although they're separate apps deployed on separate domains and separate infrastructure, are sharing the same sync server, so they have the same access to the same data. And so you can see this is even live, right? It's not just live collaboration, between instances of the same app. It's live collaboration across apps. Everything is living. Okay, so this is cool. And of course, it's bidirectional. Like if I make this comment here and I say, traditional, classical, right? But I forgot to log in, and there's no way to edit who made this comment. But I can come over here into the comment threads, and I can find that comment, and I can see the user ID is null, and I'm actually going to pretend that I'm Alex Warth. And so now it says that Alex did this because it looked up, that happens to be the ID that Alex Warth has. So that's kind of cool. Okay, so we've got bidirectional editing. So what's this thing over here? Because this is actually what I'm really here to talk about is this window here. This is called Trail Runner. And so this thing here is the raw document editor. And what we're looking at is the underlying auto-merge document. In fact, I can look at a bunch of different auto-merge documents here. Here's another little example essay, right? We can have a few of these. In fact, this list of documents on the left here, we can look at the lists itself. So we can unfold. There is this document list. This document list, and everything is live. You can see it's updating on the side, so that's neat. But what's happening here? I mean, we can click on this, and this will just link into itself, so that's kind of funny. But if we wanted to go, we could look. What's the raw editor doing in here? So the raw editor itself is a document in this system. And so the editor we're looking at, this is a package.json. And the document editor is just a standard ECMAScript module. There's nothing special here. And we have done one clever thing, which is we've taken the contents of the files in the ECMAScript module and stuck them into the package.json. So it's a very fat package.json. So this package.json includes the implementation of the raw editor. But this is kind of an awkward way to work on it, and I can tell you this with authority because before I built the other parts of the system, this was the only way to edit these things. So if I go in here, though, I can open up a module editor, which is a different tool to operate on this document type. So now I'm looking at the module editor. So now I can work on the raw editor from inside of itself. And the module editor as well is implemented in the system. So all of the tools that we're looking at here are built and hosted inside the system, and indeed I built them within the system. And they operate on themselves. But I can say again, that this is very fragile. It's kind of like editing PHP, but you're editing your editor, and so it's dangerous and you break things. So like if I'm here inside, I don't know, let's look at the raw editor again. You know, this document ID, actually technically this isn't a document ID, this is a document URL because it has a protocol. So let's fix that. But I'm worried about breaking the raw editor. So let's fork the editor. And now we're going to come in here and we go to the module editor. And then where does it say document ID? Somewhere down here. Okay, this is actually a document URL. And let's save that. Now, what just happened? Did I save that? Well, let's look at the document history. Okay, so let's see, scroll down here. That's where we're doing some imports. Splicing document editor. Is it up here at the top somewhere? I'm not seeing it. Maybe it didn't save. There we have an edit. Let's look in here again. Interesting. Maybe that one didn't save. Let's go back and look at it in the module editor again. Oh, it's still there. Okay, well, tell you what, I'm just going to trust in fate, and let's try running it. So now we can run it because it's registered itself as an editor for any kind of document. Okay, and this one says document URL, and that's great. This one still says document URL to, it's because I'm using the wrong program here. Run the old version of the code to get the document ID. Let's merge this change back into the system. So we merge that, say yes. Great, we can throw this away now. We don't need this anymore. And we can check, we haven't reloaded this code yet. Fun fact, live programming on a self-editing system is not a good idea. That is exactly enough rope to hang yourself. So we can do a manual refresh in a sec here, but I'm curious whether the edit will show up in my history. Oh, sure, yeah, to set up the next session? Yeah. Okay. Oh, awesome. So as people come back from the coffee break, we'll give people a moment more to come back. We've got 2 remote presentations coming up, unfolding state changes via live state-first debugging, and then lewd, build video games quickly. And I'm not going to try and full screen after what happened to Paul in the last session, but we'll start momentarily here for those on the live stream.
Hi, Lisa. Can you hear us? Okay, well, can you unmute yourself and try talking?
Yeah,
We'll see if it
sorry,
comes
I was
through.
just trying to find that button and I found it.
Let me
Finally.
just turn it
Sorry.
up. Okay, yeah, we hear
Do
you.
you hear me clearly?
Yep. And we see your
Awesome.
slides and your camera feed. So it should
Wonderful.
be ready to go once the chair says so.
Okay. Can someone in the audience laugh so that I can hear the audience laugh? I want to make sure I'm not giving a boring talk and nobody laughs.
So we're actually still waiting for some people to get back from the coffee session.
No worries.
I think Peter went upstairs to call for more people to come back. So please, sorry, but please wait for a few more minutes
No
to
worries.
start. Well, to benefit from this a little time before the actual presentation starts, can you switch the screen to the HDMI input? Okay, so I noticed that not many of you have added the slides to the self-introductions, but we plan to archive this somehow on liveprogramming.org so that we can actually see all of you in the part of the archive of the workshop that we had. So thank you for those who already inputted your self-introduction to the slide deck. Just add your own introduction to the slide deck if possible. Yeah, so probably we're good to go. Okay, great. So please switch it back to the remote. Yes, sir. So yeah, Lisa, please go ahead. Thank you so much for waiting.
Hi everyone. Good morning from West Coast, United States. It's kind of late afternoon there, so really sorry I couldn't be there in person. I wish I could, but it's still exciting to present remotely. And my name is Lisa Huang. I'm a 4th year PhD student at UC San Diego. Today I'll be talking about some really exciting work here in San Diego around live programming and debugging. So debugging is a very normal process of programming, and debugging sometimes can cause pain. So let's check out a few common debugging techniques that might be really familiar to you. The first one is I just did some search online and read some Reddit posts, and apparently one of the most common techniques is console logs or print statements. And the other one would be debugger breakpoints which is what we see typically in like GDB, or in the screenshot, I show it in a browser developer tool as part of Chrome developer tools. So these debugging techniques, however, can be painful in the following aspects. So we all know that debugging is an activity that centers around monitoring state changes in order for the programmer to understand program behavior and find out mismatches in the program behavior to their expectations. And for one to monitor state changes using these common techniques, they will have to insert the print statements or the breakpoints manually, potentially multiple times. You probably have the experience of having 100 print statements or something in the code base, just trying to monitor the state changes and understand what's going on. Another part of the limitations is the preciseness. These insertions of print statements and breakpoints would have to be precise. If you want to see the state change of one location in the code base, you really need a breakpoint or a print statement exactly at that place. And finally, the visual output parsing part. This might be familiar to you. You have a huge pile of debugging output, and although you try your best formatting it as elegant as possible, you still have a hard time connecting components of that debug output to the corresponding print statements or breakpoints in your program. So to alleviate these challenges, there have been advances in debugging technologies. In our paper, we define these technologies as state-first debugging, or debugging techniques that automatically reveal state information based on some specifications around the state. To make it more concrete, let's look at a few examples. There is the conditional breakpoints, which is a technique that automatically pauses program execution whenever a user's specified condition becomes true. And there's object-centric debugging, which focuses more on the object-oriented programming paradigm. And this technique would automatically pause program execution upon events such as object instantiation, method invocation, etc. But state-first debugging has their limitations as well. And the biggest limitation out there is that they're debuggers at the end of the day, and they're meant to pause program execution. As a result, they force the programmers to only see one state at a time. There's no way for the programmer to step back and take a look at a potentially bigger picture of the program execution at all. Second, there's no explicit visual connection between the program state and the code. And it's really hard for one to figure out the exact lines of code in the code base that results in the creation of a program state. And finally, what if you have changes in the code? Well, you have to repeat all this debugging process in the debugging tools. You have to go back to square one and navigate through all the state changes until you reach the point at which you want to inspect. Despite these limitations, we love state-first debugging. We think it's really essential to make state information as transparent as possible to the programmer during debugging. So in our work, we tried to make state-first debugging better. We made it live. In our work, we proposed the paradigm of live state-first debugging, a paradigm in which programmers always see all state changes and their connections to the code. So without further words needed, let's see a live demo of our implementation of live state-first debugging for GUI applications, a system what we call Unfold. I hope I'm showing the application here. Okay, I'm just hoping. Right, so for this demo, I want you to follow the story of Alice. Alice is a web developer working at an e-commerce company. And these companies develop websites like shopping websites that promote their products and trying to make you spend as much money as possible on their products. And sometimes they would use promotion pop-ups that might be familiar to you as well. You know, as you're scrolling through their website, you sometimes see a pop-up showing up out of nowhere, asking you to sign up for their newsletter in order to receive a 15% off. So this is a precise shopping website that Alice is working on. She just joined the team, so she's still trying to figure out what works in the website, what does not work. And to that end, she decides to use Unfold, which is the interface you're seeing right now, to understand the behavior of the website and to fix the behaviors if they're buggy. So in this interface, you see something that looks like a traditional IDE with code on the side, and you can see the file directory in different tabs or search within the code base. What makes it special is that you can see the actual rendered interface of the web application you're working on the right, without having to switch to a browser tab or a different page. So Alice used this tool to pull up the code base of the shopping website. She sees the JavaScript code on the left and the actual website on the right. So her assumption for the behavior of this website is the following. When the user clicks on the background of the website, a pop-up will show up about promotion going on for this website. And if the user decides to click on the close button of the pop-up should disappear. This is our expectation. And let's see what happens. So now I'm Alice. I'm going to click on the background of this website. And I will see that, well, indeed, the pop-up shows up. But at the same time, besides seeing the final UI state of the website, I also see the intermediate UI state preceding the final state in this UI state timeline. So I can see that the pop-up first shows up, and then later the grayed out-ish background is added at the end. I also noticed that there are some numbered circles on top of each UI state, and they are used to connect visually each UI state and the code that results in their creation. So for example, if I click on the UI state 1, I can see a bigger view of UI state appear in the interface. And I can also see that in the code, line 43 and as a result, line 57 leads to the creation of UI state. So at this point, Alice looks at all the information she sees on the screen, and everything looks pretty good. So she moves on to test out the second user interaction, which is closing the pop-up. And once she clicks on the close button, she expects the pop-up would disappear. But in fact, it does not. And if Alice were using some tool, some traditional debugging tool, all she would see would be the final UI state. And she would be really wondering, like, what's going on? Is my computer freezing, or is the execution not going well so far? But with Unfold, she actually could see the intermediate UI state preceding the final UI state. And with this UI state timeline, you can see that the pop-up did disappear by the end of state 4. It came back on in state 5 and 6. So this is apparently a buggy behavior. But the goal for debugging is very clear to Alice. All she needs to figure out is what code that leads to the creation of state 5 and 6 and prevent those lines of code from executing. So by looking into the code base, and she's looking for numbered circles with numbers 5 and 6, and she realized that function openModal got executed unexpectedly. Supposedly, the openModal function should only be executed when someone clicked on a random background on the website, and only the click event handler for the close button right here, around line 50, should have been executed by the second click event. So what's going on here? I'll jump right into the explanation, since Alice is very expert in web development, and she's familiar with the DOM structure of this web application. It turns out what's going on here is event bubbling. A click event happening on the close button here got bubbled up onto a parent node in a DOM tree, which is the whole website. So to prevent this click event on the close button from bubbling up, it's very easy. All you need to do is add a propagation call at the end of that click event handler. So the event would not bubble up. And this is precisely what Alice would decide to do. So she adds in a call to stop propagation to stop the event from bubbling. And as you might notice, as soon as she starts typing, the bubbles inside the code editor turn into a somewhat unreadable color. And this is an indication that the interface she's seeing on the right is no longer in sync with the code on the left. So to refresh the visualization she sees on the right, she needs to save her code changes. And this is what she's doing now. So after saving this code change, the information on the right gets refreshed without her having to repeat the events she had provided. The events are automatically recorded and replayed. And all the information, all the visualization, including the final UI state and the UI state's timeline, got updated corresponding to the code change. So now, with this fix, you can see that the UI states correctly landed on the state that she expected. The pop-up did not show up again. And that is the end of demo. Now back to the presentation. So I want to spend some time talking about the design rationale behind our paradigm and the system. Because the design space is really big, and we need to figure out what design goals we want to prioritize so that the system would satisfy user needs as much as possible. And to that end, we ran an exploratory lab study with 5 programmers experienced in this domain. We had each programmer debug one of the 2 buggy JavaScript applications, a table editing application and a to-do list application. And the purpose of the study is not for us to collect evidence to further validate, but for us to explore the design space of our system. So we want the lab study to be as natural as possible so that we can observe programmers' debugging behavior and draw some insights. As such, in the setting, programmers can use any editor or debugging setup that they like. So we ended up seeing people using a variety of different editors, but for debugging setup, they all ended up using either print statements, console logs, or the browser's developer tool for using the debugger. So our findings imply 3 design goals that we prioritize for our system design. Number 1, our system should support non-interruptive tracing of UI state changes. It should connect output to the code in a visual way. And finally, our system should automate event triggering so that people don't have to repeat providing event sequences in order to debug a certain UI state. And after we designed a system with these design goals in mind, we also ran an evaluation, which is a comparative user study, trying to see to what extent our system can help people debug GUI applications. To that end, we ran a comparative user study with 12 participants, and each participant debugged 2 GUI applications, one using Unfold and the other using a traditional browser developer tool. They spent 30 minutes on each application, and each application came with 2 bugs. We randomized the order of the debugging setup as well as the apps to avoid learning effects. And from the study, we collected both quantitative and qualitative data. So quantitative data such as the success and time one participant took to complete a task, and the qualitative data in terms of user feedback on our system and their perceptions. So for quantitative results, while we observed no effect on the success of debugging or on time on fixing bugs that caused by our system, we did observe an effect caused by our system on the time it took participants to locate bugs in one task. If we looked closely at the results for the effect on time on locating bugs, in this box plot, you can see the red rectangles correspond to participants using the browser development tool, while the blue rectangles correspond to participants using Unfold. And our results show that participants debugged slightly faster in the memory game task using Unfold, with a difference of 0.9 minutes. But it debugged significantly faster in the calculator task, with a difference of 15.7 minutes. And the statistical significance have been evaluated using a Wilcoxon line rank task on the medians of the values. In terms of user perceptions, we saw that participants found Unfold easy to understand and use. They found it helpful for debugging. But we also saw a lot of desire for customizable inspection of UI states. So here are some concrete real suggestions that came from our participants. Participants wanted to inspect non-visual states in a rather visual way. They wanted to filter out uninput UI states and connector labels when there are too many of them. They'd like to examine UI components to particular UI state, and they also want to adjust the granularity of information displayed on the screen. So reflecting on our user evaluation results, as well as our overall system and paradigm design, here are some future work ideas and reflections we'd like to discuss with the audience and the community. So the first future work idea is a live debugger that suggests fixes. Recap, from our study, we observed no effect caused by our system on the success or time of fixing bugs. And this makes sense because debuggers might be helpful for locating bugs, but they don't really suggest code. Current technology include code repair works that help the user to suggest code fixes, but in existing code repair technologies, user is unable to preview the effect of the repair suggestions. We found live programming to be a really promising direction for the user to understand better the effective fix suggestions and further tweak on the suggestions. And so for future work, we propose a more live preview in a debugger setting where the debugger suggests code fix suggestions and the user can use live programming to preview the suggestions. And as a matter of fact, there has been some ongoing work, really exciting, at UC San Diego that works around the space, live programming and validating code suggestions. And I'd be happy to talk more about that offline. The second future work idea we have is the use of more human-centered design in live programming systems. What we observed from our user study is that users provided rather positive perceptions to our subsystem. This is great because we can see that human-centered design really works. Remember, we designed our system through a formative study that ground our design in the study findings. On the other hand, we also observed some effect caused by our system on the time on locating bugs, but only in one task, not the other. So these results make me wonder, or make us wonder, what happened? What happened in that task? Why did people locate bugs faster in one task and not the other? So directly to our project, the next part of future work we plan to do is to dive deeper into the user behavior data that we collected. we want to understand the success failure lessons here better. Why do people debug fast or locate bugs faster in one task, and why do people not debug faster in another task? But taking a step back, looking at live programming systems in general, and we'd like to propose a message to the overall live programming community. We see that there's currently more understanding needed for the usability of live programming systems, especially existing systems. And for future work, we'd like to propose a more qualitative evaluation of live programming systems in general, so we can reflect more on the existing designs and think more about possible improvements. Finally, this is not necessarily a future work idea, but some open problem domain we noticed that we really don't have answers for. So I like to pose up here, pose a few open questions so that the audience might find it interesting to think about. Scalable live programming. Why do we do this? What we observed from the user set is a desire for more customizable inspection of the visual information displayed on the screen. We also know that with customizability, here comes the scalability problem. And scalability in live programming has been an open issue for many, many years. So a few open questions we have here are the following. How do you want to tackle liveness for larger and more complex systems? How do we want to support live programming or liveness, live state first debugging for program state that does not come with its default use of visual representation? And how do we want to enable liveness for domains where viewing program behavior can be really useful, such as systems programming, server development, and CI/CD workflows, such as data actions. So with these open questions in mind, I'd like to wrap up my talk. In summary, we introduced the paradigm of live state-first debugging and its implementation for JavaScript GUI apps, Unfold. We demonstrated through a user evaluation that Unfold made locating some bugs faster for users, and it was perceived positively. We proposed a few future work ideas, including liveness for previewing bug fixes, human-centered live programming, and we posed open questions around scalable live state-first debugging. And that is the end of my talk. I thank you for your attention, and I'm ready to take questions. Oh, by the way, if you want to take a deeper dive into our work, here's the link to our paper.
Mike's over here.
Hi. That's it's very nice work, and it looks like it's probably quite useful. But why do you call this state-first debugging? All debugging's about state. That title doesn't really work for me. To me, I would call this some sort of UI replay, replay UI replay debugging or something. So my criticism is think about the title.
Good question. So I think it makes sense to maybe go back to this slide a little bit. We're calling the line of work around conditional breakpoints and object-centered debugging as state-first debugging, in a sense that we think techniques like print statements and traditional breakpoints away, forcing the programmers to probe into program execution in order to get the state information. Whereas in these techniques, there's no need of execution probing. You just have the state information available in front of you, taking them for granted. So that's the biggest difference we observe between these state-first systems and execution-first systems, and hence the definitions we assign to these two different categories of debugging paradigms. Does that answer your question?
Hi, thank you so much. That was really great talk, and I never thought I would be so excited about debugging. I wanted to ask if you've thought about using this kind of debugging in a non-UI scenario. So obviously, this seems great for working with UI code, but what about when there's no UI or there's like stuff that's a bit hidden? Yeah, has that ever come across your mind? Yeah.
Yeah, hey, that's a really great question. And so in this work, we started off with UI states because these visual representations are just available and we could just take them for granted. Like each DOM tree will be visually rendered to some UI representation, fairly easy. But in terms of non-visual information, I think there could be some work around more generic techniques of creating visual representations for such information. In terms of how those generic techniques or how those generic representations might look like, I don't have a concrete idea now, unfortunately, but I do think that is a super interesting line of future work to pursue if you do want to enable like stay first debugging to more, or live stay first debugging to more generic domains.
Sorry, this is not a question. I just wanted to follow up on that previous question and mention a bit of related work that I think would be very interesting to this community, which is this project called XII by Henry Lieberman. And they define diagrams off of program state and sort of have the idea of stepping between those states. And I wonder if you could apply that idea to solve this problem of if you don't have a UI, you can create another visual representation and sort of use that as your unit of stepping.
Yeah, that is definitely a promising direction. I'm aware of that paper. It's really exciting work. And it's, I guess, trying to refresh my mind about that paper, and I really investigate like deeper about how they represent like non-visual information on the screen.
Hi, great work. I also got enthusiastic about debugging, but I was already enthusiastic about it. So your work ties this going back in time and replaying events to live programming, which I think is correct. But I didn't read your full paper yet. I only just got the link. But I think this is also called omniscient debugging, this going back in time and replaying. And that could be more related work to add. So, but great work. Thanks for the talk.
Yeah, thanks for the feedback.
Okay.
Thank you, Lisa. I saw quite a few more hands here. If you can stick your questions in the Discord thread, hopefully Lisa can get to them. Our final talk of the day is coming from Mary Rose Cook. It is Lude Make, that's L-U-D-E, not L-E-W-D. Make video games quickly, I think. Is that the subtext? Mary, are you there? Are you with us?
Yeah, I'm here.
I hear you, good. We're just waiting for your video on the projector here, so give us just a few seconds for that. Thank you both for getting up early on the West Coast there to be with us. We tried to make it as minimally painful with the scheduling as possible, but I know there's only so much we can do, so thank you.
I really appreciate that. Thank you so much.
June and I did consider scheduling you two for 1 in the morning. Yeah, we're just, okay, we see you now. You're good to go. We don't see, unless you've turned into 2 spinning blue squares, we do not see your video here. It's up to you whether at this hour of the morning you want to fix that.
Let me try again.
Yeah, you could try toggling the video off and on again.
Okay, great.
Do
you see me now?
You're very blue squarey at the moment.
Oh, that's disappointing. Can you see my slides?
We absolutely see your slides, yes. And we can see your
Okay.
presenter notes as well. Whether or not that's deliberate, I'm not sure. But yes,
Let me try again.
your very 4x3 aspect. You can go wider if you want, but oh. Okay, now we don't see your slides.
Okay, let me. All right,
Okay,
so
well, we
hopefully
still
you can
see your
my
presenter notes, but we can
slides.
see we see the presentation.
Okay, great. Well, we may have to go with the presenter notes, if that's okay.
That's okay. Oh, now it's full screen.
All
You're in
right.
business.
Okay, great. Perfect. Cool. So, and you still can't see me?
Nope.
Can you see my video, or should we just skip that?
Yeah, just go ahead, Mary, unless you needed to show
Okay,
something
great.
that you're holding or something
No,
like
that's
that.
fine. Don't worry about it. That's great. All right. So yeah, thanks everyone. Thanks for being here. Really nice to see lots of friendly faces. I'm going to talk about Lude, Lude, which is a tool that I've been working on for building games quickly, specifically 2D video games. And I found some amount of success so far. So in this talk, then I'll show a demo of building a kind of rudimentary breakout in about 10 minutes. And so quick overview of the talk though. I'll do a tour of Lude, just to orient us all. And then I'll talk about breakout, just so that we know what we're building. And then I'll talk about the techniques that Lude uses for letting you build games quickly. And then the piece of the talk will be demos illustrating these techniques for building quickly. So let's look at Lude. It's composed of two parts. There's an editor which runs on the desktop in the browser. And then the second part is the game which runs on your phone, your real phone, not a simulator. And so you can see the editor there on the left, and you can see me holding up my phone, running the game in the bottom right. And you can see, you will see in a minute, a kind of screen share of my phone, which is just for your benefit, so you can see what's going on the phone, but that top right part is nothing to do with Lude, it's just a screen share, so that you can see what's going on. So that's high level of the setup. And then the Lude editor itself, we'll dig into these pieces, of course, shortly. So on the left, you have kind of a live level editor, and I'll talk about what that means. And then kind of in the middle there on the desktop browser part, then you have a series of editors. You have a object editor, which lets you edit properties. You have a specification editor, I'll talk about what that means. And then we are currently looking at the code editor on the kind of middle right there. So that's high level. And then quick review on Breakout, if you've never played it or seen it before. So it's a game where the player controls a paddle. That's the kind of green bar at the bottom there. And they use it to try and knock a ball towards some bricks. And when the ball hits a brick, the brick's destroyed. And the goal of the game is to clear all the bricks. So that's Breakout. Lude uses 4 techniques for building quickly. Number 1, directly manipulating the game as much as possible. You use direct manipulation to make any edits that you want to make. Number 2, you play test on the device, and that is a separate device from the device on which you're editing. Number 3, it's a live environment, you know, on brand for the conference. So changes you make instantly available to try. And number 4, because it's 2023, it uses code generation. So let's get on with the demos. All right, so hopefully you can see video playing. Let me know if you can't. So I'm going to add the ball and then some walls to confine the play area. And you can see me just drawing the ball there. Nice yellow color, just resizing. And then I'm going to add the walls. I'm going to start with one wall, get it the right size. And then I'm going to get so it can't move by using the property editor there. And then I'm going to draw in a nice wash of color for the wall itself. And just as a reminder, on the right-hand side, you can see everything that's happening on my phone. So it's live, it's being updated instantly. Now I'm going to duplicate that wall, make more walls, and get those into a nice position. Now we've got the ball and walls. So a bit of editorial about what happened there. So we used direct manipulation, as you saw, to position the objects and to get them to the right size. To edit anything about an object, so its appearance or its data or its behavior, you start by directly selecting it first. So you click on the thing. So I found it's profound to see a problem in the running thing and just be able to click on the problem itself. You don't dive off into some other context like code or a separate image editor or something like that. As you saw, we draw directly onto objects, and so we see drawings in their real context, at the real size, surrounded by the real objects that they'll be in the real game. And one extra thing to say about this is that this direct manipulation in a level editor is definitely not new. It's standard practice for video games, certainly. But this feels a little more powerful because generally with traditional level editors, then the game runs in a separate window. So you level edit over here on the right, and then you run your game and you see the results in a separate window. But here, there's no context switch. So you just click on the thing that is actually running, and it's a lot more consistent, I think. So that's technique number one for building quickly. Technique number two is you play test on the device. Let's watch the video. So we're going to add a play button that when the user taps it, then it will start the ball moving. So we set it to be so it can't move and can't collide with anything. And now I'm adding the behavior. We'll talk about how this all works, behavior definition later, but basically I'm saying when the button is tapped, then start the ball moving, the code was generated, and now as you can see in the bottom right there in the video of me holding up my phone, I can just start playing with it right away on the phone itself. It's been live loaded into the real running device. So this technique of playtesting on the device has some nice properties. So first you saw I can playtest the chain instantly. I can know how it will actually feel to play because I'm playing it on the real device. And then having two separate devices is also powerful for the editing. So you use one device to edit and the other to playtest. Like I say, you edit in the browser on a desktop, and then you playtest on your device. This two-device thing is really fluid, and I think the best way I can illustrate why it's fluid is to think about certainly the main alternatives that I could think of to this approach. And so number one is to introduce modes, where you switch between edit and play mode. So you can imagine that on the desktop there's like a toggle, you switch between edit and play, and yeah, don't need to go into why that sucks. Jeff Raskin's already told us about why that doesn't work very well. The other main option that I could think of was to have a single surface support both playing and editing simultaneously. So you click on a button, or you somehow click on it to trigger it in the same surface, so probably in the browser, I guess. This is a super heavy design burden, especially if you want to maintain the property of direct manipulation as much as possible. So for example, just one problem you have to solve. You need to allow a button to be both selected and also somehow triggered from the same surface. And there's like a million other overloaded inputs that you'd have to grapple with design-wise. Whereas instead, you could just, as I did, I just separated the job into two surfaces. On mobile, a tap on the play button triggers the button. On desktop, a click on the play button selects the button for editing. Super simple. That's part two is playtesting on the device. Makes things faster and more fluid to build. Part three is the live environment. Let's watch the video. So we'll now add the paddle, and we'll let the player move the paddle around by tapping on the screen. So we're just drawing in here, nice green color. And then we're going to add behavior. Again, we'll talk about how behavior definition works in a minute. So when the player taps the screen, the paddle moves slowly in the X and Y direction towards the location of the tap. So we're just going to generate that code and try it out. Looks good. The paddle's moving around. You can see the bottom right there tapping on my phone. So what happened there? Well, everything's live and there's no compilation or reloading. So edits made to the properties of objects are live the instant that they're made. So when I make the ball movable, they stop moving at that moment on my phone at that instant. And code additions or edits start running the instant that they're generated as well. So when I got that code generated, as soon as it was syntactically valid, it was run and loaded into the live environment on my phone. So obviously this means you can try out changes right away, which is really nice. But I think the bigger advantage here in terms of quick building is that the game designer doesn't lose their place when they make changes. So the game state that inspired a change that you wanted to make is the state that the game's in when you make the change. So where all the objects are, you make the change in. And then once you've made the change to your game, then the game is still in that state, ready to go, ready to try out the change in the exact context and setup that inspired the change. So it's a really, really nice type feedback. That's the third reason that it's fast to build and load. And the fourth one that I'll talk about is code generation. Let's look at the video. So we're going to add a feature to give the player a bit more control over the ball. High level, when the ball hits the paddle kind of far to the left of the paddle, and we want it to sort of bounce off much more sharply to the left. And then when the ball hits the paddle far to the right, we want it to bounce much more sharply off to the right. So this lets the player direct the ball towards the bricks with more precision. So we're just writing in the prompt there to describe that behavior. And we're going to generate the code. And then we can try it out. I'm just unpausing the game there. And look at it playing. So you can see that when the ball hits far to the left of the paddle, it really kind of pings off at a sharp angle. So how does code creation work? Well, sort of high-level programming model, probably no big surprises, is binding event handlers to objects. So, for example, when a collision event happens between an object type ball and an object of type paddle, then change the ball's velocity in the way that is described. Now, the behavior for event handlers is defined in code, and you can either write this code by hand. We're looking at the editor right now. You can just type in there, that works fine. Or you can generate that code from an LLM based on the specification that's written by the user. And those are those pieces of code that you've seen me writing throughout the demos. Let's just jump back to the, okay, so that we've got it in our mind. So it's a piece of code like that. How does it actually work in practice? The user starts with select objects they want to define behavior for. So in this case, you can see the ball of the paddle selected. And then they write the pros, writing which event they're talking about. So, a collision or a tick or whatever. And then describing the behavior that they want to happen in response to that event. So you can see that example of pros in the center there. And then if you want to debug, then you put constant logs inside your handlers in a way that is fairly common, and the logs show up in the DevTools. So why are we doing code generation here? It's because it's faster, generally speaking, not always, but quite often. And this is for two main reasons. Number one, often the LLM is better at translating the designer's intent into code, the designer is. So for example, for me, it's better than I am at implementing geometric functions. So it can get to the idea express the idea more quickly and correctly. And second, it's just often quicker to type in the prose. You know, this prose piece of code is relatively long, but it's still certainly shorter than the code. And quite often, the prose version is much shorter than the code that's required to implement it. So those are the two reasons it's quicker. And so it got to the point where I was like, well, if I can do code generation, I kind of want to do that given that it's faster. And so really, the problem becomes mitigating the problems of code generation. And so this boils down to capturing the designer's intent successfully in code. So they have something in their head, they want to successfully capture it in code. Getting that translation is the problem. And so what Lude does is tries to support that intent and expression with a bunch of things. So number one, as we saw, the designer selects the objects they're talking about. In this example, the paddle and the ball. And the LLM therefore knows, it uses those as the type of prompt, and it knows what you're talking about. Second, the designer expresses their intent by repeatedly revising the specification. So if it doesn't, they type run it, or generate and run, and it's not what they wanted, they then edit the piece of prose. And I think this is I found that this carries more meaning than a back and forth chat. It's sort of more dense meaning. And the intent can also be more precisely inferred from the prose that the designer wrote in and from the code that already exists. The code that already exists seems somehow more ambiguous. But at the same time, the specification is not everything. So the LLM is also still given the code to work from. And this means that if the designer sees a change they want to make in the code, they totally can. So let's say they want to tweak a constant or something, or make a bigger change. And that intent that they've tried to capture there does get carried forward into future versions. And so the LLM kind of does this, I guess, looks at the code, looks at the spec, and comes to some sort of agreement between them. And then finally, and I think this is probably the most important factor in successfully capturing intent, the LLM writes code using a game engine that's built into Lude. So this constrains it to one way of doing all the common things you do with 2D video games. So one way of drawing, one way of handling physics, one way of getting input, things like that. And this helps it retain internal consistency in the approach to the code that it's generating. And these Lude built-ins are the things that many games need. So, for example, you saw at the beginning that once I set the ball going, excuse me, the ball bounced off walls already. And that's because that's built into the game engine, because it's a behavior that is pretty common to video games. So that's the fourth reason that it's fast to build with Lude, is code generation. Let's watch the end of breakout video. I'm going to add a new object that will become a brick. I'm going to move it so that set it so it can't move. With a nice orange color. I'm going to make a few more bricks. Then finally, I'm going to define that behavior of when the brick detects it has collided with the ball, move the brick down by 600 pixels. So this is in effect destroying it. So we generate the code for that, and we try it out, and there go the bricks. Lovely. All right, so that's breakout. Quick summary. So the techniques that Lude uses to build quickly, directly manipulating the game as much as possible. Super intuitive, often the quickest way to make the change. Number two, playtest on the device, so you can try change it right away. And there's you can actually feel what the real game will be like to play. Next, a live environment, so your changes are ready to try and see, and you don't lose your place, you stay in the context of where the game was in when you wanted to make the change. And then finally, code generation, often faster than writing the code by hand. Thank you very much. And I would like to say thank you also to my friends at Ink and Switch who have been extremely supportive, kind of, I guess, sort of emotionally and also through pragmatic ideas. Many of the best food discussions that happened at Ink and Switch. So I really do appreciate it. Thank you so much.
Okay, questions. I see we have one so far.
Hello.
Sorry. Oh, hello.
Can you hear me?
Hi.
Hi, I'm Remy.
I can hear you, yes, thank you.
So, yeah, I already sent you an email to get in touch with you, but didn't do it yet. Yeah, I've been in the area of programming languages and games for about 10 years. So it's very good to see someone else thinks this is a nice combination as well. So, yeah, talked about another tool for game design as a case study for generic language technology. But what I was wondering is how expressive is this environment for creating games? Because I see that, okay, you have colliders, you have things moving around. How can you sculpt the gameplay in different directions? This is kind of my question. What kind of different games can you make with it?
Yeah, it's a really good question. I've made kind of 2D physicsy games like Breakout that we saw pretty successfully because there's a physics engine built in, and so that gives you quite a lot of the pieces that you need. I've also made much more document-like games where it has tables of information, graphs, and it's mostly just buttons and typing into text boxes and things like that. And that works pretty well too because in the end it's just a different rendering layout engine, really. It's still just objects that need to bind to event handlers and stuff like that. So I found it's relatively flexible. I feel sure that the big limit on its expressivity is much more about building things into the game framework than it is about the programming model or the editor. So for example, if you want a really nice sprite editor, then that has to be written and built, or if you want a nice animation engine, that has to be written. And so I think it's more like just building those batteries, if you like, that's the large amount of work.
One follow-up question, is allowed?
Yeah, great. Yeah.
Okay, so I think that if you call this game prototyping, then you could call it a framework for prototyping and playtesting, which are kind of game design oriented. And maybe you can think about how such games, after they are a prototype and they're fun to play, that somehow you offer that up as something to then fine-tune and maybe add stuff on. But yeah, then I think if you do it like that, then it can be a tool for game design. So that's...
Yeah, I think that's a really good prompt. Yeah, thanks.
So I'm curious to hear how you think about communicating with the LLM, specifically when I think about how a game engine would communicate with LLM. There's considerations around how you create guardrails for the LLM, how you scope the context, especially with games where it's like a entity component model or whatever patterns you're using in the game engine. I imagine those would align quite closely with how you choose to negotiate the communication with the LLM. And so, yeah, I'm curious how you're thinking about that.
So you're asking about how the LLM understands the game framework?
Yeah.
Yeah, it's a really good question. So far, I've found giving it a readout of all of the interfaces of the APIs that it has access to, it's pretty good at using them. And so that can be mostly auto-generated from the game code, the framework code itself. I also have been experimenting with putting in the documentation, but the documentation itself is pretty meager at the moment, so that hasn't gone very far yet. It is fairly good at staying within the guidelines of the framework. Occasionally it kind of goes a bit, bananas and gets confused, but generally it can understand how it's supposed to use APIs.
All right. Hi, this is Will Creighton from Brown. And my question is, I saw that you had like the play button on the screen along with all of the other stuff from the breakout game. And I'm curious about organization. Like, let's say I wanted to have the play button on its own screen. You click play, the button disappears, and then I have the breakout game come up proper. Is there a way, is there some notion of like layers or other ways that I could separate these things out? Or when I'm editing, do I just have to have everything from every screen in the same space all the time? Like, what do you think, either are there already facilities, or what are you thinking about for facilities to organize the game state when it's more complicated like that?
Yeah, it's an excellent question. I think this is one of the central questions around code generation that I've been grappling with, is that really the meaning is spread across the code and the prompt that the user types in, and to some extent the state of the game as well. And so keeping the relevant parts of that on screen at the same time is challenging. So I think the next version of this would look at that more deeply to let you essentially assemble a context that you need for your current problem. So exactly like you say, sometimes you just look at the code, but most of the time you want to see all three of those things. And having the editor be more adaptive to your context would be really helpful.
All right, thanks.
All right. All right, I think last call for questions. Thank you, Mary. Really cool stuff. It's nice to see it on stage here today. That was the final talk for our workshop. Can we get a round of applause for all of the presenters and for our volunteers who have been helping us through all kinds of exciting challenges and crashes and video streams and so on. I think this is the first year using Discord as well as the host, so it has not been completely bump-free, but honestly, it's gone better than I actually thought it would. So kudos to all of you for doing that. Thank you so much.
And thanks to Peter and June for sharing this and making it all happen.
It's a real privilege to be here with you all. So we had a little bit of time left, and we wanted to try and make things a little participatory to end the day on more than just sitting and listening to people talk the whole time. And folks on the live stream I think you can hop in, and can they hop into the stage? So don't just start yelling or anything, but you're welcome to jump in and join the conversation. But we wanted to, June and I have been sort of trying to find themes or like questions implied by people's talks throughout the day. So we thought maybe we would try a couple of different discussion topics. Yeah, so maybe should we pick these off one at a time? Maybe we should pick these off one at a time. I'll try and time box them so they don't go too long on any one subject. And then at the end, we're going to put you guys to work, guys and gals to work, helping build next year's program, because next year will be the 10th anniversary, 10th edition of Live, and we want to make sure it's a really good one. And the people in this room, if nothing else, you can start thinking about what you want your submissions to be now. And you can nominate ideas that you hope somebody else will submit now too. Okay, so June's just getting that up on screen. Awesome. Okay, so June, do you want to read the first one there? Sorry? Do you want to read the first question? This was your proposal for a prompt here, or do you want me to read it? This was your suggestion. Oh, okay. I thought this came out of our. Okay, I'll read it then. So we've seen a couple of different takes on the role of LLMs in live programming. And we've seen a bunch of different opinions, thumbs in all different directions earlier, in terms of how LLMs might intersect live programming. And I think one thing that is in the live programming kind of pitch is that live programming can increase user agency. So does outsourcing your code to an LLM make you a bad programmer and possibly a bad human, based on some of the thumbs and fingers I saw out there? Or does this actually just automate the grunt work that none of us should have been doing in the first place, just like moving out of assembly language to higher level languages did? I think we can see both perspectives, and I see lots of hands going up. Let's just start calling on people. Do you want to start running the mic around? Awesome. Bring us your spiciest takes.
Oh, you know it. Thank you, Peter. That was a great introduction. So I raised a middle finger proudly when the survey of LLMs came up, for a reason that I think is especially relevant to this room right here, which is that like one of the things in live programming and a lot of the talks today were at least flirting with, if not fully embracing, visual forms of expression. And as far as everything I've seen from LLMs, it is very much language as text. And so I would be very, very interested to see if this group of people can come up with some ways to use LLMs that are not about text at all. Whether that's even possible, I don't know. Or whether it would be any good, I don't know. But I think, just personally, like text is evil and bad. And if like text programming is your definition of programming, then we shouldn't be programming.
If you bring an LLM visual programming environment submission, I 97% promise you have to put some work into it. But I would, that one would be super fun. So
if you feed an LLM visual programming language, if you feed a mouse a cookie.
It's bound to ask for a recursive evaluator.
Yes,
Yeah.
Anyways, that was my first thing. Lou, you had a...
Hello. I think the question is quite tricky because, like, it's like saying, you know, LLMs it's such a diverse use of them. Like, I think it's like saying, does coding, you know, do computers increase or decrease user agency? I think, yeah.
Okay, now you have to say which ways would increase user agency in your opinion and which ones would decrease it. Give us, you don't have to have a definition, but give us an is Chicago, is not Chicago, right? Like what's a thing that would and what's a thing that wouldn't?
Well, all right, cogs are turning.
Yeah.
So I think, you know Maggie Appleton?
Yes.
Yeah, I share an office with her, and I think she just like, all I'm trying to do now is summarize like her most recent talk in like 2 sentences.
And we can post a link to that on the Discord
and,
later.
Like talking about like how AI tools can do both of those things, and how when they're good they like enhance, and when they're bad they replace. So I think the big question to ask yourself is this replacing you or your employee? or is this enhancing you or your employee? And there's like cultural issues involved in that as well.
There's a great Canadian philosopher, metallurgist, and pacifist feminist, Ursula Franklin, who wrote a great book a while back called The Real World of Technology, where she classifies technologies as either empowering the individual and giving them holistic abilities to pursue their own aims, or else placing them under management and making them cogs in a machine. And I think that's a great framework for all of us to evaluate our work, and both professionally and personally.
Yeah, thanks. I'll pass it on now.
I see Clemens was waiting for me. Yeah.
I'm afraid that LLMs can introduce a certain conservatism based on what they're trained on. And I think live programming environments require us rethinking the programming models. And I think by using LLMs that are trained on the old days, we will be stuck. Reinforcement
learning gives you more of what you already have. This is the concern. We're here, Jonathan. That's how it's different from today. We're here to break the mold.
This is it, pretty much. There are dozens of us.
Literally dozens.
I just wanted to offer a counterpoint to that, from speaking from concrete examples. So last year, I with some collaborators developed this live programmable dynamic document environment, and then we decided later on to try adding LLMs, and we just sort of like Mary did, fed it the docs for our made-up spreadsheet language that we had invented, and used it as sort of an accelerator of this end-user programming environment we had already created, which had liveness and data visibility and things. And we found that we weren't just looking at textual code, we were looking at not the most visual representations, but at least tables of live data, and it sort of fit in very naturally. And so I'm quite optimistic that if we don't forget all the good stuff that this community has discovered and we remember it and combine it with this new tool, we can get sort of strictly better experiences that are not worse in any meaningful way and are much more empowering to get started with. And I think it would be a real shame if we sort of had like a reactionary attitude towards this new technology.
Rah, rah, rah.
Yeah,
Things were fine before.
Especially if we're all really good at programming. I think a big draw of live programming for me is accessibility to novices and education. And I think we should all be thoughtfully considering how to use LLMs in that context as an on-ramp.
Josh has had his hand up for a while. Josh. Sorry, is it Josh? Oh, I can't see through somebody's head there.
Is this you talking about here?
That's not.
I just want to say something about what you said about education. I think when someone asks a question and you go and you give them the answer, you're not really teaching them anything usually, and I feel like that's a lot of the experience with LLMs when people use them for programming. And so I wonder like whether that's real empowerment or if it's just a crutch. So,
Give that microphone to the man who gave a talk about LLMs. He's been so patient there. Wait, is that not? I can't see. Okay, I don't know who's. I see just a head sticking. Okay. Give it to Will. Okay.
All right.
Sorry.
Thank you. Not Josh. Hi.
Can't see through. Sorry.
So, that's right.
You there with the microphone.
Me. So, I tend to think about as at the two extremes. I think about it as like LLMs are sort of. You can think about it as when you make a child literate. You are exposing them to a world of knowledge and giving them an immensely powerful tool, which of course is dangerous in some ways. You can also give a baby a loaded gun, and that's just like strictly irresponsible and dangerous, and because you recognize that no one's going to know what to do with it, and at worst they're going to harm themselves and others. And I think actually for this community in particular, I suspect the way that LLMs will intersect with live programming is data analysis. This is the gajillion-dollar market. Everyone's doing LLMs to SQL and to data visualizations, and I think this will be one of the most important domains for us to consider. And it's just being abused horribly. Like Jeff here had a great talk. He's a professor at UW, studies data visualization. And he talks about how, like, in the marketing materials for ChatGPT doing data analysis, you just say, run a data analysis on this data, and it, like, produces some pretty-looking charts that don't mean anything and have, like, weird interpretive errors. And, he just talks about, like, when we encourage people to use tools that way, obviously that's actively encouraging them to be completely irresponsible with their data and then to make downstream decisions that are probably going to harm people. And so
Are you implying that venture-backed startups eager to capitalize on a mega trend are just throwing together slapdash implementations of the new hotness and putting it out there without any consideration for whether it has any value?
No, I would never imply that.
Oh, good. Thank goodness. We don't have any corporate sponsors for this workshop, but if we did.
And so I think as the authors of live programming environments, I think a very interesting question is how you can like simultaneously provide your users agency but guide them away from making these horribly irresponsible decisions, either by making actions impossible or providing guide rails or guidance. I don't know what that guidance looks like, but I think it's one of those...
You tell GPT, please guide me towards responsible decisions.
Yeah, correct.
I'm not even joking. That stuff works really well.
Yeah. And so I think investigating that of, that's an ethical consideration in the creation of these environments, and it's something that people should be talking about as they design things that incorporate LLMs.
Do we have anyone who hasn't commented yet? I want to make sure we're creating opportunities for. Mariana hasn't said much in this. I'm bad for this, and I know I put my hand up a lot too. Yeah, Josh there in the front. No, I'm kidding. It's you. Mariana, go ahead. All right.
I have something really short while Mariano's thinking about what he's going to say, since you put him on the spot. So I think a lot of us, when we're building systems, we're thinking about building collaborative systems, like systems that allow us to collaborate with others. And if you brought someone else, another human, into your system, does that limit your agency? Like if you have a coworker that joins you, does that limit your agency? So my provocation would be to think about modeling LLMs as a coworker in your system. And I think that'll help us not limit human agency.
So I've been playing on and off with it and thinking. And I think there are two ways, the good way and the bad way. At least the ones I observed, there's the lazy way, which is basically, and the thing that basically grabs LLMs and applies it to the current way of doing things, which is write me a React app for a to-do app, and it will just spit whatever, and you will try to run it, and if it doesn't work, you will say, fix it.
Try again.
Basically, it's a Perl generator. It's kind of like a read-only, and you feed it back only to see if it fixes it. It's really, it's not collaboration. It's like, I will try to do the work with the current set of tools that are not, of course, designed for LLMs or anything like that. But also the level of granularity, that's like coarse grain, like write me an app, which only works for Twitter threads with exploding emojis and stuff like that, exploding minds emojis. But something I've tried and it has worked, and I think it's we can use today, and it applies really well to live environments. It's in the small, you have a hole, Hazel style or whatever, you have a thing in your app where you can grab a lot of context, and you can have a really contextual prompt with a lot of information, and you can write half the prompt in the system because of the context, but let the user write the thing they want to achieve, and only feel that at least as a draft, and then make a feedback loop of collaboration. Not that I've 80% or more of the demos using LLMs are really lazy. Make them generate.
But not our speakers. Our speakers' demos were very thoughtful.
Of course not. All things here are on the right side of history. But what I mean, I'm talking more about the Twitter demo, make it do things. It's quoting LNK. Nobody quoted LNK today. Using computers to virtualize an office, paper and stuff like that, and not thinking what's the native medium and abstractions and ideas for this new technology. Of course, the initial step of any new technology is virtualizing the old one, but as a community, we can start thinking ahead and say can we start thinking and prototyping the native way of using LLMs?
And I look forward to those submissions for next year's workshop. I want to actually drag us, just in the interest of time, to a related follow-on question that's come up a few times throughout the session, which is, what is the role of expertise in these live programming systems? Lou's demo implies a heck of a lot of knowledge about cellular automata to do the interesting things they showed. And Xavier's programmable DAW takes all the difficulty of programming and then adds all the difficulty of musical composition. But a violin is not a worse instrument than a harmonica because it's harder. So I've heard a lot of people in this room in conversation and on stage saying we need to make programming easier. Yeah, Lou. Oh, sorry, there's a mic out there, yeah.
Hi, I have very strong opinions about this. I am not for making programming or creative processes easier. I think there is a lot of joy to be found and a lot of good that comes out of being stuck in a hard process. And I think that's what makes certain art forms, and this is, I'm talking within the creative space, but you know, that's a sliding scale as well. So
is programming a creative act?
It may be more than you think. And I've done a bit of speaking to people who are involved in printmaking, and which is a very hard, laborious process. And I'm just curious, because I don't do it. I've been asking them, why do you do this? Why do you do this really hard thing? And I have some audio recordings on my phone if you ask me afterwards. But it forces you into a different frame of mind. It allows you to focus on certain things. It allows you to communicate in a certain way. When we're coding, the limitations and parameters that are around us are sometimes hinder us, sometimes help us. Sometimes they're hurdles in the way, sometimes they're guardrails on the side, and sometimes they're walls that can be smashed for great effect. I know this is quite hypothetical, but I don't often hear people embrace the challenge and difficulty of certain tasks. I wonder how your mindset would change if you consider that.
The goal of life is not to have the easiest life. There's someone at the back we haven't heard from before. Please.
Hi, so I have a similar perspective because I conducted like 15 interviews with creative coding artists, and actually that was one of the points that they mentioned. I thought, okay, do you want to make programming easier? And they were like, no, we want it to be hard because they really like to face these challenges. So it was completely opposite that the answer I was looking for, but that's what I found. Like, yeah, well, we are happy with the tools if it's hard. That's another thing that we like, and that's why we want to do this, because it's hard. It's not for everyone.
Okay, go ahead. At the back there. Yeah.
I think it depends a lot on what the goal is, right? And so, if you ask what makes a harmonica hard to play, right? Composing the song, maybe that's the hard part of playing the harmonica, right? And so
bends and draws, but yeah, go on.
So I think about the Steve Jobs computer as the bicycle for the mind, right? And so you want the tool to disappear if the tool is not of interest. But if the tool is of interest, then fine, right? So, you want to sculpt with clay, and you can decide whether you're interested in the properties of the clay, or you're going to make the clay disappear and make the thing that you're trying to make, right? And, you have to decide when you're designing the clay which your goal is.
I really like this clay analogy, and I'm gonna pull that actually, and to push the conversation in a different direction, which is that clay tools are extremely simple, and the craft is in the knowledge of the user and the practice that they have with those tools. Should we be doing the same thing with our computing tools? Why are we building such complicated things with so many features instead of making smaller tools? Is anyone making smaller, simpler tools? Xavier.
I would argue that this is kind of what I tried to hammer in my talk when I was talking about the composability of programming versus GUIs. And this is what I'm trying to do when I'm designing the project that I'm working on, which is I'm not trying to replicate all the complicated features of a DAW. I'm actually trying to find what are the critical features and isolate them in little pieces that I can sprinkle exactly where I want them. And for me, this is, I don't know if it's the thing that we should aim for, but it's something that I believe is valuable that I'm trying to aim for.
And this is not just about creativity of art, right? What Lou was talking about was struggling against the medium to find discoveries and push yourself to new places. And what you're talking about is having a minimal viable set of composable tools that allow you to work on whatever you need in the moment, which is a very different claim, I think.
Yeah.
You're not like, my DAW is really hard and that's the way I want it. You're like, I'm trying to find the essential truths that are what I need to build a DAW, if I understood you.
Okay, but I think it's connected in the sense that, for example, I play the guitar, and there's a lot of different ways that you can play the guitar. I'm kind of on the lower end in terms of skills. So I play a lot of chords, and chords are really accessible. You can learn like 3 chords on the guitar very quickly, and then you can like sing a basic pop song, and that's really fun. You can also play the guitar 6 hours a day for 5 years and then play really hardcore metal songs that are really difficult. And you have this entire scale from very basic, simple things that have a lot of depth. And I think that's what I'm after personally, is the depth of the tool.
Simple things with depth. I like that claim. Clemens has been patient over there.
So I've been studying some molecular biologists that were really what we call computational disempowered from the fact that they had to use the computational tools and they had to translate from a biological phenomenon to things expressed in code that they were not trained to reason about. When they used GUI applications and their practice evolved, then the GUI applications represented calcified understanding of their practice that would get outdated, so they had to patch that with various scripts that they didn't understand. So I think one problem is when people have to think in one set of concepts, but try to express them in programming that they are not interested in or skilled in doing. And I think that's the bridge we need to.
It's a great argument for easy. Yusuf had a...
Well, no.
Oh, okay. So he says no. Well, yeah, right. Biology is not easy, but it's for making the tools easier to work with. Yeah, for the biologists, for the domain people, yes. Yeah. Oh, yeah, sorry, Todd, yeah.
From a personal level, like what Lou mentioned, like really resonates. Of course, when you're building and you've been at it for a while and you're like an expert in your craft, yeah, you feel like an artist and you enjoy that creative process, etc. But what I'm missing is on a societal level, in a society where digital technology is increasingly important, like it's powering everything and our entire society, democracy, etc. I don't want to live in a society where only like 2%, maybe 0.2% know how the systems that everybody depends on use. So I think I really see it as a mission, to explore how can we make things easier. And I think, live programming definitely plays a role in that. So I think that's.
Yeah, and ownership of the software. We shouldn't be sharecroppers in our digital lives. Todd has had a hand up for a while. Sorry, Todd.
I think one of the common themes here is around this word expertise, and I think it's an important distinction to make that expertise isn't whether something is easy or simple. Kind of if you spend time with something, you become comfortable with it. And there's a level of expertise or practice in a craft that makes you good at something and see through the obstacles in a way that is unique to whatever the craft may be, printmaking or modeling with clay or programming. And then on the other side, there's this like path of easiness, which may be closer to like intuition or the pick up and play or this wanting to get your hands dirty or make a thing. And when you have that urge to make a thing, you also push through the difficult challenge of like, okay, well, I'm gonna play with clay. I've never done this before. You have to learn, you have to kind of push yourself.
So you're saying it shouldn't take 3 hours to set up a node development environment before you can start making a web page?
Oh my goodness, I don't have to say that.
Yeah, okay. And there's companies that are just trying to solve that problem in a narrow sense. Let's give the last word to Alex, and then we're going to move to a new subject.
So this is also about what Lou was saying. I think there's a difference between having to fight against a difficult problem and having to fight things that are contrived in the tool that you're using. And I think one of the things that drives me crazy about live coding for music is that often you'll see someone giving a performance and they will paste a bunch of numbers that represent some kind of beat or rhythm. And I hate that because like that's not musical to me. There's a better way to input a beat or a rhythm into the computer. And that's one of the things that I liked about Paul, actually. When I was reading your submission, there was something about mixing like recordings and all of that stuff. It seemed like you don't have to do that. And I think, like, I guess the point that I'm trying to make is that I'd rather use my brain cells to fight things that are hard rather than fighting the tool that I'm using.
Ooh, I really like that.
Yeah.
Let's leave that there then. That was a great summation. Thank you.
I think I should
June,
take the
please.
third one. So the third dot, why do tools for thought people tend to make a novel programming environment, or the other way around? Why are such programming environments often invented by those who make creativity support tools? This is kind of question that arises throughout the day. Like, some of you are coming from the programming language field, and other people are coming from, like, artistic field. In my case, I started my career as a HCA researcher working on programming environments, and then gradually these days, I'm shifting my focus to more artistic practices, like helping animation directors. And in Peter's case, probably he started from the other way around, or I'm not sure. I mean, but the point is, these days, it seems like people who are interested in helping people's creativity tends to create something programmable or malleable or customizable by the end user or by programmers. How do you, as a community of people gathering at live, how do you see these creative activities versus programming activities? Please.
Yeah, as I guess, a self-described Tools for Thought interested person, I actually run an online monthly meetup called Tools for Thought Rocks, and I'm working on a novel programming environment, so I guess I'm the target audience for the question. But there's a really great post by a guy named Linus Lee, and I'll give you the post title, and it really tells you what you need to, what the point here, which is build tools around workflows, not workflows around tools. And I think the answer here about, like, why do we continue to build customizable environments is because the way that we all have very different ways of working and ways of thinking. And when we want to use our tools to help us, like, assist us in our work and our thinking, our workflows all look subtly different. And yet all of the tools that we adopt nowadays, when you have SaaS tools that are available for us, they encode a very specific workflow. And then you are required to adapt yourself to that workflow. And what we should be doing instead is be thinking about, what is the workflow that I personally want? How do I plan to, like, accomplish this task? And then we should be able to wrap tools around that. And right now it's backwards.
Yeah, one thought that came to mind when watching the presentation, the second last presentation, where they built this, like, state debugging environment, was this felt very similar to like, if you've worked with React and Redux, there's a Redux browser extension that allows you to rewind your events and replay them, and thinking, like, oh, could they have done that project, but instead, say, forked that browser extension and made it, like, render different paths of events within that browser extension and like, achieve the same kind of goal, but then had an outcome where it's a tool that, like, oh, maybe it works, and, like, almost every developer in the world can install it and start to use it. And it makes me, and so I don't know the answer to the question, but it makes me think, like, there's so many cool projects that come out of these, like, communities and ideas, but they often, like, fail to connect with those real world kind of environments and fail to scale and sustain themselves in that way. And like, the example of this presentation felt like it also, like, brought up the same question for me, yeah.
My brother is a really good software engineer. Like, he built half of the cargo tool for Rust. He's insanely talented. And I was talking with him about his dev tool setup. Because for me, Tools for Thought is think about it as dev tools. I was like, oh, which Rust language server do you use? He's like, what? What do you mean? No, like, how do you jump to definition? I grep. I was like, what? We have such good tools that do this instantaneously. Why don't you just use them? I know grep. What else would I need? Right, and I think that,
Just a note for people here, if you're developing in the front end, there are log points in the Chrome debugger. You don't need to put console.logs and refresh. You can just right-click on the line of code and make it a log point. You don't need to pause execution. It's just, that's a pro tip.
Thank you. And I feel like there's something deep there I think about all the time, which is knowing one tool that works everywhere and knowing it extremely well is such a valuable thing, because you can learn it very deeply, you never have to, you can apply it in every environment. In the case of grep, right, anything that's text representable is greppable, whereas the Rust language server only works with Rust, and many of the live programming environments we've seen today only work for a very specific niche. And I think that's something that's very hard to talk about and to balance against. And all the other concerns, right? Every tool you adopt, there's the learning curve of the tool, there's all the things you have to deal with every time the version breaks, and it doesn't work with your other tools, and it has to work on your operating system, and maybe it's research software, so it sucks in a ton of ways. And I think people in practice just like, they so are biased against that trade-off. They would rather use a small set of tools that consistently work, and it's difficult to make, or I think as people who want to make tools for thought, to balance against that. I've never really found a good way to work around it, but I think it's a really critical trade-off that we often don't discuss enough.
Universality versus domain specificity, is that how you would describe that trade-off?
Yeah, I think that's
okay.
part of it.
Go ahead.
I think there's an interesting related problem that I was reminded of by the Unix grep example, which is that often each live programming tool imagines its own world and doesn't have a story for how it would compose with other live programming tools, which is different from textual programming, tends to have a stronger starting point for that. I would highly recommend, there's this work called Live Rich Composable by Josh Horwitz and Jeff Here. I think it was not presented at Live, I think it was at Plateau or something, but they imagined some primitives for composing live programming tools together, and I think that's a really interesting direction for this community to be thinking about if we want all of these ideas to ever be real and to be out there and working together in any way.
Also check out Polytope by Elliot Evans. You may have heard of it, but it's this really, I think it's a similar idea. It's a really novel and like genius way of combining different programming language environments, different editors together. It's Polytope. I'll post a link in the Discord. He's also a really nice guy, so yeah.
Just a note, Clemens grad student, what's his name? The knowledge work paper? Yes, Midas Nouwen's paper on how basically we have it good. We're the lucky ones. We can pick our IDEs. I don't get forced to use Vim or Emacs when I join a company because the founder picked Vim or Emacs. I can choose my own editor, but if you're a writer or a journalist, you go to an organization and you use the CMS that the understaffed IT team set up 5 years ago before they got laid off in the last round of layoffs, and now you have to use it and nobody likes it. At least we can pick our tools. We should give that courtesy to our colleagues who don't have the same power that we have over the computers.
So I feel like I'm not allowed to disagree with what was just said. But as an idealist, I don't like hearing these kinds of point of view, because what happens is this. You say, well, it's really important that we enable these tools to work together so that they can integrate and things can be real. And Alan Kay once said that reality is a low-pass filter, and he's very right. And so I worry that if we focus too much on practicalities, like what we're just talking about, and we achieve this goal of like widespread use, we are not going to understand what we have given up. And so I think that in conjunction with the work that is being suggested right now, I also want to urge people to do this kind of blue sky, let's reject the way everything works right now, and let's do something completely novel that does not have an interaction story with the rest of the world, so that we can see what purity looks like, even if it's completely impractical. At least we'll know some, like, I believe in extremes, I guess, and then we can do a better job of the middle ground.
As a community, we can do both, and we must. If we just have wild ideas and never ship them, then only those of us in this room will ever know. And if we never have any good ideas, then we will stay in the same miserable hole we've dug ourselves.
Can I just add to that?
Yeah.
And then I'll shut up. So I think about the things that I make, I think of it like a fashion show, where
I love that.
Yeah, so like cell pond is like something you put down a catwalk. I'm not going to sell it in stores. Like, no one wear it, please. It's designed not to be worn in the real world. It's designed to move fashion forward. And there are some tools that are not supposed to be for the catwalk. They're supposed to be like, hey, you know, we took some ideas from the latest fashion show, and you can wear it for real now. So I would encourage you to know what your tool is. Is it something on the catwalk, or is it something, you know, for the supermarket?
This is a great analogy. Thank you. I see. Should we give Xavier the last word? We have one more theme, and we're already kind of over time.
I just have one thing to say is like, you were talking about what's going to be at Live next year. I would love to see, you know, you were talking about let's be idealistic. I would love to see people do things in the live programming environment that are much, much lower level than what we're seeing. Like, what if you decided to build a new computer infrastructure on FPGA with this idea of live programming in mind, or something like this? Like, I think that would be very interesting.
Thank you for an excellent transition to our closing subject, which is next year is Live 10. We hope you'll all be in, do we know what city it's in? Does anybody know? Pasadena, California. So come on down, y'all. So, okay, you want to see an FPGA-backed live programming system. That's awesome. What else do people want to see? And a couple of things that I might suggest. One is, can you nominate a system that you didn't work on that you would love to see here? Because I think it's easy to promote your own work, but when you think about stuff that isn't in this room, who should we be encouraging to submit? The other thing is, if you've been coming to this session for a while, are there ideas that are still rolling around in your head, a talk you saw 5 years ago that we can email the authors of and like ask them to resubmit? Similarly, are there things, like June, you were telling me about instrumental interactions?
Yes, Michel.
Yeah, from Michel.
Michel Flora from La Fonte.
What he said. But that's like how search and replace works now. And when he wrote that paper, it was not. So, you know, like we can change things. You know, sometimes we do. Are there other things that maybe came from this room and are out there in the world now? Or vice versa, are there things out there in the world beyond the sort of academic practice where we can point at it and say like, yeah, this is a good idea. We should think about this in this room too. Mariano has a thing.
I will do a bad trick and answer the two questions in one thing, but I think they're related. I think I interpreted the last one a little bit wrong, but I noticed a pattern. I think all demos today were web browser based and JavaScript based. And that kind of answers why the tools of thought people do their own stuff is because there's nothing other than JavaScript and Markdown that can be used to create live environments. Also, I think like Markdown and text as like at the upper bound of complexity of the problem makes it easy to create your own tools. You don't have to create like Haskell or whatever. But like related to the current one, like why is it the case that we have to, if we are so far like experimental, and I'm pro JavaScript by the way, but we are forced to use JavaScript, and I like it. But
we're not.
And why the pattern of everybody using JavaScript? But if we have to, like either the question is, can we use something else? Can we improve something else? Or if not, if JavaScript is the best way, can we like try to move it towards more features that we can use to build better live environments? Can we like try to steer industry into adding features or improving or whatever? Or if not, do we have to create a new one from the ground up? Do we modernize Smalltalk? Do we like, I don't know. Please answer that question. Next year.
I'm looking for hands. Do people have, Zafir has a...
I won't answer it.
Yeah.
You can do what I did, which is use Rust, but I don't know if it's a much better solution.
The Rustaceans are here. I will also point out this is kind of, we have a bias in this room towards web development. There's a massive industry which does more money every year in revenue than I think probably all the productivity tools combined, and that's game development. And there's a lot of live programming kinds of practices and patterns in that community that were not represented at all today. So if you know folks who work in that side of the house, they should be here.
I have a request for more ethnography. And what I mean by that is, how are people using real systems in the real world and what is missing and that kind of stuff. Like, bring to this room the gaps that we should be filling, because a lot of times we spend time in our own little bubbles and we're not aware of there's this significant group of users, and here's how they are accomplishing their computational tool needs. And let me talk about some of the gaps.
Yeah, I know Clemens has some grad students, or has had grad students working in that space. You can tell them to submit.
I'm going to do some wish casting, and this is related to Lou's fashion show idea. But I would like to see somebody demo a kind of programming that does not look recognizable as programming. I think Lou's talk this morning was close to that, and I would just like to see more of that stuff, because it motivates a kind of an approach to this space that to me does not feel incremental. It feels like a wholly different kind of thing. And so if we found some of that, that would make me personally very happy.
All right, should we wrap it here, Jen?
Yeah.
All right. Send us these submissions, please, for next year. This will be a great workshop if you go out and write papers about these things. You have a whole year if you start now. So we'll look forward to madly put together abstracts in 9 months. You'll have some time to finish the paper after the submission. Yeah, I mean, thanks for coming, everybody. And thanks, Jun. Jun did most of the organizing, and I'm deeply grateful to him, because this would not be here without him and without Jonathan, who started this 9 sessions ago.
So yeah, I would say it's really a kind of complementary relationship where he's really good at structuring things and coming up with all these nice topics, like grouping talks and all these things. And whereas I am also enjoying this kind of organizing with him, and also I really kind of enjoyed having discussion with all of you. And yeah, in short, I kind of love this community where people love to build, but also love to kind of trying to understand what people are doing in this programming activities. And so yeah, thank you all.
This was a fun day. Thanks, everybody.
Thank you.
And thanks to anybody who caught this online or is watching the live stream. Submit your talks when you see the call for papers later. All right.
Yeah.